Project Multiple Access Computer, or MAC, launched in 1963, was a research project initiated at MIT. Project MAC was intended to develop a system which allowed multiple user access to a single computer at the same time. Nowadays, it's not a big deal, but in 1963, it was groundbreaking because at that time, we had a batch processing system where one user had to wait for their job to be completed before another could use the system. Project Mac went on to becoming a resounding success and played a key role in discovering the concept of virtualization. Although the meaning of virtualization kept evolving with the internet, certain terms such as remote access, virtualization, multi-user environments, and shared resources were deeply researched upon. Eventually, these concepts led to the birth of cloud computing. In the 20th century, the concept of cloud computing was a dream, a myth. But in the 21st century, our world revolves around it. A casual user uses almost 15 to 20 cloud-based applications every single day. WhatsApp, Instagram, Facebook, X, LinkedIn, Gmail, Paytm, you name it. Now, because of the increased spending in the public cloud services, India's public cloud spending has the potential to expand at a CAGR of 27% by 2026. Now imagine the state of the jobs within the cloud market. And if we talk about India, 10% of the total jobs are going to be related to cloud. Now that is because cloud is one such sector from where the majority of the hiring demand comes from. So to sum up, cloud computing has become a necessary skill for the future. And that's why we have brought you this cloud computing full course. We'll cover all the important concepts such as cloud service models, deployment models, virtualization, databases, networking, serverless computing, the CI/CD pipeline, basically everything you need to know in order to kickstart your cloud computing journey. Throughout this course, we'll be focused on AWS. You're free to go with any platform that you would prefer. But since AWS is the leading market player, we decided to go with AWS. But don't worry, regardless of the cloud platform you choose, the concepts are going to remain the same. So, now that all of that is cleared, let's take a closer look at what we'll be covering in this particular video.
Let me walk you through the agenda for this course quickly. So first things first, we will begin with understanding what exactly is cloud computing and why it is gaining so much of attention. I'll also see how it's different from traditional setups as well. Then we will dive deeper into the cloud deployment models, where we will see public, private, hybrid, and even multi-cloud strategy models. And then we'll move forward with the service models, where we will understand infrastructure as a service, platform as a service, software as a service, and even function as a service, as these are the building blocks that you need to understand for understanding the fundamentals of the cloud. Next, we will move towards understanding the largest and the most dominant cloud provider in the market, that is AWS. Here you will master EC2, that is Elastic Compute Cloud, to launch and configure virtual servers, and also learn how to create custom AMIs, that is Amazon Machine Images, to streamline your setup. Then we will also cover securing your EC2 instances by configuring security groups and explore the auto-scaling and load balancing to handle the dynamic traffic loads with ease. Next, we will get hands-on with IAM, that is Identity and Access Management, where we will understand how to manage users and assign the roles securely. We will also work with Amazon S3, setting up the buckets, configuring permissions, and managing the storage effectively. Finally, we will put it all into the practice by building a live static website on AWS, from setting up the S3 bucket to configuring the permissions and applying lifecycle rules. You will gain practical real-world experience with the cloud solutions, as this is more than just theory. It's a hands-on journey to mastering the cloud computing with AWS.
So, now that you know what's in store for you, without further ado, let's get started.
Alright, so let's begin with a question. When was the last time you actually bought a DVD to watch a movie or carried a USB drive just to store your files? Come on, think about it. Alright, let me answer this for you. Probably a while ago, right? And why is that? Well, nowadays we simply stream movies on platforms like Netflix or Amazon Prime, where there is no need to download files or worry about running out of space. Just one click and boom, instant entertainment whenever you want, wherever you want. And it's the same with storing files as well. We just save the files over the Google Drive or Dropbox, where there is no need to panic over losing that USB or carrying extra devices around. Everything is just there whenever you need it. Now here's the fun part. This is what cloud computing looks in the action. and you have already been using the cloud in your day-to-day life without even realizing it. Like through the movies you stream, the files you save online, all of it is powered by cloud technology working silently into the background. Okay, let's make it even simpler with another example. So, think about how you listen to your favorite music nowadays. Do you still keep a giant collection of CDs or download every song onto your phone? Nope. Right. Chances are you just open your favorite music streaming app such as Spotify, Apple Music or YouTube, tap on the song you want and voila. Just instant music anywhere, anytime without worrying about storage or device space. Now, why am I talking about music and movies? Because that's exactly what cloud computing does for businesses and individuals as well. But instead of streaming songs or movies, you are getting instant access to the computing power, storage, software and much more all on your demand. Now imagine if a business had to buy and maintain massive servers and hardware for every little task. It is expensive, right? Not to mention the time and effort to manage it all. But with cloud computing, they don't have to do such a hassle. They can just rent what they need, like how you stream a song without buying the whole album. There is no maintenance worries or bulky equipments, right? Just instant access to the powerful resources whenever you need them. Now that is pretty cool. Cloud computing is like having a magical toolbox that's always stocked up with exactly what you need, without you ever having to carry it around. Now that we have seen how familiar these cloud-powered services already are into the day-to-day lives, let's dive into what cloud computing really is and why it is becoming such a game changer for businesses, startups, and individuals alike. So let's move forward with understanding what exactly is cloud computing. By the formal definition of the cloud computing, it is the delivery of on-demand computing services and resources like storage, computing power, networking, security, and more via the internet. And it operates on a pay-as-you-go basis. But what does that mean in simpler terms? For that, think of it this way. Normally, when you store your photos, documents, or apps, you save them on your computer or a local device, right? Or maybe you use external hard drives or USB sticks to keep them safe. Well, cloud computing flips that. Instead of storing all your stuff on a physical device that you own, you can save it on the internet. It acts like a virtual storage space that's available anywhere and anytime on demand. Now here's the cool part. Just like you don't need to own the movies or music you stream on Netflix or Spotify, you don't need to own all the equipment or servers to store or process data with cloud computing. Here you can just rent these resources whenever you need them and actually only pay for what you use. Think of it like a subscription to power up your business or personal projects without the need for huge upfront costs. Now let's take a look at the diagram of cloud architecture. This will show you how cloud computing services are structured. You will see how different elements work together to provide computing resources in a seamless and a scalable way. In the cloud, there are several key components. First is clients. As you can see, this end line over here, it is even written and users. These are the users or devices accessing the cloud services like from your laptop, mobile phones or from the desktops as well. Then comes this internet highway. This is the highway that connects everything, allowing you to access the cloud anytime and anywhere with unstable internet connection. Then comes the cloud service layer. This is where all the computing resources are live, such as storage, servers, networks and security tools and many more things, which is provided by the cloud service providers, by the companies like AWS, GCP, Microsoft Azure that manage the cloud infrastructure and provides the resources. So this was it for the cloud computing architecture diagram. So yeah, with cloud computing, the internet becomes like your personal virtual space where you can store, process and access anything you need without ever worrying about managing the hardware yourself. It's like renting a super powerful computer that's always ready to serve you. But wait, how does this all actually work? Why is everyone from fresh startups to the biggest tech giants moving to the cloud? And what makes it such a game changer for businesses? Well, that's exactly what we are going to break down in the coming topics. Let's start by looking at how things used to be done before cloud became a thing. In the past, businesses had to do it really hard way. Let's say you start a company. The first thing you would need to buy is tons of expensive servers and hardwares. And not just that, you would need to constantly maintain and upgrade these servers to make sure everything is running smoothly, which could really be an headache. And then you can launch your product successfully into the market. Now imagine your product gains the traction and more people are starting using it. Great, isn't it? But here's the problem. As the product grows, so does the databases. And more data means more servers. So what's next? The company has to spend even more money buying extra servers to keep up with the demand of the traffic. But here's the catch. As you add more servers, the risk of server crashing also increases, especially if the traffic spikes suddenly. So now you got a big problem. Your servers are overloaded and when they break down, you can't just wait around and sit there, right? To get things back on the track, you need a maintenance team to fix everything, to patch the servers and make sure nothing crashes again and everything works just fine. But this sounds expensive, doesn't it? Not to mention it's incredibly time consuming. You need to have experts available around the clock to keep those servers running. And this process could take days or even weeks to fix every time. Imagine how much time and money gets wasted in this process. Now, there comes another scenario. Let's say the traffic slows down over the time. The extra servers you bought earlier, well, what about them? Now they are just sitting there wasting resources. But here's the kicker. You still have to maintain them regularly, which means extra charges for something you're not even using fully. This is the classic problem businesses used to face. Spending money on servers they didn't need or use all the time, but still they had to maintain them. So, to sum up the traditional setup, businesses and companies had to buy, maintain and upgrade expensive physical servers, which comes along with huge costs for expensive hardware and software, maintenance and IT teams, offering limited flexibility as upgrading as per the traffic spike means buying new hardware every time, which is a time-consuming approach as setting up and updating servers might take weeks or even months sometimes. The result? A lot of wasted time and money for businesses just to keep things running. And that's exactly where cloud computing steps in. Imagine starting a business today. Would you rather spend thousands of dollars buying servers and hiring teams to manage and maintain them? Or would you prefer to just rent the services and resources as you need on demand and only pay for what you actually use? Sounds pretty simple yet super efficient, isn't it? Well, that's the power of the cloud. With cloud computing, you don't need to worry about cost and hassle of owning and managing hardwares like servers. You just rent exactly what you need from a cloud provider whenever you need it and on a pay-as-you-go basis. So what makes the cloud such a game changer for businesses? Here's why. It makes them more agile, cost-efficient and scalable by providing a pay-as-you-go model where they don't need to invest huge upfront investments. They can only pay for what they actually use. It provides scalability and flexibility as well, where there is no need for more resources. The cloud scales up or down instantly based on the demand. It is also fast and efficient, as forget waiting weeks to set up your hardware. With the cloud, resources are deployed within the minutes, not even months. It also provides remote access and security. You can access your data from anywhere and have top-tier security without any kind of hassle. Where you also no need to worry about server crashes. The cloud ensures your data is backed up and properly secure. In a nutshell, the cloud gives businesses the ability to be more agile, cost-efficient and scalable without getting bogged down in expensive or time-consuming IT infrastructure management. Now, instead of worrying about servers, businesses can focus on building better products and serving their customers right. So that was it. The cloud is changing the game by giving businesses exactly what they need when they need and at a fraction of the cost of maintaining the physical servers. Alright, now that we have understood what cloud is, the next big question comes is, how do companies actually use the cloud? What are their options based on their needs and why does IT infrastructure even matters? In today's world, every business relies on technology to run efficiently and having the right IT infrastructure is crucial. as it ensures things like scalability, security, and performance are spot on. But every organization needs are different. They choose the infrastructure based on the cost, flexibility, and the level of control they need. So let's break down the three main types of cloud infrastructure. First is on-premises infrastructure, second is cloud infrastructure, and third is hybrid cloud infrastructure. Let's start with on-premises infrastructure. Here, imagine you're owning a house where you're responsible for everything, the roof, the plumbing, and even deciding when to redecorate or renovate it. In the world of IT, that's what on-premises infrastructure looks like. Here, the company owns and manages all of its servers and IT resources in-house, meaning they have total control but also the full responsibility to maintain and make sure everything is running smoothly and efficiently. So now, what are the key features of on-premise infrastructure? The first one is, it provides the full control over the infrastructure, where you can make all the decisions about how your system runs. Second is, it provides high security and compliance, which is perfect for industries dealing with the sensitive data like banks or hospitals, where privacy is non-negotiable. But it also has some downsides, as it comes with huge upfront expenses. Buying hardware is expensive, and it doesn't stop there. Maintenance and upgrades are other ongoing expenses as well. It also comes with limited flexibility and scalability. If you need more capacity, that means you have to buy and set up more hardware, which can take time and can come with huge expenses as well. So when to use on-premises infrastructure? When your business requires complete control, a strict security, and you are prepared to handle the expenses involved in managing everything yourself. Now the next thing is cloud infrastructure. For this, picture using a ride-sharing app like Uber. You don't own the car, but you still get to decide where to go, in which car to go. That's essentially what cloud computing is. You can rent computing resources such as storage, processing power, databases, etc. over the internet and only pay for what you actually use, which is already provided and managed by the cloud service provider itself. So what are the key features of the cloud infrastructure? The first is, there is no hardware ownership or maintenance hassle. Forget about buying, maintaining or fixing servers. Here, everything is managed by the cloud service provider itself. Second is, it is scalable and cost efficient. You can easily scale up or down without any large initial investments. It is also fast and accessible, as you can deploy services and resources quickly and access them from anywhere, anytime. But the trade-off, it gives you very less control over the infrastructure. As the cloud service provider manages the infrastructure, you don't have much control in how things are actually running. So when you should go with the cloud? When you need quick scalability, lower costs, and want to avoid the headache of hardware and maintenance, cloud is the best option to go with. And finally, we have hybrid cloud infrastructure. In simple terms, let's take an example. Imagine you take a subway for most of your daily travel. But for places the train doesn't go, you drive your own car. That's what hybrid cloud is about. It combines on-premise systems with cloud resources as well. So you get best of both the worlds. Now what are the key features of hybrid cloud? Well, the first is, it gives you control as well as flexibility, which is considered as best of both the worlds, where you can keep the sensitive data secure in the in-house while enjoying the scalability of the cloud. Second is, it provides cost optimization, where you can use the cloud for the things where it is cheaper but keep the critical systems on premises. It also allows you for gradual cloud adoption, where you can move to the cloud gradually without a full commitment initially. But the challenge here is complexity, as managing both on-premises and cloud systems can get tricky and may require extra resources and a hardcore experts handling it. So when to use hybrid cloud? When you need a balance of security and flexibility without fully committing to the cloud, this is the best option in this case. So as we have seen, each of these infrastructure types has its own pros and cons. Now let's take a look at the quick comparison of the types of IT infrastructures we just seen through a comparison table. So the first feature, that is ownership. On the on-premises, you own and control everything, which provides full control but with high responsibility. For the cloud computing infrastructure, it is managed by the cloud service provider itself, While in the hybrid, which provides mix of both, here you can control critical data on premises while leveraging the cloud benefits as well. Coming to the second point, that is cost model. On the on-premises, you have to pay high upfront investments for the hardwares and infrastructure. But with the cloud infrastructure, it provides you with pay-as-you-go model, where you can only pay for what you actually use, making it very cost-effective. Coming to the third, that is hybrid cloud infrastructure, it provides you optimized costs because it balances between capital and operational expenses as of both on-premises and cloud. Coming to the third point, that is scalability. On-premises provides you with limited scalability as it requires buying more hardware if required. Coming to the cloud infrastructure. Here, it is highly scalable as it gives you option where you want to expand or shrink resources as per the need. Coming to the hybrid cloud infrastructure. The scalability here is balanced as you can scale up with the cloud while keeping the core system stable on the on-premises. Coming to the fourth point, that is security. On-premises provides you with high security as there is full control over the security measures as everything is handled in-house. But coming to the cloud providers or cloud computing infrastructure, here everything depends on the provider as security is shared but it is robust. Now coming to the hybrid cloud infrastructure, the security here is flexible as you can secure sensitive data on premises and use cloud resources for less critical workloads. Now coming to the fifth point, that is maintenance. On the on-premises, it requires an in-house IT team for upkeep and updates, while in the cloud infrastructure, there is no maintenance on your end. The provider handles all of it very well. Now coming to the hybrid cloud infrastructure, the maintenance is partial because you can manage on-premises components while the cloud stays managed by the service provider itself. And coming to the last point, that is deployment speed. On-premises are pretty slow while cloud infrastructure is comparatively fast, while in hybrid cloud infrastructure, everything is moderate. So that's the comparison. Pick what suits your control, cost and scalability needs the best. Now that we have seen, while there are different cloud models that we have just studied, the cloud offers huge benefits for businesses, making operations smoother and faster and more cost-effective. So let's break down the top benefits of cloud computing, as this is what makes it a powerful tool for modern businesses. With the key benefits like, first is cost efficiency. Cloud computing saves businesses money in several ways. Here you can rent resources. No need to buy expensive hardwares. And you can just rent what you need and when you need. Second is, it has very low operational costs, where cloud providers take care of hardware updates and maintenance, so you don't need to worry about any kind of costly IT teams or downtime. Third is, it provides you with pay-as-you-go model, where you can only pay for what you use, avoiding unnecessary expenses. This helps businesses control costs and scale up or down easily as needed. Now the second advantage is security and compliance. Cloud providers invest heavily in cybersecurity to keep your data safe and secure, as the encryption and compliance certificates ensure that your business meets all the necessary regulatory requirements, such as GDPR or HIPAA, etc. Second is, it provides you with MFA, that is multi-factor authentication, and regular security updates, helping you protect your data from breaches, keeping everything safe and secure. Now the third point is scalability. One of cloud's biggest advantages is scalability. It provides you with auto-scaling. The auto-scaling mechanism allows businesses to instantly increase or decrease computing resources, keeping the cost aligned with actual needs, where there is no need to predict any kind of traffic spikes in demand. Whether you are running an e-commerce site during a sale or streaming a platform during a new release, the cloud adjusts everything in real time. Now, the fourth advantage is performance speed. Cloud providers use globally distributed data centers, which means reduced latency. Data is processed closer to the user, speeding up the access. The second point is, the load balancing ensures smooth performance as the traffic is spread out efficiently, preventing slowdowns during high demand too. It also comes with edge computing advantage, which takes a further step by processing data near the user, improving users' response times even more. Coming to the fifth one, cloud computing is all about accessibility, where you can access work from anywhere on any device and as long as you have a stable internet connection. It also comes with collaboration tools like Google Docs and Microsoft 365, which enables the real-time teamwork, allowing users to work together regardless of the location. And the sixth one is disaster recovery. No one likes thinking about disasters, but the cloud helps mitigate risks of this kind too. It is powered by automatic backups, which ensures that your critical data is protected even if the system fails. It also provides replicating the data across multiple locations, keeping your data safe just in case of a failure at one site. So businesses can quickly recover without losing any kind of valuable information or data. It also helps businesses restore lost data within the minutes, minimizing the downtime and keeping the operations real smooth. While the cloud makes life much more easier, but it's not without challenges. Companies need to be mindful of certain risks and concerns before fully making the move. Let's look at some of the main challenges businesses face when it comes to the cloud, as it is very important to address these challenges to maximize efficiency and enhance the security. The first one is the constant internet connection requirement. Cloud services rely totally on a stable internet connection. If your internet goes down, you lose all your access to the critical systems as well as your data. This means your entire business operation could be at risk if the connection is interrupted, especially if you're working remotely. Now the second challenge is the downtime and reliability issues. Cloud providers, just like any other servers, can experience downtime. If the cloud provider faces downtime, your business might also face interruptions impacting productivity and customer experiences, which can lead to major damages and huge loss. For example, in 2021, AWS went down, disrupting their services and resources for major platforms like Netflix and Reddit. Coming to the third one, that is data security and privacy issues. Moving data to the cloud means trusting a third-party service provider to manage your security and authentication. If a data breach occurs, sensitive customer information could be exposed, as businesses must assess the provider's security measures to ensure that the data is handled properly and is secure on the platforms. The fourth one is complex pricing models. The cost of cloud services can fluctuate unpredictably if the usage isn't monitored closely and properly, where the companies might need to overpay for resources and services they don't need, especially if they don't track the usage regularly and properly. It's important to choose the right plan to avoid unexpected charges as well. Now coming to the last challenge that we have and is majorly talked about is vendor lock-in. So what is vendor lock-in? Let's first see that. So vendor lock-in is when you're totally relied and dependent on a single cloud service provider, that when it comes to migrating your systems or resources, it makes it difficult to switch to the another cloud service provider. So that is basically called as vendor lock-in. Here, moving data and services to the cloud often involves proprietary technologies that make it hard to switch providers later, as we discussed just now. It comes with high migration costs and compatibility issues that can prevent businesses from easily moving to a different cloud service provider if needed. This is a critical consideration when deciding on a cloud service vendor. So as we have seen, while the cloud comes and offers with huge and immense benefits, businesses must carefully consider these challenges as well before migrating. There are ways to mitigate risks, but understanding the trade-offs is must and crucial. Now that we know the advantages and challenges of cloud computing, the next step is diving into how businesses deploy their resources in the cloud. In the next module, we will explore cloud deployment models, what they are, how they work, and why they matter for your business, so your business can run efficiently, securely, and cost-effectively. Alright, let's dive in by understanding what cloud computing services are. In simple terms, cloud computing services are on-demand computing resources delivered over the internet. This includes servers, storage, databases, networking, software, and much more. These services allow users to access and manage computing power without the need to own or manage and maintain physical infrastructure. Think of it like renting tools from a hardware store instead of buying them. That's exactly how cloud services work. These services allow users to access and manage computing power without the need to own or maintain or manage any kind of physical infrastructure. Think of it like renting tools from a hardware store instead of buying them. That's exactly how cloud services work. But wait, even these services are categorized into two main models. These cloud models are basically different business models adopted by a cloud service provider. They operate on two main models. That is, first deployment models and second is server models. First, we will explore the deployment models as well. So what are the deployment models in the cloud? A deployment model basically defines the cloud services you are consuming, who is responsible for managing them, your cloud architecture, the scalability of your computing resources, and the level of control and customization you can have over your infrastructure, and the services provided to you versus how much you own of the infrastructure. In other words, it's like choosing the type of housing you want. Do you want to rent it, own it, or share your space with someone? That's how exactly cloud deployment models work, defining how you can access and manage your resources. Based on this, there are four major types of cloud deployment models. First is public cloud, second is private cloud, third is hybrid cloud, and fourth is multi-cloud. So, to make it easier, let's compare choosing a cloud deployment model to choosing a ride. When you pick a ride, you think about cost, control, and convenience, just like selecting a cloud model. Public cloud is like taking a bus, which is accessible for everyone, is cost-effective, but offers shared resources. While the private cloud is like owning a private car. It's exclusive only for you. It gives you full control and high security, but it comes with higher expenses as well. While the hybrid cloud is like using a taxi, which offers privacy and flexibility without the burden of full ownership. See how relatable that is. Now let's explore these models one by one, starting with the public cloud first. So what is public cloud? A public cloud is a cloud computing model where the third-party providers offer computing resources and services over the internet, which is shared among multiple organizations at once. For that, imagine using a gym. You get to access all the equipments there, but you share it with others as well, right? That's how public cloud works. Shared resources at an affordable price. So what are the key features of public cloud? First is scalability. Here you can dynamically scale resources based on the demand. Second is it is cost effective. There is no upfront hardware costs. You can only pay for what you actually use. Third is accessibility. You can access services from anywhere with a stable internet connection. Fourth is managed services. The provider handles the complete infrastructure, updates and maintenance. So you don't have to worry about any of the technical side. But yeah, there are certain challenges that you need to address. First is security and compliance risks. Shared resources and environments may introduce certain vulnerabilities as well as risks. Second is limited customization, which means it gives you very less control compared to the private clouds. The third is potential downtime. Here you have to rely on the provider's reliability, which may occasionally lead to the service interruptions leading to the downtime. Now what are the common use cases of public cloud? Well, it is best for hosting websites. Think of platforms like WordPress or Shopify, just like them. The second is, it works great for big data analytics, where you need to process large data sets quickly. Third is cloud storage and backups, which works like Google Drive or Dropbox, but in an efficient and scalable way. Now the fourth is running AI and machine learning models efficiently. Here it provides you with a lot of options and features where you can run and manage your machine learning models very efficiently, and they are also secure. So, the public cloud is great for the businesses that prioritize cost efficiency and scalability, but are okay with sharing resources. Now that we have explored the public cloud, let's see and talk about the private cloud, the more exclusive option in the cloud world. Imagine having your own private car. You control where it goes, how fast it drives, and who gets in. Sure, but it's more expensive than public transport, right? But you get the privacy, comfort, and full control over your car. That's exactly what a private cloud offers for the businesses. So, a private cloud is a cloud computing model where the computing resources and services are dedicated to a single organization. Unlike the public cloud, these resources aren't shared with anyone else. These private environments can be hosted on premises like within the organization's own data center or can be managed by a third-party provider but still dedicated exclusively for a single organization. This model is ideal for the businesses that need strict security, compliance, and control over their infrastructure. So what are the key features of private cloud now? Well, the exclusive use. Resources here are reserved solely for one single organization, ensuring maximum privacy. The second is enhanced security. Organizations have greater control over the data and privacy compliances, making it ideal for the sensitive industries like healthcare, banking, and finances. Third one is customization. Here you can tailor the infrastructure to meet specific business goals and needs, something that's limited in the public cloud environments. But in the private cloud, you get the full customization option. Now the fourth is consistent performance. Since there's no resource sharing, you avoid the slowdowns or downtimes and get predictable, reliable performance. But again, it comes with huge upfront costs. So let's address the challenges of private cloud. While the private cloud offers huge and significant benefits, it comes with few challenges as well. The first is higher expenses. Building and maintaining a private cloud requires a significant upfront investment as well, from buying hardware to hiring a skilled IT staff. Thus, it comes with huge expenses. Second is complex management. Here, you will need in-house expertise or third-party management to handle the infrastructure. It's not like just set it and forget it. You have to manage and implement each and everything efficiently and seamlessly. The third is scalability limitations. Unlike the public cloud, scaling a private cloud often means physically adding more hardwares, which again comes to on-premises, taking your money and time. So when does it make sense to use a private cloud? Well, for the organizations with strict security and compliance requirements, such as healthcare, finance, government sectors, where data privacy is non-negotiable, or businesses needing customized infrastructure solutions, where they want tailored environments for unique business needs. And the third one is enterprises, where the requirement is for high-performance computing without any kind of shared resources. This is ideal for workloads like scientific simulations, financial modeling, or big data analytics, without the risks of any kind of shared resources. So, this was for the private cloud. It gives you privacy and control, but it again comes with higher expenses and management responsibilities. But what if you could get best of both the worlds? That is, cost effectiveness of the public cloud and the security of a private one. Exactly. That's where hybrid cloud steps in. So let's see what hybrid cloud is. We have looked at the public cloud like taking a bus, affordable but shared resources. Then the private cloud like owning a car, private but costly. But what if you could combine both? Imagine using a public transport for daily travel, but driving your own car for special occasions or private trips. You get the cost savings of the bus and the privacy of your car. Adds best of both worlds again, right? That's exactly what the hybrid cloud offers. But what is hybrid cloud? Hybrid cloud combines both public and private cloud environments, allowing data and applications to move between them seamlessly, which provides better flexibility, scalability, and security. Why is that useful? Well, sometimes you need extra resources for certain workload spikes. That's when you can tap into the public cloud. But for the other times, when you need a strict security and control, that's when you can use the private cloud. It's all about flexibility and smart resource management. So, let's see the key features of hybrid cloud. First is, it provides flexibility. Here you can run sensitive workloads in the private cloud and less critical ones in the public cloud, where you can choose what works best for each situation individually. The second one is scalability. The need for extra power during peak seasons, right? Now, expand resources instantly using the public cloud without any investment in more hardwares. The third one is security and compliance needs, where you can keep the sensitive data secure in the private cloud while enjoying the public cloud scalability for non-sensitive tasks, which is again cheaper than private cloud. The fourth one is cost optimization. Here you can avoid overspending by balancing the workloads, as you can use private infrastructure for the critical operations and public cloud for the variable demands. While the public and the private offers great benefits, and then comes the hybrid cloud, which is a perfect solution, but it does come with its own set of challenges. The first one is the complex management. Integrating two different environments means you will need to manage both and ensure they work together seamlessly and without any downtimes or any infrastructure complexity. Thus, it can be complex to manage both of it. The second is security risks. Moving data between the clouds. Well, that really requires a strong security measures to prevent data breaches or data leaks. And the third one is higher upfront costs. Managing both a private infrastructure and a public cloud can be expensive, especially if not optimized properly. As we have seen in one of the challenges, complex pricing. Remember? Yeah, exactly. This refers to that. Now, what are the common use cases of a hybrid cloud? So, when you should use a hybrid cloud? For the businesses needing data privacy and regulatory compliances, such as healthcare and finance sectors that also require cloud stability and scalability. Or for the companies with variable workloads, think of for e-commerce platforms where during holiday sales they need extra resources during peak times, but not around the year, like seasonal demand spikes. The third one is enterprises with on-premises infrastructure. The organizations that want cloud benefits without completely moving away from their existing on-premise setups. This is the best option to go with. Now, while the hybrid cloud offers best of the both worlds, that is flexibility, security, and cost optimization, but managing it can be tricky. But here's another interesting thought. What if you don't just stick to one cloud provider? What if you can use multiple cloud providers to avoid dependency and get the best features from each of it? While the hybrid cloud offers the best of the both worlds, providing you with flexibility, security, cost optimization, but managing it can be tricky and expensive. Here's another interesting thought. What if you didn't just stick to one cloud provider? What if you could use multiple cloud providers to avoid dependency and get the best features from each one of it? Yeah, that's exactly what the multi-cloud model is about. In the multi-cloud, you can just shop around and pick the best features from different cloud providers instead of sticking to one. It's like when you're shopping online, you might buy electronics from the Amazon, clothes from the Flipkart, and groceries from the Zepto. Why? Because you're looking for the best deal, quality, and convenience from different platforms. That's exactly what the multi-cloud approach is all about. The multi-cloud model involves using resources and services from multiple cloud providers like AWS, Azure, or Google Cloud Platform, that is GCP, simultaneously to optimize the performance, reduce dependency on a single cloud provider, and again enhance the resilience. Think of it like instead of putting all your eggs in one basket, you are spreading your workloads across different providers for better reliability and performance and easy access. So let's see the key features of multi-cloud. The first is, it comes with vendor independence. You remember I told you about the vendor lock-in and we have studied this concept into the challenges of cloud computing? Exactly. It gives you vendor independence, which means here you can avoid getting locked up into one provider's ecosystem. If one service becomes expensive or unreliable, you have got the alternatives as well. Here you no need for the high migration costs that comes with vendor lock-in as well. The second is best of breed services, which means here you can use different cloud service providers for the different multiple utilities. As you can use AWS for storage, GCP for AI tools, and Azure for enterprise solutions, getting the best each provider has to offer. The third one is resilience and redundancy. If one cloud goes down, others keep your services running, which means minimizing the downtime and reliability risks. The fourth one is optimized performance. It can help you deploy workloads on the cloud that best suits them. Need fast data processing? Choose the provider known for that. It's easy as that. So how does a multi-cloud environment actually works? Since this concept might seem new to you, let's break it down with a simple scenario. Imagine you run a global e-commerce platform. You use AWS to host your website for its scalability, Google Cloud manages your AI-driven product recommendations, and Azure handles financial transactions because of its strong compliance features. Yes, this is how it works. These services work together, ensuring your customer get the best experience without you being tied to a single cloud provider. So that is how it works. While multi-cloud has many perks, it's not all smooth sailing. It also has some challenges that need to be addressed. So, how does this actually work? Since this concept might seem new to you, let's break it down with a simple scenario. Imagine you're running a global e-commerce platform. You use AWS to host your website for its scalability, Google Cloud to manage your AI-driven product recommendations, and Azure to handle financial transactions because of its strong compliance features. This is exactly how it works. These services work together, ensuring your customers get the best experience without you being tied to a single cloud service provider, where organizations can distribute workloads across different cloud service providers, and the data and applications can interact across multiple cloud platforms as well. While the multi-cloud has so many perks, but it's not all smooth sailing. So the first challenge is complex management. Handling multiple cloud service providers means more dashboards, tools, and processes to manage and handle, which can be complex and tricky at times. The second is security risks. Different cloud service providers mean variety of security protocols, making it harder to maintain consistent protection as well. And the third one is integration issues. Ensuring a smooth communication between different cloud providers can be tricky and may need specialized tools and hardcore experts around you all the time. So, what are the common use cases and when you should use multi-cloud? For the enterprises needing high availability and disaster recovery, as if one cloud goes down, other clouds or other cloud service providers can keep things running smoothly and ensure everything is running just fine. The second is when you need cost optimization, where businesses pick best price services across clouds to save money. And the third one is businesses adopting to different cloud strength for different workloads. As we already discussed about this, you can use GCP for AI/ML projects, run databases on AWS, or handle enterprise applications on Azure. So now that we have explored how companies set up their cloud environments through different deployment models, let's quickly compare cloud deployment models with just enough context to make things crystal clear. Let's dive in. Alright, now that we have explored the different types of cloud deployment models, that is public, private, hybrid, and a multi-cloud strategy, let's bring these concepts to life with some real-world examples as well. Because, let's be honest, theory is great, but seeing actually how big companies use cloud deployment models in action, that's where the real learning happens, right? So, starting with the first, that is public cloud, let's take an example of Netflix here. Have you ever wondered how Netflix seamlessly streams your favorite shows to millions of the users across the world without any kind of buffering issues? Well, here's the secret. They use the public cloud, specifically speaking AWS, that is Amazon Web Services, to manage their massive streaming traffic, store terabytes of video data, and process big data analytics for the personalized recommendations. Since public cloud is fully managed by the provider and scales automatically, Netflix can focus on delivering an uninterrupted binge-watching experience while AWS handles the heavy weightlifting behind the scenes seamlessly. That was it for the public cloud. Now, what about industries where security is the number one priority? For example, take Bank of America. For an example, financial institutions handle sensitive customer data and they have to comply with the strict regulations as well. And that's why they use the private cloud, which gives them full control over their data, security, and infrastructure, while keeping it accessible only within their internal network. As this ensures that the customer data remains private and secure, meeting all the compliance requirements necessary for this. Now moving forward with the hybrid cloud model, have you heard about Lego? Yeah. Lego isn't just about colorful bricks anymore. It's also a tech-savvy company. To handle their operations efficiently, Lego uses a hybrid cloud approach as well. They store the sensitive data on premises for security and compliance reasons, while they use the public cloud, that is, Microsoft Azure, to scale their operations during high-demand seasons like Black Friday or holiday sales. This combination gives them the best of both the worlds, that is, security and flexibility on demand. Now, coming to the multi-cloud strategy, let's talk about Spotify here. Your go-to app for music streaming. Spotify uses the multi-cloud strategy relying on different cloud providers for different kind of tasks. For instance, they store the data on AWS while they also use Google Cloud for the AI-driven recommendations that suggest your next favorite song. Thus, by using multiple clouds, Spotify ensures high availability, cost optimization, and advanced analytics without being locked up into a single cloud provider. Efficient, isn't it? And there you have it. These real-world examples actually show how businesses use different kind of cloud deployment models to match their specific needs. Whether it's a global streaming service, a high-security financial institution, or a hybrid retail tech company, or even a data-driven music platform, cloud computing plays a crucial role in making all of this happen. So next time when you watch Netflix or shop online or even stream your favorite song, you will know there's some serious cloud stuff happening behind the scenes. Now let's quickly compare the cloud deployment models once again to make things crystal clear with the comparison table here. So coming to the first point, that is the ownership. In the public cloud, everything is owned and managed by the third-party providers like AWS or Azure, which is great when you don't want to manage the infrastructure. Coming to the private cloud, which is dedicated to a single organization, it is ideal for the companies needing full control. Now moving to the hybrid cloud, which is a mix of public and private clouds, is perfect when you need flexibility as well as security. While the multi-cloud approach, here it uses services from multiple providers, which helps avoid the vendor lock-in and provide you with optimized performance. Coming to the second point, that is scalability. In the public cloud, it scales easily to handle varying workloads, which is good for unpredictable demands. But in the private cloud, the scalability is limited, but it is best for stable and consistent workloads. While in the hybrid cloud, it offers you with the flexible scaling, as you can use the private cloud for the critical data and public cloud for the extra capacity you need. While in the multi-cloud, it provides you with high scalability across the multiple cloud providers, which is ideal for the global operations. Now coming to the third point, that is security. In public cloud, the security is of moderate level, which is sufficient for the general applications. While in the private cloud, it provides you with the high security, which is best for sensitive data and compliance needs. While in the hybrid cloud model, it provides you with the balanced security where you can control the sensitive data privately while you can also leverage the public resources on the public cloud. Coming to the multi-cloud approach, the security here varies depending on each provider and how the security is managed in it. Now coming to the fourth point, that is cost. In the public cloud, it provides you with the low cost option as it has the pay-as-you-go model which suits the startups and small businesses the best. While in the private cloud, it comes with high cost, which is actually worth it for the organizations prioritizing security and control both. But in the hybrid cloud, the cost is kind of balanced as it is more than public but less than a private cloud alone. While in the multi-cloud approach, the costs can vary according to the service provider you actually choose and the services to balance price and performance. Now coming to the fifth point, that is customization. In the public cloud, it provides you with a limited customization, while in the private cloud, it is highly customizable. Here you can also tailor it with your exact specification and requirements. While in the hybrid cloud, it provides you with a moderate level of customization, as here you can customize the private side while using the public for the general needs. But in the multi-cloud approach, the customization depends on the chosen providers that you have opted like AWS, Azure or GCP. Now, which cloud is best for which? The public cloud is best for the startups or web apps needing quick and affordable solutions, while the private cloud is best in case of enterprises handling sensitive data with strict regulations, where security cannot be compromised at all. Coming to the hybrid cloud, which is best for businesses seeking both security as well as the cloud flexibility. Now, the multi-cloud approach is best for the large companies optimizing costs and avoiding the reliance on a single cloud provider, which also helps you to avoid the vendor lock-in. Thus, here it is. Now that we have explored how companies set up their cloud environments through different deployment models, it's time to dive into how they use cloud services like storage, servers, and softwares. In the coming module, we will explore the cloud service models, that is, infrastructure as a service, platform as a service, software as a service, and even function as a service, and how they help businesses build, deploy, and manage the applications more efficiently and seamlessly. So, now that we have explored how companies set up the cloud environments through different deployment models, it's time to dive into how they use cloud services like storage, servers, and softwares efficiently. In this module, we will explore the cloud service models, that is, infrastructure as a service, platform as a service, and software as a service, and how they help businesses build, deploy, and manage applications more efficiently and smoothly. So let's begin by understanding what exactly are cloud service models. So according to the definition, cloud computing service models define the different levels of computing resources that cloud providers offer to businesses and individuals. In simple terms, they define the levels of computing resources that cloud providers actually offer. They answer the one big question: who manages what? How much is handled by the provider itself, and how much do you actually manage? But why do we even need these service models? Think about it. Every business has different technical needs. Some companies want full control, managing their servers and softwares. Others just want ready-to-use applications without the headache of maintenance. And that's where cloud service models comes to rescue. They provide different levels of control, flexibility, and convenience, so companies can actually choose what works best as per their needs. The major 4 cloud service models are: first is infrastructure as a service, second is platform as a service, third is software as a service, and fourth is function as a service. Now, to make things easier to understand, let's take a real-world analogy here. Imagine you are setting up your dream house, or in this case, your IT setup. Infrastructure as a service, think of it as renting an empty plot with the utilities. Here you can build the house your way, but the land and power supply are provided by a certain provider. While in the platform as a service, here think of it as renting a partially built house, where the walls and plumbing are already given to you. You just need to decorate and furnish it as per your needs. While in the software as a service model, think of it as booking a fully furnished Airbnb, where you can just walk in and start living. Now coming to the function as a service model, think of it as ordering room service in that Airbnb. You don't even need to worry about the kitchen. They deliver what you need when you need as per your demands. Now this was the simplest example to understand each one of the services. Now let's break this down with a relatable scenario. Imagine you're launching a new business. Now to start your business, you will need a website, a database to store the customer information, a secure network connection, a software to manage your daily operations. Now, how do you will set it up? Traditionally, you would have to buy expensive hardware, set up physical servers, install all the necessary softwares, and constantly maintain everything by yourself. And damn, sounds like a lot of work and money, right? But thanks to the cloud service models, you get to choose how much responsibility you handle versus how much the cloud service provider manages. It's like deciding between cooking at home, which gives you all effort and full control, or using a meal kit, where you require less effort but you don't have much control over it as well, or simply dining at a restaurant, minimal effort, sit back and just enjoy your food. You pick here based on how much effort and time you want to invest in it, and how quickly you need things up and running. So, here, instead of owning and managing everything, businesses can just rent IT resources from a cloud service provider based on their needs and specifications. So let's understand them in detail. Let's begin with the foundation model, that is, infrastructure as a service. Infrastructure as a service is like renting the land and utilities to build your own house. Here, you don't own the land. For example, that is the infrastructure here, but you actually build and manage the house, that is, apps or data in your infrastructure, the way you want and exactly as per your specifications and requirements. In technical terms, The provider supplies and manages the infrastructure components needed to run applications such as servers like your house foundation, storage like closets of your data, networking, the roads connecting everything in between, and the virtual machines for running your applications. Here you can manage everything else like installing software, setting up firewalls, and maintaining the system. So what are the key features of infrastructure as a service? The first is, it provides you with the compute resources where you can quickly create virtual machines for various workloads. Second is, it gives you storage options where you can easily scale the storage up or down as per your needs and requirements. The third is, it provides you with also the networking part where you can manage networks, load balancers, and firewalls to secure your connections. The fourth is, it comes with pay-as-you-go model, as you can pay only for what you use. No need for massive upfront investments as well. Even with all the benefits, infrastructure as a service isn't without hurdles. There are some challenges as well. The first one is management complexity. Here you will need technical expertise to configure and manage the infrastructure. The second is security concerns. While the provider secures the physical data centers, but you are actually responsible for protecting your apps and data. The third point is data transfer costs, as moving large amounts of data from on-premises to the cloud can come up with huge upfront expenses as well. Now, what are the common use cases of infrastructure as a service? It is best in case for the companies handling variable workloads like e-commerce sites during holiday sales, or businesses needing data and privacy compliances but still wanting cloud scalability, or the enterprises expanding their infrastructure without buying any kind of new hardware. And it is also the best option for the startups wanting a cost-effective way to test the new applications without any kind of major investments. Now that we have seen how infrastructure as a service provides the building blocks of your IT setup, what if you don't want to handle the entire construction yourself? What if you just want a ready-made platform to build and deploy applications seamlessly without any kind of worry about underlying hardware? And that's exactly Platform as Service steps in. Platform as a Service is a cloud computing model that provides a ready-made platform for developers where they can build, deploy, and manage web applications without any kind of worrying about underlying infrastructure like servers, storage, or networks. Think of it as a one-stop shop for all the app development, perfect for teams that want to focus on coding and innovation rather than the boring IT management stuff. So what are the key features of Platform as a Service? Well, the first one is, it provides you with the development tools. Here you have the access to frameworks, libraries, and tools to make the app development even more faster. Second is, it provides you with the managed kind of hosting. Here you no need to manage servers or worry about the maintenance. The platform handles it all efficiently and effectively. The third one is, it comes with integrated databases, where you can easily use built-in databases without any kind of complex setups or managements. The fourth one is, it again comes with pay-as-you-go model, where you only pay for what you use, saving a lot on operational costs as well. Even with all of the convenience, there are favorite things that you need to watch out for. And the first one is vendor lock-in. As switching providers later can be tricky once you are tied to one particular cloud service provider or one platform. The next is customization limits, as it gives you less control over the underlying infrastructure, which is great for simplicity but not always for the flexibility and scalability you want to implement. And the third one is security concerns. While the provider secures the platform, but you are also responsible for the app level security. Thus, there can be risks of data breaches and data leaks if not properly configured. Now, what are the use cases of Platform as a Service? Well, it is best in case of web and mobile app development purposes, where you can quickly build and deploy applications seamlessly. It is also best for API development and integration, as here you can create and manage APIs with even bare minimal effort. It also comes with database integrations, which is best in case of database management, where you can effortlessly set up databases to power your applications. So, with Platform as a Service, you can focus on your app and the provider takes care of all the techie backend stuff by themselves. Now, what if you don't even want to develop anything by yourself? You just need ready-to-use softwares like email services or project management tools. And that's where software as a service comes into the play. Here, you don't need to deal with infrastructure or development at all. Here you can use the software without worrying about how it runs. Think about it like streaming movies on Netflix. You don't need to download anything or manage servers or even update softwares. You just log in and enjoy it. And that's exactly what software as a service is all about. It is a cloud computing model that delivers ready-to-use software applications over the internet, often on a subscription basis, where there is no need to install any kind of softwares, no hardware requirements. You can access it anytime through a web browser. Here, the provider handles everything, infrastructure, maintenance, and updates. So you can just focus on using the software and doing your work. Now, what are the key features of software as a service? The first one is, there is no need of any kind of installations. You can access the softwares directly through your web browser. No downloads required. The second is, it gives you automatic updates. There is no need to manually update anything. The provider takes care of all of it. The third is, it comes with scalability. It can easily adjust to the usage based on users' numbers or needed features. And again, it comes with pay-as-you-go model, where you only have to pay for what you actually use, no hefty upfront costs required. And then again, while software as a service is super convenient, but there are certain challenges that you need to address. So the first one is the total dependence on internet connectivity, which means no internet equals to no access. A stable internet connection is a must requirement for you. A stable internet connection is a must requirement here. Now the second one is security concerns. Since the data is completely stored on the third-party servers, ensuring strong security measures is essential as well. And the third one is limited customization. Here you get a pre-packaged solution which might not fit every unique need or any kind of personal requirements or specification needed for your application or utility. Now, what are the common use cases where software as a service can be ideal? The first one is email and collaboration tools like Gmail, Microsoft Outlook, or even Microsoft 365. Now again, for the customer relationship management, tools like Salesforce or HubSpot, which helps to manage customer relationships. Now the third one is for the project management purposes, for the platforms like Trello, Asana, or Slack streamlined teamwork management tools. And the fourth one is accounting and financial softwares like QuickBooks Online, Xero for financial management, etc. So this was it for the software as a service. So with software as a service, it's like enjoying a ready-made meal you ordered from a restaurant, right? But the question is, what if you need to run the code without worrying about servers or infrastructure at all? But now, what if you need to run the code without worrying about any kind of servers or infrastructures at all? And here comes function as a service, the ultimate set it and forget it model. To understand this, imagine a simple scenario. You walk into the coffee shop, place your order and get your coffee and leave. You don't care about how the coffee machine works or how the beans were roasted. You just want your coffee quickly. That's it. And that's function as a service in a nutshell. Here, you only focus on the code and the provider handles the rest of the things in the backend. So let's see what is function as a service. It is a serverless cloud computing model where you can write small pieces of code called as functions that run in response to events like a website click, a file upload, or even an API request. Here, there's no need to manage any kind of servers. The code runs only when it is triggered. And you only pay for the actual execution time of the function and not for any kind of servers. And it automatically scales based on the demand. Think of it like a vending machine. For an event, you push a button. And then as a cloud provider, that is the machine, delivers your snack. That is running your function. Easy, right? Now this is how function as a service works. So what are the key features of function as a service? The first is, it's event-driven execution, where the function triggers when something happens like an HTTP request, a file upload, or even a database change. And it is completely serverless. Serverless, it doesn't mean that there are no servers here. They are there. You just don't need to manage them. The cloud provider handles all of it in the backend. It also provides automatic scaling, whether you got one request or a million requests. Function as a service scales automatically to handle the demands. It comes with pay-per-execution, which actually means here you only have to pay when your code actually runs and not a second more than that. The fifth key feature of this is it provides faster time to market where you can deploy your code quickly without worrying about any kind of infrastructure. But it comes with some challenges as well. The first is cold start latency. Now, if a function hasn't been used in a while, it might take a few extra seconds to start. This is what we call as cold start latency or a cold start. The second one is state management, which means the functions here are stateless, which means it makes it a little bit of tricky to manage the ongoing data across the executions. The third one is debugging and monitoring. Without traditional servers, troubleshooting can be a bit more challenging than it seems. So what are the common use cases for the function as a service? The first is it comes with microservices architecture, which means it makes it easier to break down large applications into smaller and manageable services. The second one is real-time file processing. Here you can automatically resize images when users upload them. The third one is API backend. You can handle the API requests on demand without any kind of dedicated servers in the real time. The fourth one is IoT event processing. Here you can trigger the functions based on the sensors or sensor data from the devices. So with function as a service, you just write the code, set the trigger, and the cloud takes care of all the backend and manages your function efficiently. Now that we have explored all the cloud service models, that is infrastructure as a service, platform as a service, software as a service, and even function as a service, let's simplify them with some quick context and relatable examples with a comparison table as well. So the first point is definition. For the infrastructure as a service, it provides virtual server, storage, and networking, which is ideal when you need raw infrastructure but want to avoid physical hardware, as in short term, it is a virtualized infrastructure. While for the platform as a service, it offers a platform for developers to build and deploy apps without any worry about hardware or operating systems management. Thus, it provides a platform for web as well as app development purposes. While in the software as a service, it delivers fully functional software through the cloud. While in the function as a service, it lets you run the code triggered. While in the function as a service, it lets you execute the event-driven functions with the help of the triggers, which is perfect in the case of small or tiny tasks without any kind of server management. Now the second point is control. In the infrastructure as a service, it provides you with the high control over the servers and configurations, which is great for IT teams wanting flexibility as well. While for the platform as a service, it provides you with a medium level control where you can handle app. The provider manages the infrastructure. But in the software as a service, it provides you with a low control as you use what's provided, focusing purely on the usage. Lastly, in the function as a service, it again provides you with the low level control as here you just write the functions. Scaling and servers are handled for you by the service provider itself. Now coming to the third point, that is scalability. In the infrastructure as a service, it can scale manually or automatically depending on how you set it up. While in the platform as a service, the scalability is automated based on the app needs as developers don't have to worry about it. In the software as a service, the auto scaling happens with the user demands. Lastly, in the function as a service, it instantly scales up with the number of function calls, which is perfect for fluctuating workloads. Coming to the fourth point, that is the pricing. In the infrastructure as a service, you only pay for the resources used, like storage or compute power. Thus, it goes with pay per use. While in the platform as a service, here you only pay for the platform services you consume. Coming to the software as a service, it is completely subscription based where you can pay monthly or yearly for software access or subscriptions. But in the function as a service, you only pay for the function execution, saving costs for event-driven tasks as well. Now for the examples, in the infrastructure as a service, take the example of AWS EC2, Google Compute Engine, like renting virtual machines. While in the platform as a service, You can take the example of Google App Engine, AWS Beanstalk, where you can focus on code and not on the infrastructure. While for the software as a service, Google Workspace and Salesforce are the softwares which are ready to use from day one. And lastly, for the function as a service, AWS Lambda and Google Functions are best examples of function as a service, where you can run the snippets of the code whenever needed. And that's it. Here, each model serves different needs, whether you want full control or just want things to work out of the box. Alright, so far we have explored the cloud deployment models and service models as well. But have you ever wondered who's actually behind the cloud services we use every day? Well, let me introduce you to the top players in the cloud market, the companies that power the internet's backbone and make the cloud possible for us. Alright, let's see who provides the cloud services. The cloud services are provided by cloud service providers, the companies that own and maintain large-scale data centers worldwide, offering the computing power, storage, networking, and more over the internet. These providers own massive data centers across the world, packed with thousands of server, storage systems, and networking equipments. Now imagine a warehouse, the size of several football fields filled with blinking servers. That's the scale we are talking about here. Now, who actually runs the cloud and makes sure it's safe? Let's break it down in simple terms. Cloud governance is a shared responsibility, meaning multiple parties work together to keep the cloud services secure, reliable, and running. So the first one is cloud providers. They own and maintain the cloud infrastructure, making sure the servers are running, the data centers are secure, and services comply with regulations and compliances. Then comes the government and regulatory bodies like GDPR and HIPAA. They create the laws and guidelines to protect the user data, ensure companies follow the security standards and compliances as well. Then comes businesses and users. That's exactly you. You are responsible for setting up security controls, managing your data, and ensuring the best practices are followed within your cloud environment. Think of it like renting an apartment, where the landlord, that is the cloud provider, takes care of the building and ensure the utilities work just fine. Then comes the city government regulations, which enforces safety codes and makes sure the building meet legal requirements and compliances. Then comes you, the tenant, who are staying there. You are responsible for locking your doors, managing your belongings, and keeping your space secure and clean. So, while the cloud providers give you the infrastructure, it's up to the businesses and users to ensure their data is safe and secure. Next, we'll see what is a cloud provider. The cloud provider is simply a company that rents out IT resources like servers, storage, databases, and software over the internet, where instead of buying expensive hardware and maintaining it, you pay for what you use. We have studied it already. So why do businesses use or choose or prefer cloud providers? Ever wondered why businesses don't just build their own massive data centers instead of using the cloud providers like AWS, Azure, or GCP? Simple. It's because cloud providers don't just offer storage. They offer powerful technology that helps businesses grow faster, smarter, and safer. The first one is security and compliances. Cloud providers offer built-in encryption, firewalls, and compliances with the industry regulations like GDPR and HIPAA. So businesses don't have to worry about setting up security from scratch and about the regulatory bodies. They can just focus on their own growth. The next is AI and big data capabilities. If you need to process huge data sets or even build AI-driven applications, AWS, Azure, and GCP provide powerful machine learning tools and analytics solutions as well. So, businesses can run and turn their data into insights effortlessly and without any kind of hustle. Then comes the seamless integrations. Each provider has its own strength. For example, Azure integrates seamlessly with Microsoft tools, while AWS offers the broadest range of cloud services. Then, Google Cloud leads in AI, machine learning, and analytics. The fourth factor is hybrid and multi-cloud flexibility. Companies don't have to stick to a single provider. Many use hybrid, that is mixing cloud plus on-premises infrastructure, or multi-cloud, that is using multiple providers, to maximize the flexibility and avoid the vendor lock-in. Thus, you see, at the end of the day, businesses don't just choose cloud providers for cost savings. They are about giving businesses the tool to innovate, scale, and stay secure while they focus on what truly matters, that is, growth and innovation. And that's why businesses rely and prefer cloud providers. Okay, now that you know what cloud providers do, let's take a look at the top players dominating the cloud market. So this is the revenue graph. You can see it clearly that AWS, being the industry giant, holds the largest market share, that is 31%. It's known for its wide range of services, global reach and scalability. Then comes the Microsoft Azure, holding the 20% of the market. Then comes our Google Cloud, which holds nearly 12% of the market share. And then comes other notable players like IBM Cloud, Oracle Cloud, and Alibaba Cloud, serving major industries and regional markets offering specialized solutions. As we already saw, the top cloud providers in the market. The first one is AWS, the largest and most widely used. Then comes our Microsoft Azure, which is popular for enterprises and Microsoft users. Then comes Google Cloud Platform, which is strong in AI and data analytics capabilities. Then comes other notable players like IBM Cloud, Oracle Cloud, Alibaba Cloud, etc. These providers are in fierce competition, but each has its own strengths, so choosing the right one depends on your own business needs and specifications. Now let's see the biggest player in the cloud space, that is AWS, which stands for Amazon Web Services, which was launched in 2006. As AWS was the first major cloud provider and has become the go-to choice for startups, large enterprises, and even governments worldwide. But why is AWS so popular? It provides vast range of services, that is over 200 services covering everything from computing to the AI. Second, it provides global infrastructure. The data centers called availability zones in regions are spread all across the globe. Third, that is reliability and scalability. It is trusted by companies like Netflix, Airbnb, and even NASA. Now let's see what are some AWS popular services. For the compute, EC2, which provides virtual machines to run your applications. Then comes Lambda, which is widely used for serverless computing. Remember the function as a service model? Yep, that's Lambda. Then comes the storage. For that, S3, which is a scalable object storage, which provides storage for files and backups. Then comes EBS, that is block storage for virtual machines. Then comes the databases. AWS provides RDS and DynamoDB. RDS is managed relational databases like MySQL and PostgreSQL, while the DynamoDB is a NoSQL database for high-speed applications. Then comes AI-enabled. AWS provides platforms like SageMaker, where you can build, train, and deploy machine learning models easily and smoothly. It also provides the recognition, where it provides the analysis tools for images and videos too. Yes, it can recognize faces and objects. So, that's AWS. Powerful, versatile, and the market leader. But what about the competitors? Yeah. How does Microsoft Azure stand out? And why do companies choose Google Cloud for AI projects? Now, next up, let's see and talk about Microsoft Azure, the second largest cloud provider launched by Microsoft in 2010. Azure is one of the top cloud providers. But why is it so popular? Well, imagine you're already using tools like Microsoft 365, Teams, or even Windows servers in your company. Wouldn't it be convenient for you if the cloud platform just clicked with everything that you're already using? Well, that's exactly where Azure shines. It provides seamless integration with all the Microsoft products. It is the second largest cloud provider with around 20% of market. Impressive, right? Now let's see what are some popular Azure services. For the compute, it provides virtual machines. Here you can run various operating systems and applications as well. And then it also provides Azure Functions for serverless computing, which is perfect for event-driven applications. Then for the storage, Azure provides blob storage, where you can store massive amounts of unstructured data as well, like images or videos. Then it also provides Azure Files, which is used for file sharing across multiple machines. For the databases, it provides you with SQL database, which is fully managed relational database. Then Cosmos DB, which is globally distributed NoSQL database with ultra-low latency. This says a major fact about Cosmos DB, that it is globally distributed NoSQL database with ultra-low latency. Then for the AI and analytics, Azure provides AI tools for speech recognition, computer vision, and more. It also provides Azure ML, where you can build and deploy ML models without starting from scratch. Now here's a quick thought. If AWS is like the popular all-rounded charmer in the class, Azure is a super organized one who always has the notes in sync with the teacher. Like Microsoft tools in this case. Got it? Now, let's meet the third largest player in the cloud game. That is Google Cloud Platform or GCP, which was launched in 2008 by Google. GCP is like tech-savvy friend who's really good with data and AI. Companies focused on big data analytics, AI, and machine learning often turn to GCP. Why? It already holds a market share of around 12% and it's growing really fast. Now let's take a look at the popular GCP services. For the compute, it provides compute engines where the virtual machines are tailored to your needs. Actually, they are tailored to your own specific needs. Then for the serverless execution, it provides you with cloud functions. For the storage, it comes with cloud storage, which is reliable object storage for files, backups, and media. It also provides you with persistent disks, which are durable and high-performance storage for virtual machines as well. For the database, it provides you with BigQuery, which provides super-fast data analytics, handling massive data sets with ease. It also provides you with FileStore, which is a NoSQL database for building scalable and real-time apps as well. Then for the AI and ML, it provides TensorFlow, which is an open source machine learning framework, and yes, it's Google's. Then it also provides AutoML, which helps you to build custom ML models with minimal amount of coding. Then Vertex AI, which provides you with end-to-end platform for ML model deployment and management. Fun fact, have you ever used Google Maps or Google Photos? Yep, that also comes under GCP. AI working behind the scenes. So there you have it. AWS, the versatile leader, Microsoft Azure, the enterprise favorite with seamless Microsoft integrations, Google Cloud, the go-to choice for the data-driven and AI-powered solutions. Now let's see how to choose which provider is best for you. Let's break it down with the help of the comparison table here. For the business needs, when it comes to AWS, it is great for scalability and a wide range of services as well. And it is ideal for businesses of all sizes needing global reach. While for the Azure, it is best if you are heavily using Microsoft products, where you can seamlessly integrate it with the tools like Office 365 and Windows Server. While for the Google Cloud, it is perfect for AI-driven data-heavy workloads and startups looking for innovation and speed. Second point, that is pricing. AWS offers pay-as-you-go with options like reserved instances for cost savings on long-term use, while Azure provides volume-based discounts, which is ideal for large enterprises planning for long-term usages. Then Google Cloud features per-second billing with sustained use discounts, which is great for the cost-conscious projects as well. For the third point, that is performance and availability. AWS has the largest global infrastructure, which is also reliable for businesses needing worldwide availability, while Azure is strong in hybrid cloud solutions and is trusted by enterprises for consistent performances. Then, the Google Cloud excels in AI services and resources with high-speed data processing, which is perfect for analytics-driven applications. The fourth point, that is security and compliances. AWS offers strong compliances with standards like GDPR and HIPAA, which is suitable for sensitive industries, while the Azure matches AWS in compliances, making it a solid choice for regulated industries as well. Then comes the Google Cloud, which focuses on advanced security with robust measures for data protection and enhancements. So now, which cloud is best for what? When it comes to AWS, companies needing global services and a broad range of services and solutions, this is the best one to go with. While for the Azure, enterprises relying on Microsoft products and hybrid environments can be the choice. Then lastly, for the Google Cloud, the businesses which are more focused on AI, data analytics and cost efficiency, this is the best option for you. So that was it. A quick rundown. Now you can choose the provider that aligns with your business goals and tech needs. Not to forget, each provider has its unique strength and businesses should choose based on their needs, budget and existing tech stack. Now that you have got a solid foundation in cloud computing, it's time to dive into the core concepts and understand what truly powers the cloud. These are the essential building blocks that you will need to understand how the cloud operates behind the scenes. So let's begin by understanding what are the core concepts of cloud computing. Speaking of it, cloud computing is a powerful and transformative technology that enables the organizations to leverage computing resources without the need for any kind of heavy investments into the physical hardware. But how does this thing actually works? It's all because of these core concepts that keep everything running smoothly. So let's see what are those. The first one is virtualization, second are containers, the third is serverless computing, fourth is scalability, fifth is elasticity, and sixth is, the most importantly, cost optimizations. So first, let's see what is virtualization. Virtualization is the process of creating virtual versions of physical hardware resources such as server, storage systems, devices or networks. To make things even more simpler to understand, let's take an example. Imagine you are having one giant pizza, but instead of giving the whole thing to just one person, you slice it up into many pieces so that multiple people can share it and enjoy it. Virtualization works the same way. It's the process of creating virtual versions of physical hardware resources like server, storage or networks so that they can be shared among multiple users. Now let's see what are the benefits of virtualization. First one is efficiency. What does this mean is, you can maximize the hardware usage without wasting resources by creating a multiple virtual versions of it. The second is cost savings. Here you no need to buy tons of hardware. You can rent whatever you need virtually. The third one is flexibility. Here you can also run different types of operating systems and apps simultaneously on your system. The fourth one is isolation. Here each virtual machine works independently so that one issue won't affect the others. So this was about virtualization. But now, how does virtualization actually works? Cloud providers use virtualization to host multiple virtual machines on a single physical server, as you can see in the picture. Here, each VM acts like its own mini computer. You seeing this? VM guest 1, VM guest 2, VM guest 3. That is how each VM acts like its own mini computer, with its own operating system, apps, but they all are sharing the same hardware underneath. Think of it like roommates sharing an apartment. Everyone has their own room, but they share the kitchen and living room. That is the hardware resources in this case. So that was it for the virtualization. Next we will see about what are containers. Alright, let's take an example so that will make things easier for you to understand. Imagine you are packing lunch. You put the sandwich, salad and dessert into 3 separate containers so that they don't mix with each other but can still be carried together. The containers in cloud computing works exactly the same way. Here you can package an application along with everything it needs, like the code, libraries and dependencies into a single unit. This means the app can run anywhere without any kind of issues. So by the formal definition, containers are lightweight portable units that package an application and all of its dependencies such as code, libraries and runtime together to run consistently across any computing environments. Now let's see what are the benefits of containers. The first one is portability. Here you can run the same container on any machine so that there will be no issues if we switch the machine. The second one is efficiency. Containers are lightweight and can start up really super fast. The third one is isolation. Each container runs separately so that the apps don't interfere with each other. The fourth one is scalability. The containers can easily scale up or down based on the demand. So, how does containers work? Unlike virtualization, which uses the full-blown virtual machines, containers share the operating system, but keep the app environments separate. Think of it like a hotel, that is OS in our case, with different rooms that are the containers, and the guests in each room have their own privacy, but they all use the same building structure and services. So that's how it works. The most popular containers are Docker and Kubernetes. You might have heard about them, don't you? So the next up, that is, we'll see serverless computing. And no, it doesn't mean that there are no servers. There are servers, but you don't have to manage them. The cloud provider takes care of that for you. So what is serverless computing? Serverless computing is a cloud service model where developers write and deploy code without managing or provisioning any kind of physical infrastructure. The cloud providers handle the underlying servers and scaling and all the maintenance of it as well. For that, let's take an example here also. You're at a restaurant, you order the food, it gets served and you enjoy without worrying about cooking, cleaning, handling anything. Just order, it gets served and you enjoy it. That's how serverless is like for the developers. They write code and the cloud provider runs it automatically whenever the trigger happens. We have seen this before, didn't we? So what are the benefits of serverless computing? The first one is there is no need of managing any kind of infrastructure. You only focus on your codes and not on the servers, and everything is handled in the backend by the cloud service providers. The second one is automatic scaling. The functions you write here can scale up or down depending on the usage and on your needs. The third one is it is cost effective because you only pay for when your code actually runs. No idle charges of the servers. And the fourth one is faster market time. Here you can deploy apps faster without any backend headaches or managing any kind of infrastructure or servers. But how does this actually work? In the serverless computing, the code that are your functions are triggered by the events like HTTP requests, a file upload, or a database changes. Imagine flipping the light switch. The light, that is the code here, turns on only when you need it. No power wasted otherwise. Just like that. And the popular tools for serverless computing are AWS Lambda, Azure Functions, and Google Cloud Functions. Now moving next, let's see what is scalability in the cloud computing and why it is so important. So basically scalability means the cloud's ability to handle growth without breaking anything. The formal definition goes like scalability refers to the ability of a cloud system to handle a growing amount of work or its potential to accommodate to the growth that is necessary and demanding. To understand this in a simpler way, let's take an example of an ice cream truck. On a hot day, you need more staff to serve the crowd, but on a cold day, fewer people show up, right? And that's how scalability works. Scalability in the cloud works similarly. It allows resources to expand or shrink based on the demand without any wastage of the resources. That is the most important thing, without any wastage of resources. So basically there are two types of scaling. The first is vertical scaling. Here you have to add more resources like CPU, RAM to an existing machine, like upgrading your phone to a newer model. The second one is horizontal scaling, or another called as scaling out. Here you have to add more machines to handle the load, like opening more ice cream trucks to serve more people. So what are the benefits of scalability in the cloud computing? The first one is improved performance. Here you can handle more users without any kind of lagging. The second one is it is cost effective. Here you can scale down whenever the demand drops to save money that will be wasting on the idle or extra resources. The third one is business growth, as it supports increasing workload seamlessly and there is no any kind of wastage of the resources here. So that was it for the scalability. Next we'll see what is elasticity in the cloud computing. Yeah, it is closely related to the scalability, but there's a difference. Elasticity is about automatic scaling. The system detects the change in demand and adjusts the resources on the fly. The formal definition goes by elasticity is the ability to automatically adjust the amount of cloud resources, that is compute, power, storage, which can go up or down based on the real-time demand. It involves adding resources to handle increased demand without affecting the performance of the system. To understand this easily, let's take an example of a self-driving car that speeds up or slows down depending on the traffic rate without you touching the steering wheel, accelerator, or brake. And that's how elasticity works. So what are the benefits of elasticity? The benefits of elasticity are, first is on-demand resource adjustment, as you don't have to do any kind of manual intervention. It adjusts automatically. The second one is cost optimizations. Here you only pay for what you actually use, nothing more, nothing less. The third one is improved user experience as it prevents slowdowns during high traffic times. As we already seen how it works, right? I will read it again for you. Cloud resources automatically scale resources in response to any kind of change in the demands. When the demand decreases, resources are reduced to save the costs. But when the demand increases, resources are again brought into the usage so that everything runs smoothly. That's it. Now the next thing is, what is cost optimization? Cost optimization in the cloud is all about reducing the expenses while keeping your services efficient, reliable, and high performing. It's like getting the best value for your money without compromising the quality. It also involves strategies and tools to reduce the cloud service expenses while maintaining the performance and reliability of your application or systems. So, there are several techniques that are used to optimize the cost. The first one is using reserved instances. Here you can commit to certain resources like reserved instances for 1 to 3 years and again enjoy the significant discounts, that is up to 75% compared to on-demand pricing, which is perfect for predictable and long-term workloads. The second one is auto-scaling, where you can automatically add or remove resources based on the real-time demand. It is best in case when you have to handle peak loads without overspending when demand even drops. The third one is right sizing, which means matching your resources to actual workload needs. Like, why pay for an 8-core server when you can handle everything on a 4-core one, right? That is how it works. Now the fourth one is using cost management tools, which are already provided by every cloud service provider. For example, AWS Cost Explorer or AWS Budgets, Azure Cost Management, and Google Cloud Billing helps to track, analyze, and control your expenses. So what are the benefits of cost optimization? The first one is it prevents resource wastage. Here you don't pay for idle or unused resources. You only pay for what you actually use. The second one is here you get to control the scalability costs, as you can scale efficiently without overspending. The third one is you can manage the dynamic usage patterns and adjust the resources as the demand fluctuates. The fourth one is budget control. Once you enable the budget control, you can stay within the spending limits, and even when you exceed the spending limits, immediately the alert is issued on your Gmail account that you have used in it. The fifth one is cheaper cloud billing. When you learn to manage these resources and services smartly, you can save a huge amount of money on this. So, cost optimization isn't just about saving money, but it's also about spending smarter while keeping your system reliable, efficient, and smooth. Pro tip: please regularly review your cloud usage and adapt to your strategies as per your business or project evolves. These were the concepts which are seen as the backbone of modern cloud solutions, helping businesses innovate faster, smarter, and speedier. So that was it for the core cloud concepts. Let me know if you have any doubts in the comment section. And let's move forward to the quiz now. Alright, now that we have explored the foundation of cloud computing, it's time for a quick knowledge check. Let's see how much you understood. So beginning with the first question, what is the key difference between on-premises and cloud computing? And your options are: A. Cloud computing requires physical servers while on-premises does not. B. On-premises needs in-house infrastructure while cloud computing provides resources over the internet. C. Cloud computing is free while on-premises always has costs. D. On-premises is more scalable than the cloud. Think about it and answer. Alright, the answer is option B. On-premises needs in-house infrastructure while cloud computing provides resources over the internet. Yes, cloud computing lets business access computing resources without any kind of maintenance of their own hardware. Alright, let's see the second question. That is true or false? So the question is, serverless computing means there are no physical servers involved. What? Do you think that this is true or false? Tricky, right? Think about it. Alright, it is false because servers still exist. But in serverless computing, you don't have to manage them. It has already been taken care by the provider itself. Now moving to the third question, which is a scenario-based question. The question is, A healthcare company needs to store patient records and comply with strict data privacy laws like HIPAA. Which cloud computing model should they choose? And your options are A. Public cloud, B. Private cloud, C. Hybrid cloud, D. Multi-cloud. What do you think? Which suits the best? And the answer is B. Private cloud. Because it ensures maximum security and compliances with the healthcare regulations. Thus, a private cloud would be the best option to go with. Now moving to the fourth question. Here, a company uses AWS for hosting its website but relies on Google Cloud for AI-based customer insights. What cloud strategy are they following and which is the most suitable here? So your options are A. Public cloud, B. Private cloud, C. Multi-cloud, D. Hybrid cloud. So what is your guess? Yeah, it's C. Multi-cloud. Because multi-cloud means using multiple cloud providers for different services, which is best when it comes to AI-based customer insights. So moving to our fifth question. Here, a startup wants to launch a mobile app but doesn't want to worry about its infrastructure, scaling or any kind of updates. So which cloud model is the best fit for this? And your options are A. Infrastructure as service, B. Platform as a service, C. Software as a service, and D. Hybrid cloud. What do you think about this? Exactly. It's B. Platform as a service. It gives developers a platform to build and deploy apps without managing any kind of infrastructure. And here, everything they need to build and deploy applications without any kind of management issues. Thus, platform as a service serves the best. Now moving to the sixth question. Now, a company subscribes to Google Workspace that includes Gmail, Docs, Drive for their daily business operations. Which cloud model are they using here? Remember about the service models that we have studied earlier? Exactly. So the options are software as a service, infrastructure as a service, platform as a service, function as a service. So what works right here? The answer is software as a service. The applications are fully managed and accessed via the internet. Thus, the right answer is software as a service because Gmail, Docs, Drive, this all are softwares provided over the internet, right? So here's your answer. Now coming to the seventh question. Here, a global e-commerce company needs the cloud provider with the wildest global reach and largest data center network in the world. Which provider should they choose? And your options are A. AWS, B. Azure, C. Google Cloud, D. IBM Cloud. Now come on, this is so obvious. Yes, you're right. It is AWS. AWS wins this one as it has the largest cloud infrastructure across the globe. Now moving to the next question, that is eighth one. A startup wants to build an AI-powered chatbot that actually uses advanced machine learning models. Which cloud provider would be the best choice for this? And your options are A. AWS, B. Google Cloud, C. Azure, D. IBM Cloud. What do you think about this when it comes to AI? Yep, your guess is right. It's B. Google Cloud. It excels in terms of AI/ML services. It is a leader in AI/ML services with tools like TensorFlow and AutoML. It simplifies the process of building an AI-powered chatbot. Thus, Google Cloud would be the best fit for this. Now moving forward with the ninth question. An e-commerce site experiences sudden traffic spikes during sales events and needs a cloud solution that automatically scales based on the demand. What should they use? And your options are A. Virtual machines, B. Auto-scaling, C. Static hosting, D. On-premise servers. Yes, you guessed it absolutely right. The correct option is B. Auto-scaling, as auto-scaling adjusts resources in real time based on the traffic demands. Now coming to the very last question. A gaming company wants to run a multiplayer game where servers need to handle unpredictable spikes in users. Which cloud computing model should they focus on? And your options are A. Virtualization, B. Elasticity, C. Software as a service, D. Edge computing. And when it comes to handling unpredictable spikes, the correct option is B. Elasticity. Elasticity ensures the game servers scale up and down dynamically based on the demands. And that's it for the quiz. How did you do? If you got most of these questions right, you are on the way to mastering the cloud. If not, don't worry. Every expert was once a beginner, so keep learning. So, we have learned all about cloud computing as for the foundation, right? But what if you're asked about it in an interview? No worries. Here are some golden tips to ace any cloud related discussions. The first one is explain concepts clearly and concisely. Keep your answers simple and to the point. No overcomplicated jargon at all. Now, the second is use real world examples. If you are asked about cloud deployment models, why not mention how Netflix uses AWS or how Lego balances security and scalability with a hybrid cloud model? Just like that, use real world examples to support your answers. Now, coming to the third point, that is compare different cloud models and services. Like, why would you choose infrastructure as a service over platform as a service? And don't just define it, explain when to use what. That makes you stand out. Now, the fourth one is discuss security, cost, and scalability. These three factors drive cloud adoption. Show awareness of how businesses balance them in an effective way. And the last one is show understanding of multi cloud and hybrid trends. For example, like companies are no longer relying on just one cloud provider nowadays. Highlight why businesses mix AWS, Azure, and GCP for better optimization and performance. Follow this and you won't just answer interview questions, you will impress them. So congratulations, you have officially completed this cloud computing course. And here, you have built a strong foundation in cloud computing from its core concepts to the real-world applications. You also understood how businesses use cloud services and how to choose the right deployment and service models. Most importantly, you're now ready to take the next step, whether it's exploring hands-on labs, preparing for the interviews, or even getting certified. But remember, cloud computing is always evolving. The more you explore, the better you will get. Keep learning, keep experimenting, and most importantly, keep innovating and practicing.
Just a quick info, guys. Intellipaat offers an advanced certification in cloud computing and DevOps by IAM Web. Through this course, you can learn all the important concepts of cloud computing, DevOps, AWS, Azure, Linux, and Python. The course features live classes with IIT faculty and industry experts, campus immersion at iHub IIT Roorkee, and includes certifications from both iHub IIT Roorkee and Microsoft. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials in our Achievers channel, whose link is given in the description below. With 24/7 support, placement assistance, and EMI payment options, this course without a doubt can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of cloud computing.
We discussed about the data centers, right? We discussed that an organization would require data center, and those data centers will have the servers inside them, right? So the servers are deployed inside the data centers. Servers are deployed where? Within the data centers. Now the question comes in that what about the data centers which are owned by Amazon Web Services? Because your organization, for example, you work for a company like Accenture, Wipro, HCL, Infosys, JP Morgan, AIG, Apple, right? Now, when these companies start using cloud computing vendors like AWS, Microsoft Azure, GCP, Salesforce, these companies become their customers. For example, Apple says we want to use Microsoft Azure to deploy our workloads and applications, right? So in that case, Apple would be the customer of Microsoft Azure or Microsoft. Okay, so think of yourself as a customer, or you are the employee for working in that organization who's the customer of any one of these three providers. The next question that comes in is that how exactly you leverage that infrastructure which is owned by your cloud vendor. Let's suppose you're working for Apple, or let's suppose you're working for Netflix. Netflix is a customer of AWS. Now, Netflix is running all its videos, its applications, workloads on AWS. Now, being a part of Netflix, you have to understand exactly that how Amazon Web Services has scattered its data centers, or how it is managing its data centers in different parts of the world. Because Netflix doesn't offer services only in US. It offers the services in a lot of countries, including India, right? So you have to make sure that how you understand its global infrastructure of AWS. You understand that how they place the data centers in different parts, or in different countries or different continents. That's where we discuss. That's where the concept of the global infrastructure comes into play. Global infrastructure means that you understand exactly that how our cloud provider, which is Amazon, has placed its data centers and clustered those data centers in a different location, or what's exactly, not exactly location, but exactly how these things are being placed in let's suppose in Africa and India, in US and Europe, how they have clustered their data centers in these different countries. So in this case, we need to understand concept that's called global infrastructure. Let's try to understand that. Okay, so we're trying to understand first topic. I would say that of AWS, which is the actual topic. The name of the topic is AWS Global Infrastructure. Now, it consists of different components, different parts like regions, availability zones, edge locations. We have, for example, local regions, local zones. I'm sorry, local zones, regions, local zones, availability zones. Uh, we also have edge locations, but there will be two things that we're discussing with you right now: regions and availability zones. Edge locations, local zones, we'll discuss afterwards. Okay, this discuss the AWS global infrastructure. Let's try to understand that. Okay, so the very first component or the part of this infrastructure includes a region. Okay, what is an AWS region? An AWS region is nothing but it's a geographical region. It's a geographical location or a geographical region or a piece of land which consists of which consists of a cluster of data centers owned and managed by AWS. Okay. What's a cluster? What do you mean by cluster? Some people ask me this question. What do you mean by cluster? Cluster means group, right? So a region is nothing but it's the geographical location. It's a basically it's a piece of land. It can be on the name of any city, uh, or maybe, for example, most of these are based on cities or named after countries. So it can be any name. It can be based on the city. Like for example, in India, there are two regions: Hyderabad and Mumbai. Uh, for in Australia, Sydney and Melbourne are two regions. For UAE, they have a separate region. For let's suppose for South Africa, Cape Town, there's a separate region. Singapore is a separate region, right? Japan is a separate region. A region is nothing but it's a geographical location which consists of a group of data centers which are being owned and managed by Amazon Web Services, which is our cloud provider. We are the customers, right? Like let's suppose we work for Netflix, we work for JP Morgan, we we use AWS to deploy our resources into. So those custom data centers are used by us, right? But who owns and manages those data centers or cluster of data centers? It is the cloud provider. Okay, so a region is nothing but it's a piece of land. It's a geographical location where the cluster of data centers, the group of data centers which are being owned and managed by Amazon Web Services exist over there. I would say it's a geographical location or it's a piece of land where Amazon's owned and managed data centers run, and they are being operated by Amazon. So Amazon Web Services says, let's suppose in Cape Town, I have my 3 data centers running. So I mark Cape Town as a region, right? So a region is a geographical location which consists of data centers, a chain of data centers. Now, in these cluster of data centers are being denoted by a special term. Okay. So what is that special term that we use over here? This cluster of data centers that we these cluster of data centers are denoted by a term that is called availability zones. What's that? It's called availability zones, right? Okay, availability zones in the short form are called AZs. These are the data centers, or these are the facilities consisting of racks of servers. These are data centers only, right? So these are the facilities which houses racks of servers, right? These are the facilities which consist of racks of servers. Now, one availability zone or one AZ is equal to one or more data centers. A single AZ can have one or more data centers, okay? And in each region, there are at least 3 AZs, right? To make your data more redundant, to make your work applications more available. So basically, these are the two terms you have to remember and learn. A region is a geographical location which consists of a cluster of data centers. These cluster of data centers are called availability zones. So availability zones are the data centers only, or they're the facilities which consist of rack of servers. One AZ equates to one or more data centers, and each region will have at least 3 AZs. There could be more than 3 AZs, but you'll find minimum 3 AZs or availability zones. Fine. These are the two terms you have to remember. I'll just give you a few examples over here so that you understand that and understand this concept in and out. Okay. Now I'm just logged into my AWS Maven console to my account. Now you're going to be seeing one thing is that once I just go to the top right hand corner, right? I'm talking about this thing where you see my this cursor over there. In this case, you're going to be seeing that these are the listed regions over here: North Virginia, Ohio, California, Oregon, Hyderabad, Melbourne, Mumbai, Seoul, Singapore, Sydney, Tokyo, Canada, Frankfurt, Europe. These are the existing regions, right? Frankfurt, Ireland, London, Paris, Stockholm. We have Cape Town, Hong Kong, Jakarta, Milan, Spain, Zurich. Right, so these are the regions. It shows exactly the regions, and it gives the details of the regions and the availability zones which are owned by AWS. Okay, so in this case, if I just go back and show you exactly, this is the map. So as of now, they have 31 launched regions. So presently, when I'm talking to you, they have 31 running regions, which are running to 24/7, right? This is the map that shows up. On this map, the green dots that you can see, these are the existing regions. That's why we say a region is a physical location. It's a geographical location. It's a piece of land. For example, so the green dots you can see, those green dots represent regions. For example, this green dot represents Sydney. This one Melbourne. This one Jakarta, Hyderabad, Mumbai, UAE, Bahrain, Spain. This is, for example, North Virginia. This is, for example, Milan, Spain, Ireland, right? So the green dots represent existing regions. Each region is a physical location which consists of a chain of data centers or a group of data centers. And those group of data centers are called as availability zones. Now, the one that you can see in the form of red dots, these are the upcoming. They are coming soon, which means that they will be set up in the next few months. It's work in progress. Amazon is still setting them up because launching a chain of data centers take a lot of time, and it is still in progress. and very soon you're going to be seeing these data centers being showing up. So as of now, you can see the exact details. There are 99 availability zones. Now, each availability zone can be one or more data centers. Generally, we assume it's one data center. Okay. So let's suppose there are 99 data centers. There could be more than 99. 99 data centers in 31 geographic regions. All right. With announced plans for 15 more data centers, or more than 15, could there could be a possibility that one AZ because in there are few AZs which consist of two data centers. So 50 or more availability zones in 5 more regions in Canada, Israel, Malaysia, New Zealand, and Thailand. So I think by the end of this year, you will be seeing most of these the regions being deployed. Okay, I think Canada will show up because they announced Canada region in Montreal few months back. But let's see. Okay, so these are the regions which exist, and some of the regions they are still in plan. They will be deployed very soon. Fine. Now, I can also show the definition just in case if I just go to this other link. Okay, so you can see that AWS has a concept of a region, which is a physical location around the world where we cluster the data centers. We call each group of logical data centers as an availability zone. So that's why I said an availability zone can be one or more data centers. And there are 3 availability zones at least in one region. Okay, so AWS has a concept of a region, which is nothing but it's a physical location around the world where we cluster the data centers. And this group of logical data centers are called as availability zone. Each region consists of a minimum of 3 isolated, physically separate AZs within a geographic area. So each region will consist of 3 availability zones within a geographical area or in a region, so that they isolate any hardware failures, any power outage. So I think there's a distance of around 50 to 60 kilometers between each of the AZ. That's the minimum distance. So if one AZ, so the distance between 2 AZs is at least 50 to 60 kilometers, right? So because if one AZ goes down because of a power outage, maybe because of floods, natural disaster, you can easily have other regions, other availability zones serving you the services in form of workloads and applications running inside them. Now, what is an availability zone? An availability zone, in the short form we call it as an AZ, is one or more discrete data centers with redundant power, networking, connectivity in an AWS region, right? So it's a kind of an AZ is equal to one or more data centers which has its own power, networking, connectivity inside that region. Okay, let me just give you 3 examples, then I'll take the questions forward. Let's take 1 or 2 examples. First thing first, we need to understand that each region is given a special name. For example, the one which is labeled as US East 1, that's the North Virginia. What's that? North Virginia. So basically, they don't go with this with the geographical names. They give their own special names. For example, the one which is the US East 1, US East 1 means that they're talking about the Northern Virginia, right? So for California, it's okay. How they labeled US East 1? North Virginia is on the east coast of US, right? And this was the very first region on the east coast of US. So they labeled as US East 1. Now, by the way, US East 1 is the very first region Amazon set up when they started giving AWS as, or when they started as a cloud provider. So this is the Amazon's Web Services first region. So this is the on the east coast of US, the very first region. So they labeled as US East 1. Ohio is the second region on the east coast of US, so it's US East 2. On the west coast, the first region is California, US West 1, and US West 2 is Oregon, the second region on the west coast. For example, let's take in India we have AP South 1. AP stands for Asia Pacific, In the southern region, the very first region was Mumbai, AP South 1, and the second was Hyderabad, so it's AP South 2. You don't have to learn these names. So they've labeled these names, they've given us the abbreviation or special names for these different regions. Okay, so for example, let's go with US East 1, which is North Virginia. Okay, let's take this one. Uh, let's go with Mumbai. Okay, Mumbai was the very first region in India, launched a few years back, I think 2017 or 2018. I'm not sure about the exact date. But anyhow, every region you have, every region is a separate infrastructure on its own. It is independent from other regions. Fine. For example, if you deploy my resources in Mumbai, they will stay in Mumbai only. They will not be visible. I would say they will not be the part of Hyderabad or California or Virginia. So assume that every region is a complete infrastructure on its own or by itself. So, for example, if I use Mumbai and deploy my resources in Mumbai, they stay in Mumbai. Of course, I can access them remotely from other location, but they would be the part of Mumbai region. That's why you have to switch dashboards between regions, right? For example, right now I'm in Mumbai dashboard, so I can access my resources in Mumbai. Similarly, if I switch to California, so in this case, I'll be accessing my resources in California. Understood? So each region is its own. It's an infrastructure on its own. I would say it is a complete infrastructure which is independent from other regions. That's the reason you have to switch back and forth between different regions to access the individual dashboards. So if I deploy my resources in California, they stay in California. If I have to, let's suppose, access my resources in Sydney, I have to switch to Sydney's dashboard. That's the reason. Once I switch between different regions, the link or the URL changes at the top, right? So every region is isolated or it's kept separate from other regions. Uh, if I say it is a separate entity, this means that it has its own identity, right? So to access and deploy the resources in Sydney, I have to explicitly go to Sydney, switch to the dashboard, and start launching my resources inside Sydney. I can't deploy resources in Sydney while just using Melbourne dashboard. I can't do that. Okay, so that this thing you have to understand. Okay, let's take the example of Mumbai. I was trying to give you some examples. Mumbai is labeled as AP South 1. This is a special name assigned to it. Okay. Now, let's suppose I want to show you, I want to see the availability zones in Mumbai. I need to see the availability zones inside Mumbai. So I go to EC2. EC2 stands for Elastic Compute Cloud, which helps me to deploy the virtual machines in the Amazon's cloud. So if I want to deploy my virtual machines or the instances or EC2 instances in the cloud, I use EC2 dashboard, which stands for Elastic Compute Cloud. Very well. Now, if I just go to Mumbai right now, let me show you the Mumbai region. Okay. So in this case, this is the region of Mumbai, which is labeled as AP South 1. What's that? It is AP South 1. Okay. Inside AP South 1, I have three availability zones: AP South 1A, AP South 1B, and AP South 1C. Right? So, what is the AP South 1? It is the region of Mumbai. This is the one. So, AP South 1A, 1B, and 1C are the three availability zones which are interconnected with high speed fiber optic cables. Okay. So, these are the three clustered interconnected availability zones which operate inside Mumbai. Fine. I'll give you two or three examples, two or three more examples to give you some more clarity. Let's go to Sydney. Sydney is labeled as AP Southeast 2. Okay, let's go there. Now, AP Southeast 2 is which region out there? AP Southeast 2 is the region which is the Sydney. So AP Southeast 2 is Sydney region, or the region of Sydney. So AP Southeast 2A, which is this one, 2A, 2B, and 2C. These are the three interconnected regions, availability zones. What are these? I'm sorry, it was slip of tongue. These are, what are these? These are the three availability zones, or three AZs. Fine, these are three AZs which are interconnected with high-speed fiber optic cables, and where they're being deployed, they're launched inside this region, which is Sydney, which is AP Southeast 2. So AP Southeast 2 is the region of Sydney, which consists of three interconnected availability zones: AP Southeast 2A, AP Southeast 2B, and AP Southeast 2C. Let's take one more example. Let's jump to the next region, which is Frankfurt. Frankfurt is EU Central 1. If you click on that, you will see that immediately the page will change. The details will change automatically. So Frankfurt is represented using this term, which is EU Central 1. It's the central part of Europe, Frankfurt in Germany. So EU Central 1, it consists of three interconnected availability zones. They're labeled as EU Central 1A, EU Central 1B, and EU Central 1C. So these are the three AZs interconnected and located inside EU Central 1, which is the Frankfurt region. So a region is a geographical location which consists of at least three AZs, or availability zones. These availability zones represent group of data centers. There are at least three AZs inside a region, at least. I'll show you. North Virginia consists of most of the AZs. If I go to North Virginia, the very first region which was set up by Amazon Web Services. So North Virginia is labeled as US East 1. What is that? It's the US East 1. Fine. It consists of these 6 availability zones: 1A, 1B, 1C, 1D, 1E, 1F. So 6 availability zones inside the region of North Virginia, which is US East 1. Okay. So this is the concept of regions and availability zones. Now the thing is, I know that this question will come up, that how we achieve high availability between them. Can we use all the regions or all the availability zones? The answer is yes. We have to make use of some tools like load balancing, global accelerator, Route 53, auto scaling, to disperse and scatter your resources across these AZs and regions and use them as a part of a single application. How they cluster the data center? Basically, the data centers are interconnected with high-speed fiber optic cables. That's how they cluster them. Okay, I guess this is clear. Now, how to make use of all of them or some of them? We're going to be discussing the services. Based on the services that we discuss, we're going to be understanding each one of these different, I would say, how to use them. Right now, we are just seeing them, how that these are the list of regions, these are the list of availability zones, but how to make use of them, we'll be discussing that when we start with the process of launching of services. Right? For example, if we deploy the servers or virtual machines, I can explicitly choose the region of my choice and the availability zone of my choice. I can do both. But once we start with the launching process, we start understanding that stuff, how to use them. Okay. So to access the availability zone, you have to go to EC2 dashboard, and there's the service health status or service health dashboard. This is where you can see a list of availability zones inside the region. All right, that's about the stuff. Very well. So guys, let's get started with the next topic, which is quite important for us to understand, which is the topic name is EC2. Now the EC2 as a topic is quite extensive. It requires a lot of things to be discussed. So we're discussing all of these things one by one, include the basics like instance types, AMI, and all kind of stuff. All right. So what is EC2? What exactly that concept is all about? Now, when you start launching your services and applications, it is quite important that you start working on a concept that's called EC2, or the Elastic Compute Cloud. Let's try to understand that concept. It is quite important. So Elastic Compute Cloud, what do you mean by that? Okay, let's understand what is the full form of it, and what's the exactly the concept is all about. Elastic compute cloud means that you get the resizable compute capacity in the cloud. Elastic means it can be resized. It is quite flexible to use. Okay. Elastic compute cloud. So elastic compute cloud is a service. I'll explain you the definition in depth. So try to understand the definition, because I'll be explaining everything in depth to you, so that you don't face any trouble when while working on the service. Basically, we'll start with the uh, basics, including the AMI and instance types, because those are the two basic things we have to discuss first. So Elastic Compute Cloud, basically, it provides resizable compute capacity in the cloud. It provides you with a resizable compute capacity in the cloud. Resizable compute capacity in the cloud. What do we mean by resizable? I'll come to that. I explain you every single word of this definition to you, so that later on you understand exactly what it means. So it provides you resizable compute capacity in the cloud. Okay. Let's take one example. Let's imagine that this is the AWS cloud that I've I have which I'm running a virtual machine. This is a virtual machine running inside Amazon's cloud, or Amazon Web Services cloud. Now this virtual machine is labeled as an EC2 instance. Now Amazon says that this is an EC2 instance. What's an EC2 instance? It's a virtual machine, or it's a VM running in the AWS cloud. So basically, it's a virtual machine, it's a VM running inside Amazon's cloud. It's a virtual machine, it's a VM, which is running inside Amazon's cloud, in AWS cloud. Fine. So an EC2 is a virtual machine which is running in the AWS cloud. That's a EC2 instance. Now this EC2 instance has some compute capacity. What do you mean by compute capacity? Imagine you want to buy a smartphone, or maybe a tab, maybe a computer, laptop, or a desktop. You look for its physical specifications. What do you mean by physical specifications? For example, the amount of storage, RAM, the processor it has, uh, the graphics. For example, I want to buy an Apple laptop, that's MacBook. So I will see whether it's an Intel chip or Silicon chip. If it's a Windows laptop, I'll see whether it's the for example, Intel laptop, or it is based on for example, there are multiple chipsets which are available in the market. What's the amount of RAM I'm getting? What's the processor it's giving to me? The storage, whether it has dedicated graphics or not, right? How many? What's the amount of cores it has? Right, nowadays we go for 8 core, 12 core chip. So we go with the compute capacity. That's called compute capacity, because we that compute capacity offers that how powerful that machine is, right? If I go with an 8 core, 32 gig 8 core CPU with 32 gigs of RAM, 2 TB of SSD storage, it's a decent performance I'm getting from a laptop. So this is what you do when you go and buy a computer for yourself. But now you're not going to buy a computer. You're going to go for a virtual machine. See, whether it's a virtual machine or it's a computer, a virtual machine is a computer only. It's a server only. Server, computer, virtual machine, it's the same thing. It's only the only thing is that because you can't see it physically in front of you, it's virtual in nature. So a virtual machine has some compute capacity. Similarly, as if you see the compute capacity of your mobile phone, of your laptop or the desktop, a server, anything you want to buy. So in terms of this here compute refers to the compute capacity refers to here the compute capacity refers to, let me just correct it over here with using the full term. Here the compute capacity refers to the amount of what's the processor you're using. For example, um, uh, let's suppose it's the amount of RAM, cores, storage, graphics, network performance, etc., etc. This is called compute capacity. What's the amount of RAM, cores, CPU, storage, network performance that computer, that virtual machine refers to? This is called compute capacity, right? I've already given you a very layman and common example. Tomorrow you go to a store and try to buy a laptop, but you will see what's the RAM you're getting, what's the processor you're getting, how many cores are there, what's the graphics that came to you. You see all those things. Storage it's came to you. Similarly, in terms of instance, we talk about the amount of RAM, cores, storage, graphics, network performance, etc. Right? So we will see all these things. We see all these things. AWS uses basically Amazon uses special names for everything. All right. In terms of Amazon Web Services, this compute capacity is represented by a special term. So now Amazon likes using acronyms for everything. So this compute capacity is depicted or decided by a special concept or a special term. That special term or that special concept is called an instance type. What's instance type? It's a virtual representation. It's the virtual representation of the underlying compute capacity offered by an instance. What is the compute capacity that this a specific instance offers to us? This is represented by a special term that's called instance type. Okay, I'll give you some examples over there. Let's take some examples. Let's understand some of the examples. For example, there's a instance type which exists in AWS that's called T2.micro. I explain you every single thing. Don't worry. It is T2.micro. Okay. Now T2.micro is a special instance type which has this compute capacity. Following is the compute capacity of T2.micro instance. It has 2.5 gigahertz of Intel Xeon processor, right? And it has 1 GB RAM. Basically, we use 1 gig or 1 GB, the same thing, 1 GB RAM. It has 1 virtual core. It's a 1 core only. I'm sorry, it's a 1 core. Or we call it as 1 virtual CPU. We use the term this thing over here. And you can attach from 8 8 GB um, to 16. I'm sorry. It's 8 gigabyte to 16 terabyte of solid state disk or hard disk drive storage. And it offers to you low to moderate network performance. Okay, so these are the physical specifications of an instance type. With this T2.micro, this is free of cost for us. We can use that in a free tier account. I'll show you the list of them. So basically, I'll come to the same concept one more time. An EC2 instance is nothing but it's a virtual machine running in the AWS cloud. It offers you some compute capacity in the form of amount of RAM, cores, storage, graphics, network performance, etc., etc. This is being depicted by something called instance type. And instance type is nothing but it's a virtual representation of the amount of compute capacity a specific instance offers to you. We make use of special terms, for example, T2.micro. It has the following compute capacity: 2.5 gigahertz of Intel Xeon processor with 1 GB RAM, um, one core CPU. You can attach from 8 GB to 16 terabyte of SSD storage, and gives you low to moderate network performance. It's basically it is decent to deploy a small application. Fine. Now I show you a list of them. If I go to my let's go to okay. So for example, I go to EC2 dashboard. On the left hand side, okay, I just go to EC2, right? Now once I just go to EC2, I just go to the instance types on the left hand side. Why it's not loading up? Let me just go to a different region. So I just go to the EC2 right now. I go to instance types. It says loading instance types, right? As if now, let's suppose in North Virginia, I have 640 instance types. These instance types, like it's kind of a model for every instance, kind of instance you can deploy. Let's suppose I'll start the first example. T1.micro. Now it gives you one core. It's a one core CPU. This is the architecture we can use for that. This is the memory it gives me, 0.6 GB only. That's it, and very low network performance. T2.micro. It's a one core CPU with only 1 GB RAM and low to moderate network performance. Let's take some more examples out there. Just give it a few seconds. Now, how you decide this test time? It depends on a number of factors. The types of application services you'll be running. Okay, for example, I want to run a MySQL database. I want to run a MySQL database application on the package path instance. In that case, let's suppose MySQL vendor says at least 1 gig of RAM is required. If you want to run a MySQL database on a virtual machine, I need at least 1 gig of RAM. If you want to deploy, let's suppose, a MySQL enterprise level database, I need at least 4 gigs of RAM. Right? So basically, the type of application services you'll be running upon these instances, you have a list of instance type that you can choose from, and whichever closely matches that specification, you choose that. Second thing is that once you start launching the service and applications, because on these instances you'll be launching software applications. The software vendor or the software as a service provider will give you the recommendation that this is the instance type you should be using so that an application can run properly. Right? This is the bare minimum specs that you need whenever you deploy any software. let's suppose forget about instance type. Whenever you download any free software, open source software from the internet, now you see that at least 1 GB storage is required. For it to run properly, at least 1 GB RAM is required. So every vendor gives you a specific specification for its software to run properly. Whether it's MySQL database, Oracle database, Apache proxy server. Let's suppose you have to deploy a Python web application. So when you start deploying the application, the services, based on your past experience, and also based on the vendor recommendation, you have to go for the specific instance types. No option for customized instances. There are more than 640 instance types. Okay, so Amazon has already created a complete list of 640 instance types. You can choose any one of them. Instance type is nothing. It's a make and model of an instance. It's a make and model of instance, right? Don't mix it with Elastic Compute Cloud. Okay. Now, why it's called Elastic Compute Cloud? I'll come to that. It provides resizable compute capacity. Let me just go back. Resizable or elastic. What do you mean by that? This thing. This means that whenever you deploy any instance with a specific instance type, it can be changed afterwards. Okay, we'll come to that afterwards, but we'll discuss the resizing options later on because it will confuse you. You are merging two concepts together. In terms of resizing options, we have two options to resize our instances. One is vertical scaling. Vertical scaling means that you can change the instance type. It says go back. Okay. For example, today you deploy the instance with an instance type T2.micro. Okay, which offers you only 1 GB RAM. Now you say 1 GB RAM is not sufficient for my needs. I need 4 GB. Okay, so what you can do is that you can change the instance type. Of the running instance, right, on the fly. Now, of course, you need to stop this instance first. We'll discuss the process afterwards. Let's suppose I want to have 4 GB RAM, right? So let's suppose I go with T2.x large. I'm sorry. Yeah, sorry. T2.medium, which gives me 4 GB RAM. So in this case, I can change this type of a virtual machine, and I can say that I want to change it to T2.medium, which gives me 4 GB RAM. Right? This is called elastic. This is a kind of a one of the concept of elasticity. This is elastic. It doesn't mean that if you choose the make and model of instance type, you're fixed to it. It's malleable. It's flexible. That's why it's called resizable. Don't confuse that with the definition of the instance type. Instance type is a make and model of the instance. Because you can change the instance types later on of the instances, that's what's called elastic compute cloud instances. Because they're elastic, they're flexible, you can change the instance types or the make and model, or you can add on more RAM storage afterwards. Okay, this is called vertical scaling. There's a next step of scaling which is called horizontal scaling. What do you mean by horizontal scaling? Horizontal scaling means go wide. Now this is AWS recommended. Go wide. You widen up. This is recommended by AWS. This is more beneficial. Recommended. Right? What do you mean by horizontal scaling? So in this case, if you go with vertical scaling, what you do is that you have the same physical. You have the same physical server, right? You're just sharing the instance type of it. You're going from a smaller instance type with 1 GB RAM to a bigger instance type with 4 GB RAM. You're going big, right? Horizontal scaling means you go wide, which means that overall you want to have 4 GB compute capacity. It's all about compute capacity only, right? We're playing around with the compute capacity. Now, I repeat, what's the compute capacity? RAM, cores, storage, graphics, performance. Now, I want to make sure that I want to have the same 4 GB RAM, but I don't want to be dependent on just one instance. I don't want to depend myself on just one instance. Let's imagine on your instance, you're running a Python application, a Python web application. You're running a single application upon it, right? It's a Python web application. The problem with this approach is because you are adding more resources to a single server. What if this single server goes down? At any given point of time, let's imagine this single server goes down. Your entire application is down. Your entire application is running upon this instance. It's down. You have increased the capacity. You're paying extra amount for 4 gigs of RAM, but because you're depending yourself just on a single server. If that single server goes down, your complete app is down. You can't do anything about it. So horizontal scaling means horizontal scaling is the more modern approach. This is basically more conventional and traditional. This is outdated. Horizontal scaling means that you need more RAM. Why don't we have that 4 GB RAM in 4 different instances? So what we do is that instead of having 4 GB RAM in this one instance, I have 4 instances with 1 GB RAM each. Okay. I distribute my request coming from, for example, a load balancer. We discussed that, but I distribute my request coming in, or the data that it has to process. It's being distributed between these different instances. The traffic distribution, basically the traffic or the request distribution, is done between them. Requests distribution it's been done between them, and each of these instances process the request. So basically you're paying the same amount. Over here you're getting 4 GB in one server, but you're getting 1 GB, you're getting the total amount of 4 GB but in different servers. Now the advantage is that you can place these servers or virtual machines in different regions or maybe availability zones. For example, I can say, let's take this example. Let's imagine that the first 2 servers you can see, they are the first 2 servers you can see, server A and server B, right? They are in the region of, for example, in North Virginia, which is US East 1. And inside North Virginia, they are in different availability zones of North Virginia. US East 1A, and this is running in US East 1B. Right? The one which are there, instance A and B are running in, for example, EU North 1, which is Frankfurt in Europe. Frankfurt is labeled as EU North 1. So this is the EU North 1A, and this is EU North 1B availability zone. So what I'm saying is, I'm intentionally putting my instances in different regions and availability zones inside them, so they are less prone to failures. I'm intentionally putting them into different location. Distribution of the traffic or the requests are being done between these different instances. So this is a more modern and more smart approach. This is a smarter approach compared to this one. You're paying for the same amount, 4 GB RAM. The compute capacity you have to pay for is the same thing. But in this case, you are putting that in just one instance. But over here, you're just putting that into 4 different instances. The concept is called resizable or elastic. This is called elasticity. You can change this test type and go to a bigger server, or you can have more servers or more instances with the same instance type. That's why it's called elastic compute cloud, which means it provides a resizable compute capacity. What's the compute capacity? It's the amount of RAM, storage, cores, graphics you get. You can resize into 2 different ways. Either you just go with vertical scaling, you go for a high instance type, or you go for horizontal scaling, where you go for more instances. Okay, what's the next thing? The next thing that we're going to be discussing is called AMI, or Amazon Machine Image. Basically, the instance type that I discussed with you, it is nothing but it's a physical specification, right? Now I'm talking about the software. When you use a laptop or a computer, it's a hardware plus software, right? Instance type is nothing but it's the hardware of the instance, or even though it's in virtual format, it's a hardware. Who decides the software? Amazon Machine Image. Amazon Machine Image decides the operating system of the instance. It can be Linux, it can be Mac OS, it can be Windows, right? Um, it also decides upon the applications you want to run upon them, services, scripts, etc., and additional software. All right. All these things are the part of AMI. And AMI is nothing but it's a pre-configured software template which enlists all the software components of your virtual machine. This is a pre-configured template. This is a software template. Fine. Which consists of the operating system, application, services, resources in terms of software. So it defines a software. Right now, using a most of you are using Windows laptop. Your Windows operating system plus Zoom applications running upon it. Maybe Outlook, Word, Excel. Those are additional software. You're running some applications upon it. So if you bundle that together, it's called an AMI. If we use the same thing in terms of Amazon Web Services. Okay, now let's do one thing. Let's go back. If I just go to the left hand side, there's something called, okay, I go to the EC2 right now, and there's on the left hand side, you will see that there's something called images AMIs catalog. Now, these are the different categories of AMIs that we can use, right? Quick start AMIs, my AMIs. For example, I'll discuss with you few of the things. For example, these are the quick start. Quick start are the commonly used AMIs. Most of the companies use them. Most of the organizations use them. For example, I can show the list of them. We have the Amazon Linux, Mac OS Ventura, Monterey, Red Hat Enterprise Linux, Big Sur, Ubuntu Server, Microsoft Windows Server. These are different packages or different special images with special built-in operating system and some additional applications running upon them. Right. So let's go. These are the commonly used AMIs. You can just filter that based on the free tier only. Free tier only means that they're only used, they can use it with a free tier account without paying any charges. You can browse by Linux and Unix, and also you can browse by the type of architecture. Okay. My AMIs are the one which you create privately. I'll show you how to create a private AMI, which is customized by a customer. So we can create our own customized AMIs that are called private AMIs. There are some AMIs which you can buy from marketplace. There are some software vendors like Microsoft, SAP, Zend, Cisco, Juniper. You can buy the AMIs from them. For example, I want to go for Palo Alto. I want to uh, deploy a firewall, Palo Alto VM series virtual next generation firewall. Now, firewalls are used to secure your infrastructure. Let's suppose I want to deploy Palo Alto firewall uh, on Amazon Web Services. So Palo Alto give me some of the details. If I go to the product details, or let's go to the pricing. Now again, you will see that vendor will, let's suppose I want to deploy Palo Alto firewall. This VM series virtual next generation firewall, 5 core security subs bundle 2, right? My vendor, who is vendor in this case, Palo Alto, will give me the recommendation that please use this instance type C5N.xlarge, because Palo Alto in this case is my software as a service provider. So being a vendor will give me some suggestions. So it's saying that please use C5.N9X large instance. It has some the amount of RAM and CPU based on which this firewall can run properly. Okay. Then if I just see the list, right, it will show me the entire list of the supported instance type. But you will see that I can choose any of these test types. But C5.N9 C5N.xlarge is vendor recommended. Fine. This is called marketplace AMIs. For example, I want to deploy any of the software out there. I can purchase the software uh, from the vendor. I can pay on monthly basis, or maybe I can just go for a software subscription for 1 year or 3-year plan. All right. So this is the thing. Community AMIs are, it's a developer community. It's open source AMIs, which means that anyone, you, me, or any Amazon's account owner, AWS account owner can publish the AMI in the community AMI. It's an open source developer community based AMI. You can see that community AMIs are public, therefore anyone can publish an AMI and it will show in this catalog. Most of them are used for hands-on purpose, for research purpose. So these are the different categories of the software configuration that you can choose from. You can see a clear definition. An AMI is a template that contains a software configuration, including the operating system, application server, and applications required to launch your instance. So it's a software part of instance. The operating system, services, applications, scripts that you would like to deploy upon the instance. Okay. The next thing that we have to understand is that how you connect to these instances that you're going to be running. Okay. Let's imagine you want to connect to these instances. How you connect to these instances? So connecting to your EC2 instances. Now, when you connect your instances, you use certain protocols and port. Okay, these are industry standard. These are not being invented, or these are not being made by Amazon Web Services. Okay. So in terms of connected to instances, Let's imagine this is the AWS cloud. Right? So let's suppose this is a Linux instance, right? Now, you want to connect to it. For example, you're the administrator, you're the admin, right? You want to connect to this instance. From your computer, you want to gain access to this instance. Now, why would you do that? Why would you do that? Because as an administrator, you need to get to the root or the operating system of the Linux instance. You want to get the root access or operating system access or shell access, right? So as an admin, I can say that you need to get root, shell, or OS access. You want to get to the core of the server, right? Why would you do that? Because as an administrator, you have to start with the installation of the software. You have to install some business applications upon the instance. For example, you need to configure something. You need to do with something called patching. Patching means running some security updates or additional software to be deployed. Maintenance, right? You want to do a lot of things. For that, you need to connect to the server remotely. Why use it remotely? Because this instance may be running in, for example, in California, you're in Hyderabad, in India, or maybe in Dubai. So basically, you're trying to connect it over the internet or from far distant location, and you want to gain access to it. Root access, share access, or OS access. So in this case, what happens is that if it's a Linux instance, you're going to be using a protocol. This is industry standard. Protocols and ports are being made. These are being designed or these are being invented few decades back. If you go to Google and type in protocol and ports, you can see a list of them. They're used for communication, right? So the default protocol that you're going to be using is SSH. The SSH uses a port number which is 22. It's a dedicated port number, right? It's a dedicated port number. So SSH stands for secure shell. What is this? This stands for secure shell, right? This stands for secure shell. So using secure shell SSH protocol and port S22, which it uses, you gain access to the instance. You connect to it, right? You access it. So you can access the root, the operating system of the server, so that you can perform your day-to-day job. Fine. You can just do the installation of the software, configuration, patching, maintenance. So as an administrator, you'll be getting access to the instance. So you're the internal administrator, you're the IT software administrator, or I would say that the employee in one of the IT software verticals in your organization. You can be an architect, a list administrator, a database administrator. You can be a developer, a quality analyst. You need to get access to the instance from your end. Okay. Now, for the authentication purpose, we used a certain. Okay, so I think this is understood. We use the SSH for Linux. Now, if you run a Windows computer, I'm sorry, a Windows instance, if instead of a Linux instance, this is a Windows instance, the operating system of this one is different, right? So instead of running a Linux instance, you tend to run a Windows instance, right? This is the AWS cloud that you have, and this is the Windows instance. Now for Windows instance, so basically you want to gain access to the Windows instance from your end. Fine. So for this purpose, or for this type of instance plus Windows instance, the protocol that we use is remote desktop protocol. It is called RDP in short form, and it uses a dedicated port number, which is 3389 3389. Okay, so as an administrator, you want to get to the Windows operating system or to the root of the Windows systems, get the server access. You need to get to the operating system of the Windows, I would say Windows operating system, get to the server access, the root access. Then in that case, for Windows, we use a different protocol, which is the remote desktop protocol, RDP, which uses port 3389. Fine. So the type of instance that you're going to be running as an administrator, behind the scenes, you're going to be using different protocols and ports, port numbers. These are the industry standard, and they've been used from past many decades. So this is the standard protocol and ports we use to connect. Fine. So this is what you do. Now the next thing that comes into this entire conversation is the authentication. Authentication means I want to confirm and I want to ensure that this administrator is the right person who is trying to connect to my instance. It's not the any hacker or any unauthorized person who's just trying to get it to my instance and trying to get access to it. Fine. I want to ensure that only the authorized person can get access to my instance. Right. So you need to authorize, authenticate. Whenever you just use your pins, OTPs, IDs, passwords. Why do we use them in terms of banking transactions or logging to our smartphones, devices? Why we use user ID and passwords? For a reason that only the authorized person is able to unlock the devices. Or we use the user ID and passwords for banking transactions so that only the authorized person can make that banking transaction from a specific account. Right. So authentication is quite important because I want to make sure that no external user which is not authorized can get access to my server. So only my known people can access my instances or the servers. So what's the methodology we use in this case? The method that we use is called key pair. Okay, it's called key pair. In terms of key pair, there are two keys. One key is stored on the admin's computer. It's called private key. Right? It is saved on the administrator's computer. So this is my PC, right? So administrator owns a computer. This private key is saved over there. The Linux instance over here will have a public key. Fine. So private key is stored on the computer which is owned by administrator, and public key is stored inside your Linux instance or the Windows instance. The mechanism, so basically the concept is same in terms of authentication, right? So my instances will have the public keys stored inside them. Okay. Now, when the user tries to connect to any of these instances, at the time of connecting, the administrator has to provide the private key. So administrator says, okay, I am providing the private key. Please match it with the public key, right? So the administrator has to provide it. Fine. So at the time of connectivity, the administrator has to provide the private key which is being matched with the public key. If the match is perfectly all right, then the administrator is able to get inside the instance. You must have seen this thing where whenever you operate lockers in any of the banks. So, for example, you have a locker in Indian Bank, Bank of Baroda, or Andhra Bank, Punjab National Bank. Now, we generally people they own lockers in these banks to store their valuable items. There are two keys that we have to open the lockers. One key is with bank official, other key is with you, right? So, for example, you want to open your locker. You go to the bank premises, you sign the register, and you're being escorted to the locker's room along with the bank official. So you use your key to unlock your lock, and the second lock is being unlocked by bank official because the bank official will have its own key or it his own key, right? So there are two keys used to open lockers. One key is with you, other key is with bank. Okay, the same concept applies over here. To make sure that only the authorized person is able to open the instance and get inside it or unlock the instance, one key is with the administrator and the other key is that private key is stored on the administrator's computer, and the other key is stored inside the instance. So at the time of connectivity, this key has to be provided. And if the private key matches perfectly the public key, the contents are in align with each other, then in that case, the administrator is able to successfully get the remote access to the instance. Fine. So this is the mechanism we use for authentication purpose. This is the mechanism we use for authentication purpose. Fine. So this is exactly the concept is we make sure that we try to access the instance remotely, and it's only the authorized person who's allowed to get in. The concept is we store the private key, the administrator store the private key in the PC, in the local computer. The public key is stored inside the Linux instance or Linux computer. So the administrator is able to get access to the public, is able to get access to the Linux instance or Windows instance by providing the private key at the time of connectivity. Okay. So I just put it over here so there's no confusion. This is the same AWS cloud we have. Right. This is the EC2 instance. It can be Windows or Linux. It doesn't matter in this case. This instance is running upon it. It has stored the public key. Right. As an admin, you are the admin. You have a local machine, a PC or a computer. You have stored a private key inside it. So you have the copy of a private key. Now, at the time of connecting, because you want to connect, right? You want to connect. For authentication reasons, you have to provide this key. This key has to be provided. So once you provide the key, the contents of the key is being matched with the public key. The contents of the private key are matched with the public key. If they align with each other, then you're able to successfully connect to the instance. Let's suppose you're using a wrong private key, right? In that case, it will disconnect you or stops you from connecting to the instance because you're using a wrong private key. So it's a kind of, you can say that you have to provide the right key at the time of connectivity so that you authorize yourself as the valid user, the administrator who is trying to connect. Okay. So this is the mechanism used to authenticate. Authenticate means that you're the right person to connect. This is exactly the stuff. Okay. All right. So we discussed about the protocols and ports we're going to be using. to access the instances of the servers, and to authenticate, we use the key pair authentication methodology. What's that called? Key pair. Why it's called key pair? One key is with you, other key is in the instance. That's what it's called, the key pair. All right. This is what we have to use. Okay. So this is exactly the concept is. All right. So we can get started now with the hands-on. And this is called the AWS Maven console that you can be using to perform all your deployments. Every single deployment has to be done using the AWS account. Now, to get started, first thing first, if you are by mistake have gone to some other location or service, on the left hand side, you can just click on the AWS icon and you'll be back on the home page. You'll be back on the home page after that. Okay. And once you're back to the home page, I'm just putting off just turning off the Google Drive, sorry, the chat box so that we can start now. All right. So in this case, we need to start with the basics, which is getting started with the Amazon EC2 Linux instances. And the very first thing is that we have to go to the EC2 dashboard. Now, how to go to an EC2 dashboard? You will see a list of services on your home page. You go to the search menu at the top. Now, you can see the list of services in the recently visited section. Okay. Now, if you don't see the list of services, you can click on view all services. You can see the services like this, and you can see more than 100 services. Fine. So these are the services that you can see on AWS. And on the left hand side, you can see there is also a kind of a grid. You can just go to services and you can see the list of services based on different categories. But it's very tough to just find your specific service in the list. There's a search menu at the top. You can just search for the exact service you're looking for and it will show up. So for example, let's type in EC2. Once I just type in EC2, I click on the EC2 right now, and this will just take me to the EC2 dashboard. Okay. So we are on the EC2 dashboard right now. Okay. So we are on the EC2 dashboard. Now, the next thing that you have to do is that, so we have done step number 1. Let's do step number 2. Okay. Step number 1 and step 2. So once you just go to the EC2 dashboard, you land on this page. From this is where you can deploy your instances, and also you can deploy other resources like load balancers, elastic IPs, auto scaling groups, EBS volumes, and so forth. There are a lot of things you can deploy. Right now, we need to deploy instance, so we'll be focused on that one. But one thing we need to understand that once you go to the EC2 dashboard or any service, you can do that before or after. You need to change to the region of your choice. Right now, on the right hand side, you can see a list of regions out there. Okay, these are the regions that you can access to deploy your instances into, because right now we're going to our main preference is to deploy an instance. Now, you can choose any region of your choice, but I would strongly suggest you to use North Virginia. Okay. Now people will ask me the reason why exactly you say North Virginia, because there are few regions which have some issues in terms of the free tier resources. See, right now you guys are using a free tier account. A free tier account consists of some free resources. All right. For example, instance type T2.micro. Mumbai, for example, it doesn't have sufficient T2.micro free tier instances. So sometimes you may bump up to an issue where you're trying to deploy a free instance in Mumbai and you get an error message, insufficient capacity. So there are few regions which are problematic, which doesn't give you enough free resources when you want to launch them. Using North Virginia will guarantee that you will never face shortage of or scarcity of free resources. Okay, use North Virginia for your hands-on. Number 2, Staying to only one region will ensure that you don't scatter your resources unnecessarily in all the regions. See, what happens is that when you start launching resources in multiple regions, at the time of removing them, you sometimes get confused. Okay, so if you have all these sources in one single location, tracking the resources and removing them becomes much more easier. See, we are not working in a business environment. In business environment, everything is well documented. How many tests are running, how many load balancers are running, how many buckets are there in each region, how many databases are there. Everything is very, very well documented. So of course we're not documenting anything in this case. We're just using this for the hands-on. So to make sure that you keep a track of the resources properly and you can remove them when the time comes, stick to only one region. Okay, so in this case, put all your eggs in one basket only. At the time of breaking them, you know that you have to drop the entire basket. So choose only one region and preferably use North Virginia. You will never face any issues. So once I choose North Virginia, this guarantees that now the instance that we're going to launch will be launched inside the North Virginia. Okay. So switch to North Virginia region. Step number 2, based on the document, let me know so there. Let me know once you have done this thing. Now, once you start launching your resources, for example, load balancers, auto scaling groups, buckets, to create a cohesion or to create a complete robust infrastructure, you have to use that region explicitly or exclusively deploy all the resources inside that region. Okay, fine. So use North Virginia for all your hands-on. This will make sure that you don't face shortage of the free tier resources. There's no scarcity of them. Plus, sticking to one region will guarantee that you don't unnecessarily put the resources in other regions. And at the time of deleting those resources, it becomes easier for you. Fine. Okay. So this has been done. The next thing is that now I'm going to bit slow so that you become familiar with the entire web page. I should step number 3 and 4. Okay, step 3 and 4. Based on documentation, you can just refer to the same screenshots and the documentation. It's very easy. Step 3 and 4 based on the documentation. In the middle of the page, it says launch instance. To get started, launch an Amazon EC2 instance, which is a virtual server in the cloud. You go to launch instance, okay, and it says launch instance. Click on that. It says name and tags. First thing first, we can put any tag over here. Let's suppose you put it as demo web server. Now, even though it's not mandatory to put any tag in this case, it's purely optional. But because it's a best practice to tag your server, because later on tagging helps you to name the servers, recognize them, to perform automation, and also to extract build reports. So initiate the process to launch instance and put any name over there. Demo server, my server, whatever you want to just type in. It's a simple name that you're going to just put over there. It's just for the sake of naming it. You have to start with the launch instance. Plus, you have to tag the instance right now. Again, this is tagging the instance is not mandatory, but based on the best practices, business best practices, you should always tag your resources. Okay, what's the next thing? The next thing is application and OS images. 5th and 6th. Once you put a tag or you just name the server, the next thing is the application and OS images in the form of AMI. Okay. You have to decide upon that what is the software configuration of the instance. Now, in this case, we are choosing the operating systems. Now, in the quick start, you have the Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, Debian. Right? These are the few choices that I get. I can click on browse more AMIs to look for more AMIs. I can just go to the drop down menu. I can see the entire list. Okay. Right now, okay, by mistake, I've canceled this thing. Right now, what you have to do is that you have to just go with the Amazon, the default value. Hang on 1 second. Which is the Amazon Linux AWS. Now, this is the Amazon's own proprietary built, developed Linux-based operating system. a Linux distribution. It says Amazon Linux 2023 AMI. It's a free tier eligible. Whenever you see the label free tier eligible, this means that this is free of cost. You don't have to pay even a single penny for it. Okay, there are some of the details that you can see. Most importantly, you have to see the AMI ID. Now, what is this AMI ID? AMI ID is nothing but it's the auto-generated identification code for this image, right? It can be same for all of us. It can be different based on regions. So there's a high probability that if you're using North Virginia, the Amazon Linux AMI ID of all of us is same. Okay. So AMI ID is the auto-generated value. And when we start using templates, like for example, CloudFormation to automate the infrastructure, we have to provide these AMI IDs over there. If you don't use GUI, the graphic user interface that we're using right now, the console, if you use automation or CLI, you have to, or the command line interfaces, then you have to provide the AMI using the AMI IDs. So right now, AMI ID is not very, it's not important for us, but for the future reference, it is important that you understand this thing that AMI IDs is quite important because when you start with the automation of the processes, you start creating templates to automate infrastructure. These AMI IDs need to be provided at that time. So every image has a unique AMI ID assigned to it. What's next? You don't have to change the architecture. We just go with 64-bit x86 architecture. You can also go with ARM architecture, or just go with 64-bit x86, which supports a lot of applications. Instance type. Instance type means that, as we discussed earlier, it is the hardware specification of the instance. They want a RAM, CPU, storage. You can see a bunch of list, but we're going to be going with the T2.micro, which is free of cost. And you can see that it is a free tier eligible instance type. So this a free tier eligible instance type is free of cost for us. We don't have to pay for it. There are the free tier instance type like T1.micro, T3.micro, but we're going to accept T2.micro as a default instance type. So basically, you just have to look into the details. You don't have to change the AMI. Just go with the Amazon Linux 2023 AMI and instance type as T2.micro. What's the next thing? The next thing is the key pair logging. I'm talking about the step number based on the documentation. I'm talking about the step number 7. As per the step number 7, what you're going to do next is that you have to click on create key pair login. This key pair login is the same concept that we discussed. Which concept? This one. Private key, it is stored on a computer, which has to be provided at the time of gaining connection to the instance, and the instance has a public key embedded, or it stores your public key. So the time of gaining connection, you have to provide this private key to instance, and if it matches perfectly fine, if it aligns with the contents of the public key, then you're able to get access to the instance. So to create a key pair, you can see that you can use a key pair to securely create your instance, right? Click on create a new key pair on the just right hand side. Fine. So it says key pair name. You can put any key pair name. It doesn't matter whatever name you just choose in your case. You can just put any key pair name. For example, I name it as, let's suppose, demo, or let's suppose WP-KP. Anything. I would say that you can put any name over here. For example, name it as Intel server-KP. I have a lot of keys stored, so just to avoid duplication, I'm using kind of a complicated name. You can put any name in the key pair. Okay. Now the thing is, there are two standards we use for the key pair type: RSA and ET25519. We always use RSA because RSA can be used for Linux and Windows both. In the private key file format, will not change this thing. That I discuss with you tomorrow, because the format changes based on what's the type of client software you're going to be using. Format means it's let's Let's suppose we have the format of the images JPEG, PNG, or we have format of the documents like docx. For spreadsheet, we have file extension like XLSX. For PPT, we have PPTX. So it's a format of the key. What's a extension of the key? In what format? In PEM format or PPK format? So basically, what you have to do is you just have to click on create new key pair and name the key pair. That's it. We never ever change the key pair type. The industry standard is RSA, which can be used for both Linux and Windows instances. And as if now, don't change the private key file format. Okay? Don't change it. What's next? The next thing is that you can create key pair and the key pair will be saved on your computer. If you go to download section, if you go to downloads folder, you will see that the key is being saved. The key pair is being saved. Okay, this is the private key, right? This is in printable encoded archive. So basically, this is the PEM key that you have downloaded. This is a private key. I'm sorry, yeah, in PEM format. You need to provide this key later on if you want to connect to the instance. Fine. Okay. What's next? The next thing is you have to go for the network settings. Steps 8 and 9. In steps 8 and 9, what we're doing next is that you have to go to network settings first. Now, under network settings, you don't have to change anything. This concept is called VPC or the virtual private cloud. Okay. What is this? We'll discuss this thing in depth because there's a complete section dedicated to VPC. A VPC is a your own virtual data center on the cloud. In this case, whatever you're going to launch is inside your own private cloud. It's a virtual private cloud. It's called VPC, right? Virtual private cloud. So AWS says that we give you your own virtual data center, your own private cloud. And when you deploy resources in that cloud, those resources are not visible by other customers. Okay. So if I deploy my resources in this VPC, you can't see that because it is owned by me. So basically it protects my resources. VPC stands for virtual private cloud. It's a virtual data center which we get inside which all our servers have been deployed. This gives us security and privacy. Okay. I'm not touching upon the networking components as of now because there's a complete section dedicated towards that. The important thing that you have to do is that you have to go to security groups. Now, what it says, we're trying to connect to a Linux instance, or we're going to launch a Linux server. Now, for Linux, we use SSH to connect. Okay, if I just go back to the diagram, if you just go back to this diagram that I created, this drawing, you're going to be using SSH as a protocol to connect. This is what you're going to be using. SSH as a protocol to connect. Okay. Now the thing is, you'll be trying to connect from your machine, from your PC, which stores your private key. Now your machine is on the internet, or it's in your data center or in your company's network. This PC is getting an IP address. Okay, the IP addresses are unique in nature. They are unique. No two public IPs are same. I want to say that only from this IP address, the unique IP address, someone can SSH or initiate this SSH connectivity. IP address basically recognizes your machine on the internet. Your machine is getting different IP, my machine is getting different IP. No two IPs can be the same. I'm talking about public IPs. We'll discuss public IPs afterwards, but the IP addresses which your machines get are completely different from others. They are unique. So I'm saying that only my admin's IP address is eligible to initiate the SSH connectivity, because if you're going to be using a computer, right? Only your computer's IP address is recognized to get access to the instance via SSH to connect to it. So in this case, what we're saying is that allow SSH traffic from anywhere. Anywhere is 0.0.0.0.0.0/0. This is a security threat. This means that any machine on the internet can get SSH access to my instance. You can see that. Rules with the source 0.0.0.0.0/0 allow all the IP addresses to access your instance. So for security reasons, we choose my IP. Right now, what we will be choosing my IP. This will pick the IP address of your computer, which your computer is getting, so that only from this computer that you're working right now, you become eligible to connect to the instance. You can choose a custom IP range, but I'll choose my IP. Okay. So this will automatically ensure that only your computer's IP is eligible to initiate the SSH connectivity to the instance. Then what about launching a website upon the instance? For accessing the websites, we use two protocols, HTTP and HTTPS. Right? When you go to Intellipaat.com, you or Google.com or Facebook.com, you use the HTTP or HTTPS protocol, right? So if you're trying to host a website, you can check both of them. If you now HTTPS is a secure version of HTTP, but it needs some certain provisions. We choose both of them. It's because we're going to deploy a website upon the instance. Okay, so basically, you don't have to change any one of the network settings on the top. You have to configure the firewall. You allow the SSH from your computer's IP only, because you, as an administrator, only from your computer, it's only your computer from where you can access the instances operating system. Fine. Plus, if you want to deploy a website upon the instance, you allow the HTTP and HTTPS traffic coming from the internet. What's the next thing? The next thing is that you don't have to do step number 10, straight away go to step number 11. What I've done is that I've given you 3 documents, out of which there's one document which is a script. The name of the document is this one. Okay. Now, in this script, we're going to be using to install the website or Apache web application upon the instance. This script will automate the web application deployment upon the instance. Now, this is a bash script which will run some updates upon my instance, install the HTTPD. Now, HTTPD is for the Apache package. Start the service, change the directory to the HTML folder, and configure the index.html page inside it. Right? Now you have to copy this entire script as it is. Go back to the last category that's called advanced details. And under advanced details, you have to go to the last category, which is user data. You need to paste it under user data. Okay, what's the next thing? You have to straight away go to the 12th step, step number 12. You need to just go back, and on the right hand side, you can see a summary. Click on launch instance, and instance will get launched. On the right hand side, you have a summary table. What's next? The next thing is testing. Step number 13, 14, and 15. You need to go back, click on the instance ID. Now, this is your instance that you just got deployed. Your instance gets a unique instance ID. There's a checkbox which is on the left hand side. You need to select it. Once you make the selection, you will see that there's a tab that's called details. Under details, you have this thing called public IPv4 address, or it's a public IPv4 DNS name. Right. This is basically used to access the your instance over the internet. If you're using internet as a medium, and let's suppose you want to access the website upon it, or maybe you want to SSH to the instance, then you're going to be using the public IP address. So public means internet. What to do next is that you need to just go ahead and copy the public. There's a copy icon. Click on this copy button and paste that in the browser. And you will get this thing displayed. So there's a simple HTML page we have deployed, and this shows us the result. Now, if you're not able to browse a page, make sure that if it's showing you HTTPS by mistake, remove S from HTTPS. Just in case if it says page can be displayed, make sure that by mistake you're not trying to browse the HTTPS website. Remove S at the end of it, because to configure the HTTPS, we have to also configure the SSL certificate. We haven't done that. Yeah, great. Yeah, by default it got HTTP, but sometimes it gets to HTTPS based on browser settings. Okay, so this is a simple website you have just deployed upon the instance using a script that I given to you, and this is a simple procedure that you have to follow along to deploy your instance in AWS Cloud. Okay, great. Now, guys, once you're done with this thing, before you log out, you terminate the instance. Terminate means that you don't need this instance anymore. You want to get rid of it. Now, how to terminate the instance? Now, either you right click on the instance, you have the options from where you can just stop, reboot, or terminate the instance. Or you select the web server, go to instance state, you can stop it. Stop means you can come back and restart it. Reboot means you can reboot its operating system. And terminate means that you're trying to kill it. You can't get it back. So either you right click, you can see there's a terminate option, or you just go to test state and click on terminate. It says terminate instance. I sure want to do that. You click on terminate, and this will lead to the termination of the instance. This, I think, procedure is laid out in step number 16, 17, based on the documentation. Step 16 and 17. Fine. We discussed briefly about security groups, and I should just deep dive inside that, or dive deep into that concept and make you understand exactly what the purpose of security group is. All right. So basically, we want to understand this thing is that security of our resources is our priority, right? When we go to cloud and we start launching our resources into the cloud, our applications, websites, databases, backend servers, processing servers, whatever you want to launch inside cloud, one of the priorities that we have is security, right? Priorities means that in terms of priorities, we mean that we want to make sure that we have all the things achieved and we get the same sense of reliability, security, high availability as we would expect in our own data centers, right? So you're shifting your entire application and services and you're putting them on the cloud. Now you want to achieve the same sense of same type of security, reliability, performance, right? So you have expectations in those areas. The question that comes into this entire place is that what are the security mechanisms that we may employ or we can engage so that our instances and the data can be easily protected? The very first thing that you need to understand is that in terms of the resources, provisioning, and security, one of the first things we can use is the keys, right? Private key and public key. The concept behind private key and public key is that you have the private key saved on a computer, right? So in this case, only that individual that has a copy of that private key will be authorized to connect to the instance. Connect means to get the remote operating system access. You can get into the machine, get to the shell, get to the operating system, and you can perform installation, configuration, patching, maintenance. So you want to do server management. You want to get the root, shell, or OS access. So if you have the exact copy of the private key saved on a computer, and you provide that private key at the time of getting connection, then in that case, you're being authorized to gain that access. This is one of the security mechanisms that we use. Fine. The second thing that we use is the protocol and port. This is the second level at which we apply the security. First level is keys. Second level is that we apply the security on two protocols, SSH and RDP. Because remember, if you want to get the admin type of access, administrator type of access to a server or to a remote instance, for Linux we use SSH, which stands for Secure Shell, it uses port 22. So to get a remote access to Linux server, you can be using SSH secure shell port 22 request being sent towards instance. And for the Windows, we make use of remote desktop protocol, or it's called RDP, which uses the port 3389. Okay, so protocol and port. This is what we're going to be using. This is what we're going to be using to gain access to Linux and Windows instances respectively. These are the two protocols: SSH port 22 and RDP port 3389. This is what we're going to be using. These are the two protocol and ports that we shall use. Fine. So you also need to make sure, because these two protocols give you the administrator access, core server access, shell access, root access to your server. You need to make sure that it's coming from the wanted IP, I would say known IPs, right? So it's not that anyone can send the SSH traffic to the Linux instance and get access to it, right? These two different types of request or protocols need to be restricted. This means that only handful of people I'm aware of should be able to initiate these two connectivity options or connections towards my instances. If let's suppose there's a hacker who wants to get inside my server, he or she tries to use SSH or RDP immediately, because the IP addresses that I've listed, the IP addresses is not in the list, they will be blocked immediately, right? So apart from the private key, I also make sure that the SSH and RDP comes from known sources, from known people. Okay. So that's where the security group comes into this entire conversation. What is a security group? Let's try to understand. Let's dive deep into this concept and try to understand that. So what is a security group? Okay. So a security group is nothing but it's a virtual firewall. It's a virtual firewall which restricts the incoming and outgoing traffic. So basically, this is a virtual firewall. Is a security group is nothing but it's a virtual firewall through which you can impose restrictions in terms of the traffic that's coming in, or it's going out from instance. What do you mean by that? So for example, this is my AWS cloud, right? This is the Amazon Web Services cloud that I have. And this is an EC2 instance that we are running. This is an EC2 instance which we are working on. Fine. Now, I want to impose restrictions in such a way that any traffic that's hitting my instance, right? So if a traffic is coming from outside and it's reaching instance, from the instance perspective, what type of traffic we are dealing with, right? It is incoming. It could be inbound. So these are the three terms, but the meaning is same. Or it could be something called ingress. Okay. Incoming traffic, inbound traffic, ingress traffic, that's the traffic that's coming inside the instance. So the traffic is coming from outside. It's hitting the instance. Think from instance perspective. If you are the instance and traffic is coming and reaching you, from your perspective, that traffic would be the incoming traffic, the inbound traffic, or the ingress traffic. These are the three words with the same meaning. Okay. What if the traffic is leaving the instance is giving response back to the user? If the traffic is it's left out, it's being sent out from the instance, this is the egress traffic. or say let's outgoing, outbound, or it's called egress or egress, right? This is leaving the instance. This is basically instance is responding and the traffic is going out from the instance. Fine. So egress, outgoing, or outbound. So these are the two type of requests that we want to restrict. Okay. So a security group basically is a virtual firewall which performs restrictions at two levels. Number one, incoming. Number two, outgoing. Fine. We need to perform restrictions. Now, to perform restrictions, we use three filters. What are those filters we're talking about? Filters that we use during our school days. Now we used to do the experiment of sedimentation, uh, condensation, filtration. Now we used to have a beaker of glass, and then used to have a sandpaper or kind of a bloating paper, and we used to the water used to have a lot of mud and sand inside it, maybe the sand particles, and then if we just put that on filter paper on the sand or the that bloating paper or sandpaper, then in that case, the sand will be filtered out and the pure water goes inside the beaker. Okay, so that's we use that filtration process. The same filtration process we kind of filtration process we apply over here. We saying that we filter through only that traffic which we want. Okay, so there are three types of filters that we apply. Number one, the very first filter that we have is the protocol. The second filter is port. And the third filter is IP address. These are the three filters that we make use of. Okay. Uh, Protocol, port, and IP address. These are three filters we use. Based on these three filters, we restrict the traffic that's coming in or the traffic that's going out. Okay. Protocol, port, and IP address. These are three filters that we make use of. I'll give you examples. Try to understand those examples. I'll give you three scenarios. First two scenarios are simple, right? So I'll give you two scenarios, first two scenarios, and then I'll merge the first two scenarios and put that in a bigger picture or bigger perspective in a third scenario. Let's start with scenario number one. Try to understand it. It's a very simple, and even though it is a very simple concept, it is equally important. Scenario number one. Scenario number one is that let's suppose I want to have the users access my web application. So this is accessing, or you want to allow your end users to access your web application. Okay, this is the scenario number one. What do we mean by this thing? Let's try to understand and put that into scenario. Okay. Yesterday we deployed a website upon the instance. That website was accessed using its public IP. Now, if you would have given that public IP to any other person, maybe if you have put that public IP in the chat box, other person will also be able to gain the same access to your website. Okay. So what is happening behind the scenes? Behind the scenes, we'll just take the same example over here. Behind the scenes, we have the AWS cloud, right? This is an EC2 instance that we have. Right? Which is running the Apache PHP web application upon it. Right? We deployed, we would like to deploy an Apache PHP web application. All right. So this is the application running upon the instance. Now I want my customers who want to access my website. These are my end users. These end users would need to access my site. So what they were going to be doing is they would be sending these two types of requests, right? The first type of request that they would be sending would be the HTTP request. So HTTP, right, which uses port 80. These are standard ports. These are already being set for us. We use them. All right. Now, if you want to make a secure access to the instance, then we use HTTPS. OSS stands for secure. This gives you secure HTTP access. It uses port 443, right? Port 443. So if you want to allow the front end users, the customers who want to go to your website, see your products and services, buy items, stream videos, these are the two protocols and ports that you want to allow, right? And in this case, once the instance gains the incoming request, it sends it back to the end user in the form of response, and the response will be HTTP. So basically, it will send the response to the end user in the form of HTTP or HTTPS. Outbound, right? So that response will be sent back to the customers. Fine. So these are the two levels at which we apply the protocols and ports. What about the IP addresses? See, I don't want to restrict anyone from accessing my website. Today, for example, Intellipaat.com has its website running. You have the Facebook.com, Google.com, Instagram.com, Microsoft.com. Anyone from any location, from any country, from any location can access these websites. How? Because in that case, we define the source IP. From where this traffic is coming from? We use the source IP as 0.0.0.0.0/0. This means that any IP, this means that any IP or from anywhere. Okay. This means any IP. This means that any customer who's getting any. So basically, what do you use? Your devices, your smartphones, your tablets, your computers, laptops. Your devices get the IP address. For example, if you, I'm talking about the people who are from non-IT background. If you either type in IP config or command prompt, or just type in this, for example, just go to Google and just type in my IP. It will show you computer's IP. Right? What's my IP address? If you just go over there, it will show you your computer's IP. Right? So you can also run IP config on your command prompt, or just type in what's my IP address.com. It will show you exactly what is your IP address that your machine is getting. Right? Whether you use your smartphone and you just access the internet, use a computer or a laptop or a tablet, whatever device that you run, if it is on the internet, it can access internet connectivity. Then in that case, what happens is that it gets an IP address. Fine. Now, when I just put in 0.0.0.0.0/0, it means it doesn't matter what's the IP address coming in. Please allow those users to access my website by sending HTTP or HTTPS request. So anyone is welcomed. You don't want to restrict anyone to or if it's a intranet site, your company's website which is only be used by internal employees, that's another thing. But in terms of websites which are public in nature, Amazon.com, eBay.com, Flipkart.com, Facebook.com, Microsoft.com, Intellipaat.com, they have to allow the incoming HTTP and HTTPS requests from all the sources. It doesn't matter which IP address your computer is getting. From your computer, you should be able to send these type of requests to a certain web application. Okay, that's the incoming request. What about the outgoing? Of course, in outgoing, we send back the HTTP response or maybe HTTPS. Generally, it's HTTP only. In terms of outgoing, you're saying the destination address, the destination, the destination IP is any IP with 0.0.0.0/0, any IP. So send it back to any. So there's no filter I'm applying. I'm saying please send it back to the customers. So basically I'm saying the request can come from anywhere and the request can be sent out anywhere. So this means I'm opening this in terms of IP addresses. I'm not performing any restrictions, and this is my requirement. If I block the IP address, I only allow certain IP addresses to reach my website. Only those IP addresses can do that. Rest IP addresses will be blocked automatically, which is not a favorable thing in terms of the public websites. Fine. So these are three filters we have applied over here. Let's go with the scenario number 2. Scenario number 2 is that we are talking about now in terms of scenario 2. In scenario 2, we want to make sure that we perform restrictions. We perform restrictions for admin access. Right? We want to make sure that only the authorized people can get access by SSH or RDP. So in this case, for example, I have this is the AWS cloud which is running. Okay, this is the same AWS cloud which is operating, which is running right now. And let's imagine I have two instances. Right, this instance is Linux, and this instance is Windows. Right, so I will put this thing in the middle. Okay, now I want that I need my administrators, my internal IT administrators, to gain access to these instances and get access to their operating systems. They get the root access, the admin access. So right now, for example, you're going to, let's suppose I go to Intellipaat.com, right? I go to Intellipaat.com. I'm sending the HTTPS request to Intellipaat.com and seeing the website. But this doesn't mean that Intellipaat is giving me access to the server on which this website is deployed. This website must be deployed on a Linux server, maybe a Windows server, right? It must be running on a server. That server has shell, operating system, everything. So Intellipaat.com is giving me access to the website, but not to the server or the operating system on which this website is running as an application. Fine. So I can only see the front end, but I can't see the back end. I only see the front end, but I can't see the back end. Now, you must have heard about this thing in terms of full stack development or in the website deployment. There's something called front end development and back end development, right? Front end means we only see what we get access to. This is a front end. At the back end, the server is running this application. So the front end is given to the users. I am the customer of Intellipaat, and Intellipaat.com says we give you the front end access, but the back end access is with our internal IT and software people, the architects, right? So in this case, we get the front end access. What about the administrator access to the server? Or I would say access in terms of getting access to the operating system, shell, or server management, so that you can perform day-to-day patching, upgradation, deployment, and so forth. So having said that, let's imagine this is my office building, right? This is my on-premise. This is my branch office. Right. Now inside this branch office, I have a bunch of employees that come into any one of these categories: solutions architects, administrators. Uh, they must be, for example, developers, right? They need to access to the server on daily basis, on frequently basis, whenever they want. Let's talk about the Linux server first. They would like to initiate the access. For the Linux server, the access that they will initiate would be the SSH request, which uses port 22. Okay, they should be able to send the SSH request to the Linux server, and the connection will be established. The question that releases in this case is that from which IP address I will initiate. I should not. This is you should not allow in from business point of view. You should never ever allow the SSH request from this IP. Instead, you should allow that from known IP address. For example, my branch office is given this IP address 54.78.1.0/24. Okay, /24 means that it's a block of IPs. This is a block of 256 IPs. 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. So it's a block of 256 IPs. 256 known IPs. So I want that only from these 256 IPs, which belongs to my branch office, anyone can get access to my Linux server. Out of these 256 block of 256 IPs, I'm sorry. Out of the out of the block of 256 known IPs, or a chunk of those 256 IPs, like 54.78.1.0, 1.1, 1.3, 1.4, 1.5, 1.6, right, up to 1.255. Any IP falling is in this range can initiate the SSH access to my Linux server. The rest of the IP addresses will be blocked automatically. For example, if there's a person with a different IP address, so basically this is a block of 256 IP. So it will start from 1.0, go up to 1.255. So any machine in my branch office which falls in this range of IPs will be able to initiate a connectivity request to the Linux server via SSH. I can also apply this thing to my administrators, right? So these are the admins in the same branch office. So they can send the RDP request, which uses port 3389 towards the Windows instance. So these are the admins in the same branch office. Then need to send the request to the Windows server. Fine. So in this case, what we do, we ensure that we restrict these two protocols. SSH uses port 22, RDP uses port 3389, and we just restrict these two IPs. The list of two protocol endpoints, SSH uses port 22, RDP uses port 3389. These are restricted protocol endpoints, which should be allowed from a bunch of known IPs. Fine. You can't allow access from any IP for these two protocols and ports. Okay. So that's how you perform the restrictions to make sure that the SSH is and RDP is allowed from a bunch of known IPs. And in terms of HTTP and HTTPS, you can allow the traffic from anywhere. Okay. Let's merge these two scenarios together. Let's merge these two scenarios together. So in terms of these two scenarios, let's go with the third scenario. Scenario number 3. This merges web application or admin and website access, both. This allows the request coming or reaching my instance in at two different levels. You get the admin access and the website access both. This is the scenario number 3 we're going to be discussing. Okay, having said that, let's go with this thing. This is the AWS cloud that we have. Okay, and inside this AWS cloud, we have this EC2 instance running. This is a Linux instance. Upon this Linux instance, I have the Apache PHP web application. Right? Now, what I will do is that I will just have two categories of users accessing this Linux instance. Category number 1. These are my end users who will be sending either the HTTP request over port 80 and HTTPS request over port 443 from anywhere. Okay, so they will be sending the request from any IP. The second category of the users would be my Linux administrators in my branch office. So this is my, let's suppose, corporate office. It is being assigned an IP address of 32.15.1.0/24. I have a bunch of Linux administrators who are sitting in this office, and they need to get the access via SSH. So they will be sending the SSH request over port 22 from this IP address range. Okay, so I merged these two scenarios together. In the first scenario, we give HTTP and HTTPS access to the end users, and the second one, we give the SSH and RDP access to the admins. So this is a Linux instance upon which I'm running a simple web application. So because of that, I want to make sure that these two different categories of users can gain access to my instance at two different levels. The front-end access is given to the end users, and the back-end access is given to the Linux administrators in my office. So through this method, I apply security for my servers or instances. And of course, these administrators will be using the private keys for further security. So they will have the copy of the exact private key so that they can authenticate that they are the authorized user to gain connectivity by SSH. Having said that, this is exactly what a security group concept is all about. Fine. Okay, I'll also show you the hands-on of this one as well. Okay, let me show you the implementation of it. Let's imagine, so you can create security groups in two different forms. Either you can just apply that when you deploy this test. For example, I go to EC2, right? And once I go to the EC2, I go to launch instance, go to launch instance. This is what we did yesterday, right? This is the step that we performed. If I straight away go to this thing called firewall security groups, you can see that a security group is a set of firewall rules that control the traffic for your instance. So you can click on create security group, or you click on select the existing one, and you can see the existing security groups in the list. So I click on create, and once I choose it, this is the name that it will assign to it. Launch visit 56. Okay, these are default names, and I'll just pick it up. And this is from where I can say allow SSH traffic from anywhere which is not documented. Now for the hands-on, that's okay, but from business point of view, this is not okay. So I can choose custom source. For example, I can define the IP address of my corporate office. Okay, I can do that. This is the IP address of my branch office or my corporate office, and any IP falling in this range would be eligible to send the SSH traffic to my instance. Else, I can choose my IP, and automatically it picks the IP address of my computer. If you see that 103.211.15, this is the same IP address which my computer is getting. If I just go to what's my IP address.com, this is the same IP address which my machine is getting. Okay, so this means that only from this machine I can send the SSH request to my server or to my instance. And if I deploy an application, I can allow HTTP traffic from the internet and even the HTTPS. Okay, so this is the first way through which you can go ahead, and this is one of the two ways through which you can configure a security group at the time of instance deployment. That's the first way out. The second way out is that if you go to something called EC2 dashboard, you can see a bunch of options laid out. I'm talking about the thing which is called resources. This one. Under resources, there's a separate section or option for security groups. You can just go over there, or else if you just go to the left hand side in the navigation menu, you can see that we have the security groups laid out over here. This one and this one. Okay. If I go to any one of these two places, I'll land on the same page, which is the security groups page. Okay. I will just go to the same page. I will just go ahead and click on security groups. Fine. I already have a bunch of them. Let's suppose I want to create a new one from beginning. Now, when I create it from beginning, I can apply that at the time of instance launching. So I can select an existing security group and choose anyone in the list. So for example, I click on create a security group. The very first thing it will ask me for the name. I can put in any name over here. For example, just type in Intel Linux web server. Now this will give me the detailed configuration of the security group rules. I'll show you that. I can put something in the description. For example, this allows SSH, my SQL, and HTTP access, HTTPS access. Okay, HTTPS, HTTP, and HTTPS access. So this is a description. Basically, this is just for the documentation purpose. So you put a name, you put a description. Basically, in the description, this is for the documentation. You just type in exactly what you're going to be achieving through this configuration, right? You put a name, you put a description, and don't go with the VPC as if now. We go with the default value. VPC concept we'll discuss later on. But the VPC means that it's a small network. It's a dedicated network for you. Okay. We straight away head on to inbound rules. I click on add. So there are two categories. Inbound for the incoming request or ingress request. This is the inbound. And this is the outbound for the outbound or egress or outgoing. So for example, I go to the inbound rules, click on add rule. Okay. Now once I click on add rules, I can add multiple rules out there. I just go ahead and start adding the first rule. For example, if I go to the type, I can choose the list. This is the list of protocols I have. This is the list of protocols I have. Can you see that? It's a complete bunch of, it's a complete list of the protocols, right? So when I deploy this test, I can only choose SSH, RDP, HTTP, HTTPS But now once I create a new one from beginning, separately, I can choose a lot of protocols in the list. For example, I choose HTTP. Now, once I choose HTTP, automatically it picks the port number 80, right? And in the source, it will ask me from which IP you want to allow the HTTP access. So, is it my IP? You never do that. You never allow the HTTP from a known IP. Basically, you choose either anywhere IPv4 or anywhere IPv6. You can choose any one of them. Generally, we just go with anywhere IPv4. It is 0.0.0.0.0/0. So I just put a description. This allows this allows the end users to access my website. Okay, so you put a description so that you can easily make it more presentable. You configure things properly. Basically, when you start configuring the things in a production environment, then in that case, what happens is that in a production environment, you want to make sure that everything is well documented. Because if you're including a rule, you should be putting in that exactly what that rule means, what exactly you're going to achieve from that specific configuration that you're going to apply. I can add another rule. For example, I can choose HTTPS from anywhere IPv4. So I want to allow the end users to access my website securely, because this is the secure version of HTTP. Then, for example, I can choose, let's suppose, SSH from custom source. I can choose my IP, for example. So I would say restricted. Let's suppose I choose a range, a custom range. So I choose custom. I choose 54.67 1.0/24. So restricted SSH access from my branch office. So only the people in my office will be able to access my website or the web server or the backend server, the operating system of it, the root access. I think I don't have to allow MySQL. We'll just remove. Okay. Now let's imagine that you're running a MySQL package upon this instance, MySQL database on the same instance. So I can just look for, let's suppose, MySQL. I'm running a kind of a database package, a database upon the same instance. So I choose MySQL, and I want to restrict it. So I can choose the same IP address, 54.67.1.0. So this is the restricted database access, MySQL access from my database admins, right? So I'm saying that only, let's suppose I'm running a MySQL database upon this Linux instance, and I want only my database administrators to gain access to it. So I can restrict those IPs, because MySQL is also kind of restricted IP. You don't allow the MySQL access from anywhere. Okay, this is just an add-on. So in this case, these two protocols are open. Generally, these two protocols are open. HTTPS, these are open ports and protocols. You learn from anywhere. Rest of them, most of them are restricted, including SSH for Linux, RDP for Windows, even MySQL for databases. These come under restricted categories. Fine. So once I do that, what about outbound? Outbound, basically, we don't change it, because in terms of outbound, we don't have any security threat. It's the incoming which poses security threat, not outgoing. So outbound says all traffic includes all protocols and port ranges to all the destinations. If you want, you can apply the restrictions over there. Okay. If you want, you can perform the restrictions out there, but I'll not do that. Fine. You can optionally tag this thing, but tagging is not that much important in terms of security risk management. So you understand what we are doing. we are trying to say this is my Linux web server, which allows the SSH, MySQL, and HTTP access, SSH, MySQL, HTTP, and HTTPS access. And I have opened these two protocols from all IPs. Anywhere can access my website, but I want to restrict these two protocols because these are they give the special access. It's a privileged access. For example, the SSH access is given so that the users can SSH list administrators. They can perform something. I want to run some database packages. Let's suppose I'm running a database. My database administrators need to gain access to the database running upon this. Let's suppose I'm running a Ubuntu server with MySQL package running upon it, or a Debian server, a Debian Linux instance. So there are a few things I need to do, for which I need to open this MySQL port. So I can say restricted MySQL access from my database administrators. And that's it. In terms of Outbound, I haven't touched it. All right. So that's about this stuff. This is what exactly the type of configuration I'll be applying. I click on create security group, and this creates my security group. Intel Linux web server. Now, at the time of instance deployment, I just go ahead and apply the same one in front of you. So I just go ahead and, for example, I click on select existing security group under network settings and look for the one that I just got created, Intel, this one, yeah. So I can choose select existing security group and apply the one that I just got created. Okay, this is exactly what you need to do. You can either create a new one, but you don't get a lot of options out there. You just have these three rules in place. But if you create a security group separately, you can choose a bunch of options, bunch of protocols, and then at the time of instance deployment, you choose select existing security group and apply the one. You can just search for that in the list and then apply the same one that you already have created beforehand. Fine. I'm going to give you a document, a text document, which consists of either I can just give a text document, or this is the exercise. It's already there in the Google Drive. And if I copy and paste the content of this text right now, this is the DIY exercise. DIY stands for do it your own. Do it on your own. Okay, DIY exercise. Okay, this is a scenario. So I've already explained you exactly that how a security group needs to be configured. Fine. This is the scenario that I've laid down in front of you. Okay, this is the scenario that's being in front of you. And you have to go through the scenario. Open your AWS Management Console. Try to configure a new security group on your own based on the scenario. All right. All right. So let's go to this statement. It's a DIY exercise. This do it your own exercise. So based on understanding and based on what you already know, you have to apply these steps. It says create a security group based on the following requirements. The first requirement is that you have to go for the inbound rules. You want to allow the users to access the website running upon this instance in such a way that they can access it safely and the communication is encrypted and quote unquote secure. So you want the users to access the website. It can be a Python website, a Node.js website, Apache PHP web application, whatever you want to deploy. You want to give them safer access. Okay, so in this case, I go to the security groups on my instance dashboard. So basically, if you go to EC2 dashboard, you can just click on security groups on the resources under resources menu, or you can find resources. You can find security groups on the left hand side under network and security. You can just go to either of these two options. You land on the same page. Now you can create security group and you can put any name out there. For example, demo Intel Web Security Group. Let's put it as SG in the short form, which stand for security group. So I can put some description for the documentation purpose. Allows access for my end users, and the customers, and the internal employees. Okay, so I just put a simple description. This is just for the documentation purpose. Access to my end users and the internal employees. Okay, let's start with the inbound rules. Let's start with the inbound configuration. Based on this, it says allow users to access the website or upon instance in such a way that they can access it safely and the communications is encrypted and secure. Now, whenever you want to give a safer website access, you always use HTTPS. Right now, you go to Intellipaat site, it's HTTPS only. All right. So you choose anywhere IPv4 and you just say allows HTTP secure access to my website. Right, you choose HTTP as in the front end. What's the next thing? The next thing that you have to do is that you have to, it says, as this is a Windows server, your admins should access it from the branch office. This is the IP address I've already pasted over here. So I'm saying that let's allow the RDP. So RDP is for the Windows server, and I paste the IP address over there. So I say restricted uh, restricted RDP access from my internal employees, the people who are working for me, the Windows administrators. So for my internal employees in the branch office. Okay, so you restrict it. Now the third one says that this Windows service is also running a MySQL database. You want to allow the internal access from the same branch office and a bunch of internal private IPs. And this is a bit confusing out there. It says this is a Windows server also running MySQL database. So it is very obvious that you add a rule and you just allow the MySQL access, which uses both the 306. Allow access internally from the branch office. I already put the branch office IP address over there. I choose custom. So I say restricted MySQL access from my branch office. Okay. The next thing it says, and a bunch of internal private IPs. You must have some internal servers that need to communicate with the MySQL database. Maybe there are some threaded web application server, some processing servers, which need to send some transactions, some data to the MySQL database. So you need to copy this IP address and you have to add fourth rule. MySQL from custom source and you put the IP address. So restricted MySQL access from some of my internal servers. Understand the point? You can allow the same protocol multiple times for different types of IP, for different set of IP addresses. I'm saying this is the MySQL access from my branch office. I put the branch office IP address and put it across. Also, there are some bunch of internal servers that need to access the MySQL database to send some transactions or some data towards it. So I allow the MySQL access from a bunch of IP addresses from the internal server, which belong to some of my internal servers. Okay, so if you have different categories of IP addresses or different sets which can be grouped together, you can put it across in two different rules or multiple rules. So the same protocol can be applied in multiple rules if you have different types of sources. These are the 4 rules that we have to apply. In terms of outbound, I'm saying that keep it to default. Don't do it anything. Go ahead and click on create. Right. So this is the one. That's how you have to create it. This is what the concept is. Fine. But there's one important thing I need to discuss with you before we can move forward. That is launch template or launch configuration. So I discussed with you the concept of load balancer, auto scaling, what exactly the purpose of having a load balancer is. Because basically, when you go with the horizontal scaling and you want to deploy more instances for the same application, which supports the same infrastructure, it is very obvious that you have to make sure that there should be some component or any type of device, whether it's virtual or physical, it should be sitting in the middle and should be diverting the traffic to the instances or routing the traffic out. It will dividing the traffic between them equally. For that, we use load balancer, right? So we discussed about load balancer, the health check capabilities that it has, and the downside of the load balancer we discussed was that it has no capability to do deploy more instances if there's a scarcity of them. So if you lose, for example, one instances or two instances, and you just have one or two instances left out, then load balancer will divert the entire traffic to that leftover instance, okay, or leftover instances. So in that case, you'll be uh, putting those instances to exhaustion. Will be sending a lot of traffic to those leftover instances. So to compensate for that, autoscaling can deploy more instances automatically. It will see the difference between the desired capacity and the actual capacity, and based on that, it will launch additional instances for you to compensate. Right. So whatever lesser amount of instances are there in the infrastructure, it will deploy the same number of instances for you. Then we discussed that autoscaling can also increase or decrease the number of instances based on the principle of elasticity, based on the time of day, patterns of the incoming traffic, demand. It can increase or decrease the number of instances. They make use of scaling policies as well, based on which, for example, you have the metrics like CPU utilization, the number of requests coming and hitting a load balance. So number of packets coming in or bytes coming in, bytes going out. These can be the metrics or the parameters based on which we can have the autoscaling to increase or decrease the number of instances. Autoscaling and launch instances, it's which comes under the category of scale out action. Autoscaling can also terminate the instances, which comes under the category of scale in action. In both these two cases, autoscaling will make sure that based on the metrics we have defined or the time of day or certain dates, it can automatically scale out, which means that increase number of instances, launch them, or scale in, terminate instances, or subtract them from your infrastructure. Now, all these operations are be done within the auto scaling group, which is nothing but it's a logical collection of identical targets or identical instances. So you group these instances or the targets together in a single group. Right. So I'll give the example that the load balancer is getting a lot of traffic. You can just choose this metric that the load balancer request count per target or per instance is more than 100 requests. So on an average, the load balancer is sending more than 100 requests to every instance in the group. Then in that case, autoscaling can increase more instances. And once the amount of requests go below a certain level, autoscaling can terminate the additional instances which are no longer required. Okay. So based on these metrics as well, autoscaling can function for you and it will automatically increase or decrease the number of instances. We discussed that. Okay. The thing that we need to discuss is that, for example, the autoscaling has to initiate a scale out event. It has to launch instances, right? Autoscaling, there's a need or there's a requirement for the autoscaling to increase the number of instances, right? So, for example, in this case, I just put this over here that autoscaling has to initiate a scale out event and launch 10 instances for you. The question that comes into this entire conversation is that if the autoscaling has to initiate a scale out event and launch instances, how autoscaling will know the software and the hardware configuration of those instances? There should be something, right? So if for example, autoscaling has to launch instances inside the group, right? There's certain parameters that we need to deploy. There's 10 certain properties. So autoscaling says, I would like to deploy some instances. So autoscaling has decided auto-scaling has decided as a service that I need to initiate a scale-out action or scale-out event. And based on that event, I need to launch instances inside this auto-scaling group. So this is my, for example, my auto-scaling group, which is a collection of identical instances, right? So auto-scaling has to launch some additional instances inside this group. But the question really is that who decides the AMI, the Amazon Machine Image, right? This test type, right? Who decides the, for example, key pair, security group, etc., etc. For example, you have some storage settings. Storage, for example, EBS or EFS. These settings need to configure them. So basically, these are some basic properties. These are some basic parameters. Auto scaling needs to put across these parameters or refer to these parameters and deploy the instances, the similar instances inside the auto scaling group. Right? That's what it wants. So what you do is that you put this entire list of properties in a template on a document. That document is called launch configuration. Or launch template. Right? This is called launch template or the launch configuration. You can use either of these two things. They're the same thing. Launch template gives you some more advanced options. Otherwise, the purpose of both these two different options, launch configuration or the launch template, is the same. These are the documents based on which it will list down the parameters or the properties which is an instance requires, or we need or autoscaling requires or needs to deploy the similar instances inside this autoscaling group, right? So we want that in an autoscaling group, all the instances have the same AMI, same instance type, same key pair, same skill group, same storage settings. So we'll have to list exactly these parameters. Autoscaling will refer to these parameters. Basically, it will use the document, the launch configuration of the launch template, and based on that, it will initiate a scale-out event and deploy the similar instances with exactly the same AMI, instance type, key pair, secure group, whatever properties are you define in the autoscaling group. Fine. So the launch templates or the launch configuration need to be configured first before you can put autoscaling into action. Fine. So this is exactly what we need. Now, in this hands-on that we're doing, we'll be using launch configuration. How to use launch templates, we'll discuss afterwards. Because when you start configuring launch configuration, Amazon Web Services will or AWS will give you notification, use launch templates. They are recommended. Yes, launch templates are recommended over launch configuration, but you can use both of them. Both will work perfectly fine. In launch templates, basically, you can create the versions and revisions. Okay, that's the advantage you get. We'll discuss launch template as a separate topic. So in this hands-on, we'll use a launch configuration for auto-scaling. Fine. Public image. Okay, what's a public image? Public image is the one which are already available for all of us. It's common for us. For example, if I go to EC2 dashboard, I go to AMI catalog, right? For example, quick start AMIs, marketplace AMIs, community AMIs, these are public images, which means that if you go on your instance dashboard or your EC2 dashboard and you just try to access the AMI catalog on the left hand side, these AMIs are exactly the same. It's a public offering. I would say that everyone can use it. If you go to the quick start AMIs, where you deploy this test, Amazon Linux AMI is same for all of us. There's no difference, right? You can also use Amazon Linux 2023 AMI, or I can also use that. So it's public in nature, which means that AWS offers these AMIs for all the account owners. Now, the public AMIs are fit for hands-on, for development, for testing, but not great fit for business applications, business use cases, because your businesses will be having their own customized images with their, I would say, with their own inbuilt software installed upon, or I would say they need to have their own packages. I'll give you one example. So, for example, let's take one example over here. Let's imagine you take an EC2 instance, right? This EC2 instance is launched using a public AMI. For example, I'm sorry, let me just remove the annotation. Let's imagine I use one of the public AMIs in the list. Let's suppose I pick Ubuntu 22. Yeah, this one. Ubuntu Server 22.04. Now, if you see in your quick start AMIs, this is the same AMI you can see. No difference. This is a basic plain AMI which is visible on all the accounts. So, for example, if I launch this instance using Ubuntu 22.04 AMI, public AMI. Now, this is not being customized based on business requirements. This is a plain image, a plain operating system. Okay. Now, what you do is that you SSH to the instance, or you run a script, and you say, all right, let me install upon it. Let me install, for example, WordPress upon it, MySQL. So WordPress 5.1.1, MySQL 6.0, Apache PHP application. Right? You install these packages and you customize them. So you customize all of them. You customize, basically you're trying to launch your web application. So you customize these packages based on your business. You customize them. You do the customization. You customize the WordPress site, the MySQL database. You have the entire data in that database. You run the Apache PHP application. So you install all these bundles. Okay. Once you install all these bundles upon the instance, where it will be installed? Within the instance, you customize, you install all the software and customize the software and your apps based on your business requirements. And then as a final product, you fetch a private image out of it. Right? Now, once you get this private image, where it shows up, let me show you. So it shows up under this category, My AMI. It says created by me, which your business creates for its own needs, because a business will have its own AMI. The advantage that you get is that once you have this AMI ready for you, okay, you don't have to manually log into every instance and every Ubuntu AMI instance and install the same software again and again. This private image can be taken as it can be stored in my AMI space, and from this private image can help you to launch identical instances, right? And these instances can be of any instance type. So you can deploy identical instances in thousands of any instance type, and all these instances will have all these applications pre-installed upon them. WordPress, MySQL, Apache PHP, they've been customized automatically, so you don't have to repeat the process again. You understand the point? So you take the public image, the basic common image, deploy the instance, install every customized software, business apps and services upon the instance. And once you're ready, take that image from the instance. That instance will help that instance from where you take that image. Once you take the image from that instance, that image will now help you to launch identical instances with exactly the same software. So all these things will be carried over and encapsulated or packaged inside the private image. It will be automatically packaged. Okay. This is what you have to understand. Enough of talk. Let's start with the hands-on, guys. I show the step from 1 to 11. Okay, 1 to 11 or 1 to 14. Okay. See what I'm doing? This script is the same script that we have used earlier. This is the bootstrap script. Now, this will install a kind of a customized software for us on the instance which is launched using the public AMI. Okay. So we're going to be using the script. I launch instance first. I go to my instances dashboard and I click on launch instance. I name this, I can put any name to this instance or I can just leave it blank. If you want, you can tag it or you can just not tag it. It's purely your choice. Now, in terms of the application OS images, we're using the Amazon Linux 2023 AMI. Now, this is a public image. If you carefully see on your screen, on your AWS Management Console, this is the same AMI available to you. Even if you match with the AMI ID, if the region is same, North Virginia, because it's region specific, even the AMI ID would be same, which means that this public image is the one which is common for all of us. There's nothing private about it. Fine. So this public image you have to use as a Amazon Linux AMI as of now to deploy our first instance. You don't have to change the instance type. Under key pair, choose proceed without a key pair. You don't have to use the key pair. You don't have to use a key pair because we don't have to log into the instance right now. Under security group, you have to choose allow HTTP traffic from the internet because you have to access the website. And under the advanced details, you have to copy and paste the script. Now, this script will install the Apache PHP web application for the instance. It's our own customized software. AWS didn't give this script to us. We are running the script on our own to install the Apache PHP website upon the instance with the customized index.html page configured. Fine. So we just copy the script, put that under the user data. Fine. And that's it. We just go ahead and click on launch instance. There's the same concept that we've discussed earlier. You have to deploy the instance, click on the instance ID, wait for the instance to launch, and then once the instance gets in running state, try to browse its public IPv4 address. You should be able to get a result back as a web page. Now, once you perform the first 14 steps, I would say once you deploy the instance, copy its public IPv4 address and paste that in the browser, and you will get this result. Now, after launching the instance, even after, I would say 30 seconds, or maybe let's go 60 seconds, let's say give it a 1 minute buffer time. Even after 1 minute, the instance doesn't respond with this page. Now, what you have done, you have deployed your customized business application for the instance. Fine. Now we'll be taking the private AMI from this instance. We deploy this instance using a public image, install this Apache PHP application upon it. Now we will take the image out of it, which will store for our future reference. It's kind of a templatizing the things, right? Amazon offers you free public templates, which are not customized based on business requirements. In that free templates, you add on your own customization and make a private template out of it. That's what you're trying to do. So in the previous step, we have just launched instance and we were able to execute this step successfully. And we were able to get this output. So we just installed the Apache application upon instance using a script. Okay. What's the next thing? we need to get the image from this instance now, because this instance has been launched. Just okay. Now, in this case, we want to make sure that we can just go ahead and take the image out of this instance. So in this case, we are going to follow the steps from step 15 only. Okay, step 15 only. So step number 15, what we're going to be doing, let me show you that. You need to just choose this instance, go to actions. So you have to select the instance first. You have to check it. Once you check your instance you selected, you need to go to actions, image and templates, and there's an option that's called create image. You can see the definition of the AMI. It defines the program settings that are applied when you launch your instance. You can create an image from the configuration of an existing instance. Can you see this thing? You can create an image from the configuration of the existing instance. So we already configured the Apache PHP upon the existing instance, and now we're getting the image out of it, so that that image will have exactly the same package included with it. So for example, I name this image as httpd image. I put a description. For example, this image will be used with auto scaling to launch identical instances. I put some description over there. Now it says no reboot, so we have to uncheck it. So whenever we take the image from an instance, it gets removed. It is rebooted automatically. And when we take the image from an instance, it takes a backup of the image files in the form of snapshot. Right? You can see that during the image creation process, easy to create a snapshot of the above volumes. Basically, this is when we the data storage linked with instance will back up the image files. So we want to back them up in a form of a snapshot. Fine. So in this case, we want to back up all the image files in a storage device that's called snapshot. It is a storage service. So snapshot will back up all those images, and the size of that backup is 8 GB. Okay, this is this will cost us 10 to 15 cents. Okay, because I already told you that for the image you have to pay 10 to 15 cents, because when you back up the image files, they're being backed up in the form of a snapshot, SNAPSHOT. So snapshot is a backup of your data. So the backup of the image files of 8 GB will cost me 10 to 15 cents. I click on create image and my image starts getting created. On the left hand side, I go to AMIs, and this is my private image showing up. Can you see the visibility? It's private. Status is pending as of now. If I go to AMI catalog, go to my AMIs. Now under my AMIs, this private image shows up. And you will see that your AMI ID will be different. This is the private image. This is not public now. This is private to you. It's not visible from other account owners. So you can customize the images. You can install any type of applications upon your instances, customize those application services or the pages, and then you create the image from instance. And as a result, as a byproduct, you get the private image. Okay. What's the next thing? The next thing is that we have to start with the target group and application load balancer. Okay. So we'll start with the load balancer deployment. What we need to understand in this case is that if you remember, once we start discussing the concept of load balancer, we used a very basic diagram. And if we put it across, basically what we discussed in this case was that the load balancer will forward the request to a group of instances or targets. Now, what we discussed was that what are these? These are the targets. These instances are targets. Okay, what are targets? The targets can be anything. They can be EC2 instances. They can be, for example, containers, Docker containers, for example. They can be, for example, um, instances, containers. These can be also your on-premises servers, with the servers which are running in your own data center. You can also link that with the AWS load balancer. So targets can be instances, your containers, on-premises servers, and there's something called Lambda functions. Now, Lambda is advanced concepts that we'll discuss afterward. It is basically a part of serverless infrastructure deployment. Lambda functions. Lambda functions basically are used to deploy your serverless websites or serverless applications. So the targets, what we're trying to do is that the load balancer will start diverting the traffic to targets. Targets can be instances, containers, on-premises servers, and Lambda functions. Okay. Now, in this case, we are using the targets as instances. We're going to be using them. Now, the thing is, load balancer will group these targets together, and it will label and that will be called as a target group. A target group is a group of similar targets or similar instances. Okay, if we group those targets together or instances together in our case. And the main thing is that we configure the health check based on the target group. Right? We discuss about the health check. Basically, the health check is being sent from to every target, but it's being configured at the target group level, the health checks. So before we can start with the load balancer deployment, we have to create a target group first and configure the health check for its targets. So how you go about doing that? You need to just go on the left-hand side. On the left-hand side, you will see that you have load balancing and auto scaling. Fine. So we just go to load balancing. We have load balancers and target groups. You have to go to target groups first and click on create target group. Okay, now based on the steps that I'm going to put down in front of you, the step numbers are the following: 16 to 20. Okay, what's next? Well, once you start with the once you start with the process to create a target group, it says choose a target type. Is it instances? Are these are the instances? IP addresses? These are Lambda functions or application load balancer. What is this? So, for example, we are using instances. IP addresses can belong to our containers, on-premises servers. Lambda functions are it's used to deploy serverless application. You can also link one load balancer with the other one as well. We'll discuss that afterwards. It's an advanced concept. But right now, we'll just go with instances. In our case, the target equates to instances we're going to deploy. Okay. And we're going to be using auto scaling to manage and scale our capacity. What's capacity? The number of instances or number of targets. Now, once I choose instances, okay, hang on 1 second. Let me just put it across one more time. Create a target group. I go with instances. I put the target group name as, for example, HTTPD target group. So I just put a simple name in this case, HTTPD target group. Okay. And I choose a protocol and port, HTTP 80, because my target group will be receiving this traffic from the load balancer. I don't have to change VPC or the protocol version. Now, this is quite important. Health checks. Let's say that the associated load balancer will periodically send requests per the settings below to registered targets to test their status. Now, what I conveyed to you earlier was that the load balancer will send an HTTP request by default to the targets at the backend, and the targets will respond back to the load balancer with 200 OK status message. Now, if we set a health check path means that do you want to ping any document, any configured page of your application? If you carefully see the script, we have already configured the index.html page of our website. So we can use this as a path, And I'm saying that I'll be sending my health check messages to the index.html page of my website. And if my website is running properly, they should respond. There should be a response in the form of 200 OK message, right? So basically, I'm saying please try to reach the home page, the index.html page of my website. So in this case, what we're going to be doing is the health check ping path we're going to be putting in as /index.html. Okay. This is case sensitive, which means that please don't use uppercase letter anywhere or any alphabet in uppercase. This should be lowercase only. I've seen people sometimes put capital I. So it is lowercase only. Put a /index.html. Now I can just go to advanced health check settings. But right now, let's focus on this interval. It's the approximate amount of time between health checks of an individual target. So there's a default frequency of 30 seconds, which means that the load balancer will send the health check request to every instance every 30 seconds. Okay. And the success score is 200, which means that generally, if the instance is healthy, it will respond back with a 200 OK acknowledgement message. That's a status success code, right? So the interval is 30 seconds. It's the time frame between the consecutive health checks. So every 30 seconds, the load balancer will perform a health check towards every instance. You don't have to change these values, just for your information. So basically, you have to create a target group. What's a target group? It's a group of targets. The target I will choose instances. The name of the target group is, we put any random name. The protocol and port would be HTTP port 80. And you have to configure the /.index.html as a health check path. Go ahead and click on next. You don't have to do anything over here, and click on create target group. And your target group gets created. Now this target group will be added on to the load balancer in the next step. Guys, make sure that the configuration should be exactly the same. What I mean to say is that in terms of, for example, the details that I've included, let's suppose the protocol and port should be HTTP 80. Fine. This is quite important because this is the traffic that our targets will receive, and the health check protocol is HTTP. And you go with the lowercase /index.html. Okay, so the settings should be same as it is. Don't change the settings because based upon our website configuration, these settings are applicable to us. I'll show you one more time. So if you, for example, click on create target group, you have configured everything over here, right? You have configured everything over here. Okay, you have configured everything on the first page. Click on next. Don't do anything over here. In the registered targets, you don't have to configure anything. Okay, click on create target group at the bottom right-hand corner straight away. That's what you have to do. Because the targets will be registered afterwards. Will not add on any targets or instances to the this target group. Right? So what's a target group? It's a group of targets, and those targets will be added afterwards. So right now, because we'll be using autoscaling to deploy the targets, and they will be added automatically based on the confusion. So in the advanced level, once we go to the once we start configuring autoscaling, we'll merge the target group with the autoscaling group. So whatever instances autoscaling deploys will show up in this target group afterwards. There will be an overlap. You get to know this concept. Okay. Now, guys, one thing, once you're done with this thing, one thing you need to do is that if you go to AMI, AMIs, please confirm that the status of your AMI is available. The status is available. Okay. Now, this means that the image is created successfully. You can go ahead and terminate the instance that you deployed just for the sake of getting this private image. This instance that you deployed just for the sake of launching the app upon it and getting the image out of it, the private image, this instance is no longer needed. You can go ahead, you can right click or terminate the instance or go to its test state and terminate the instance. You don't need this instance anymore now. The purpose of having this instance is to just launch instance using a public image we use the Amazon Linux 2023 AMI or Amazon Linux AMI, install the Apache PHP app upon it, and took the private image out of it. That's it. Right? This image, if you use now, from now onwards, will install the same app upon same operating system, same application upon the next instances that we're going to deploy. So our mission is accomplished so far. You can just go ahead and terminate the instance. We don't need this instance anymore now. The purpose of this instance is to get the image out of it. That's it. Fine. Go to the instance dashboard. On the left hand side, we have instances. Right? We have instances. You choose instance that you had launched previously in the first step, the first 14 steps. You have to choose that instance, go to instance state, and click on terminate. Okay.
Just a quick info, guys. Intellipaat offers an advanced certification in cloud computing and DevOps by IAM Web. Through this course, you can learn all the important concepts of cloud computing, DevOps, AWS, Azure, Linux, and Python. The course features live classes with IIT faculty and industry experts, campus immersion at iHub IIT Roorkee, and includes certifications from both iHub IIT Roorkee and Microsoft. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials in our Achievers channel, whose link is given in the description below. With 24/7 support, placement assistance, and EMI payment options, this course without a doubt can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of cloud computing.
Right. So if I just go to AMI is over here. When I issued the command create image, I got this image, the private image. Create template is nothing but it's a launch template or the launch configuration. On the left hand side, you will see that there's something called launch templates. Launch templates, right? This is what we're going to be discussing. The downgrade version of launch template is launch configuration. Basically, a launch template is nothing but it's a document. When you click on launch template from the instance, basically all the instance settings are being captured in a document itself, in a template. You create that template. Afterwards, when you have to deploy the same instances again and again with the same settings, same AMI, same instance type, you can use that template. Okay, so that is also one of the options out there. You can create the image from the instance. That instance will give you a standard parameter in terms of what type of operating system you like to have, the security groups, the key pair. That can be done in launch template. But when we create the image, we're able to capture the software side of it. The operating system plus apps and services bundled together in a package. So image will create the private image, and launch template will capture all the details of the instance in a single document. And you can use the document again and again to deploy the similar instances. That's the difference. See, right now, we need to understand this thing. Whenever you create the private image or private AMI, first, template doesn't use EPS. Templates are just documents, right? In the next step forward, we'll be able to create the document. So that is already included. You can see that it says create a launch template. Okay. On the fifth step, we'll be able to understand what's the launch template. Okay. So basically, just to reiterate what I said, it's a simple document which encapsulates all the configuration parameters of the instance, including AMI, instance type, key pair, security group, everything. AMI is nothing but it's a software configuration. That's it. So you have to images is a software configuration, or it's a packaged bundled software that you use to deploy the instance. Template consists of the parameters in the form of a list in a document that you have to refer to deploy your instance. So on the fifth step, you'll be able to see the difference between them. In the previous step, we just went ahead and we started. Now they have deprecated auto-scaling. I think they have deprecated the launch configuration. Go 1 second. Okay, I think launch configuration was showing up over here. It's gone now. They've removed that from the list. No worries, we're going to be using launch template. Anyhow, we'll be using launch template, which is the advanced version of it. So the last component that we deployed was the target group. In the target group, we just mentioned the health check. That is the most important thing. Okay. And basically a target group is nothing but it's a group. It's nothing but it's a group of targets or the group of instances under the load balancer. Now this target group needs to be included in the load balancer. So the next step is that we have to deploy a load balancer, and the load balancer should be sending all its traffic to this target group. Fine. Now I will just take you to the next step, next level, and we'll just create a load balancer or deploy it. If I just go to launch templates, yeah, I think that's been deprecated. There was a lot of updates going on that the launch configuration would be removed. I think they removed that. That's okay. We'll be using launch template. So I'll show the steps in terms of the load balancer deployment. I'll show the steps. The steps would be, I'll show the steps right now. So I'll show the step. I'll go a bit slow in terms of load balancer configuration because I have to explain a lot of theory in terms of how you configure the load balancer, what's the purpose of every step, the types of load balancers. So I'll be discussing those things with you as well. Now, right now, I'll be going from step 21 and just take you up to 21 to 23 only. That's it. Fine. So I'll be going. Now, in terms of the load balancer, you have to understand this thing, that once you start with the load balancer deployment, to get started, the very first thing is that you have to be on the EC2 dashboard, right? So once you go to EC2, it will just take you to the EC2 dashboard, right? On the left-hand side, where you can see some of the menu options, you have this thing called load balancers, and target groups. So I go to load balancers, I click on create. Now I have three main load balancers in front of me. I can deploy either of these three. Now, if I choose any one of these three, the basic functionality, the common functionalities of the load balancer, I'll still be able to leverage. I'll still be able to access those basic functionalities of a load balancer, right? But why we have these three classes? Why we have these three different types of load balancers, even if we get the basic functionalities out of them? Because at certain level, they are being used in different situations, in different scenarios. For example, application load balancer is mainly fit for HTTP and HTTPS websites. All right. So the application load balancer is the most basic and most common form of load balancer that you're going to be using. In 95% of the cases, you'll be using this one. In 95% of the cases, you will be using application load balancer because it fits the requirements. It takes care of the HTTP and HTTPS websites. It can work for microservices, containers, on-premises servers. It's quite advanced load balancer, and it is suitable for two types of requests to process, HTTP and HTTPS. Fine. So in 95% of the cases, the application load balancer is more than sufficient. Now, why it's called application load balancer? Because it works at the application layer, which is HTTP and HTTPS, which includes HTTP and HTTPS protocols. Then we have network load balancer. Now, network load balancer is the one which is kind of, we can say that it's the advanced version of application load balancer. It can take care of any type of traffic: HTTP, HTTPS, SMTP, DNS, IMAP, POP3. So it can take care of any type of traffic. Fine. So let's suppose you want to take care of the SMTP traffic, which is for email servers. It can perfectly work in those situations. But that's not the main advantage of the network load balancer. Network load balancer is suitable in those cases when you have more than 1 million requests coming in each second. You can see the clear definition over here. Operating at the connection level, the network load balancers are designed or capable of handling millions of requests per second securely while maintaining ultra low latencies. Right. So, for example, if you have let's suppose a kind of requirement when you're, let's suppose, going for OTT platform streaming service like Hotstar, and you expect that because of certain events or IPL or FIFA World Cup match, you expect that millions of requests would be hitting your load balancer, and you also have to maintain ultra low latencies, which means that you have to bring down the lag. And sometimes you must have seen this thing. You have the best internet connectivity, but still there's a buffering going on. There could be possibility because a lot of traffic is hitting that OTT platform. It's not able to handle that amount of load. So that buffering is kind of a lag for us. So the network load balancers are designed to or capable of handling millions of requests per second by maintaining ultra low latencies. This means that the users will not face any lag or latency at their end. So if you have that type of requirement, then you could be using the network load balancers. Again, I'm saying so. In 95% of the cases, the application load balancer is suitable. But in few situations, like I gave you the example of, let's suppose Amazon Prime Day, e-commerce websites use the network load balancers, OTT platforms, or for example, the food delivery apps, like let's suppose Zomato has published an advertisement that they're giving 25% discount on every order for 5 days. So they know that a lot of users will be coming in and accessing the Zomato platform to place the orders and get to 25% discount. So e-commerce sites, OTT platforms, they generally use these type of load balancers in those situations when they expect that millions of customers will be coming in and trying to access their platform. Gateway load balancer is not being used that much. This is used for third-party virtual appliances. Let's suppose you're running VMware virtual machines on AWS. You're running VMware virtual machines on Amazon Web Services. In that case, you can make use of gateway load balancer. This is the rarest of the rare cases where you're going to be using gateway load balancer. 95% of the cases, you're going to be using application, and rest 5% network. That's it. In my gateway load balancer was deployed almost less than 18 months back. But in those last 18 months, I haven't seen more than 1 or 2 deployments of gateway load balancer. Why? Because gateway load balancer is used for third-party virtual appliances running on Amazon Web Services platform. Like, for example, you're running VMware virtual machines on AWS. Very few companies do that, because generally the companies, when they start having the virtual machines on AWS cloud, they will go for the AWS own proprietary instances instead of going for VMware virtual machines. There could be some exceptions. Sometimes, for example, the instances don't support those applications. So in that case, VMware virtual machines support certain applications to be deployed upon them. In those few exceptions, you can make use of a gateway load balancer. So it is used for, it's used to deploy and manage a fleet of third-party virtual appliances, which is rare of the rare cases. So these are the 2 load balancers that we're going to be using. And this hands-on, we're going to be using application. Why? Because it fits our requirement. First thing first, we're going to deploy an HTTP site. So, and we don't want to have we don't expect millions of requests coming in. It's only few clicks that we have to make. That's it. So even if you have the requirement of tens of thousands of clicks or requests coming in per second, the application load balancer is sufficient enough to cater to that requirement. Okay, so I'll go with the application load balancer, click on create. Now in this case, the very first thing that I have to do is that I have to go ahead and just put a name over there. For example, name it as HTTPD load balancer. You can put a simple name. It doesn't make any difference. Even if you just put your first name, that's okay. That's a simple name that you can easily change afterwards. Scheme, is it internet facing or is it internal? Now, in this case, we always use internet facing, because if you're using for the HTTP websites, if you're using this thing, if you're using to deploy our websites, our load balancer should always be receiving traffic from the internet. Internal load balancers means that you just want the load balancer to route the traffic for internal operations. It will not receive traffic from internet. Maybe the load balancer is receiving traffic from internal servers. There could be a possibility when you're using load balancer to just receive the traffic from internal components. Fine. But in this case, we always use internet facing, because if you're going to use load balancers for the website deployment, the load balancer should always be internet facing, because if it's internet facing, it can receive requests for your website over the internet and forward those requests to where? Instances at the backend. IP address will go with IPv4, right? Because the instances we are using right now, they're using the IPv4 addresses, which are of 32 bits, right? So that's what we have to do. You have to start with the load balancer deployment, and in the first 2 or 3 steps, you have to just go ahead and put a name. Make sure that the scheme is internet facing. Don't go with internal, because we're going to deploy a public website. And also the IP address type should be IPv4, which is the default one. Please go ahead and do that. Let me know it's done. Why are we using internet facing? Because we want the load balancer to receive traffic from public users, internet users, right? So if we don't use internet facing, or we choose internal by mistake, what happens? The load balancer loses the capability to receive traffic over the internet. Okay, it will only receive traffic from internal servers. Okay, so in that case, we should be using the internet facing load balancers. What's next? The next thing is the 23rd step. I'm sorry, 24th. In step number 24th, we have to go with the availability zones mapping. What is this? Step 24 only. What we're trying to achieve in this case is we want to make sure that every available, see the thing is that based on the best practices being recommended by Amazon Web Services, the best practices which AWS suggests to you that these are the best practices that you should be going for, you should be choosing at least 2 availability zones, the instances of which can receive traffic from the load balancer. You should have at least 2 AZs, or the instances should be put across 2 AZs to make sure that you have a highly available application. Why it is so? Because if one AZ goes down, of course that AZ goes down, the instances will also go down in that AZ. At least you have the second AZ fully functional with instances running inside it, and in that case, it will guarantee that your application has no downtime. Fine. So it is always recommended that you just choose at least 2 AZs within the load balancer's configuration, within the network mapping. Now, in this case, under mappings, I have a list of 6 AZs, I'm sorry. If you're using different region, that's a different story. Whatever regions are showing up, you have to check all the boxes. So we are saying that we want to, whenever auto scaling launches the instances, it can launch instances equally between any one of these AZs or all these AZs. And the load balancer can divert the traffic or route the traffic or send the traffic to any one of the instances in any one of these AZs. This means that I'm trying to make my application highly available. At least 2 AZs should be selected. For example, if I don't select 2 AZs, right? Okay, you can see that over here. Select at least 2 availability zones, and the load balancer routes the traffic to targets in these availability zones, right? So I will be choosing all the availability zones in this thing, so that I make all these AZs or the instances inside them to become eligible to get or receive traffic from the load balancer. Okay, you have to select all of them. Please go ahead and do that. Let me know it's done. Yeah, so choose both the ACs in that case. Whatever ACs you have, guys, you must be using California, Mumbai, whichever region you're using, you have to select all the ACs. Yeah, you choose both of them, Ravi. Whatever ACs is showing up, you have to check all the boxes. In Mumbai, for example, there are 3. So you have to make 3 boxes, but whatever boxes are showing up, you have to check all the boxes, all the blue ticks. In my case, I'm using North Virginia, which has 6 ACs, so I'm making 6 ticks. All the ACs should be checked in your case, because I want to make sure that I don't compromise in terms of making my application highly available. Because let's imagine I have 25 instances or 100 instances. Those 100 instances will be scattered between these 6 availability zones, right? Auto scaling will try to maintain the equal number of instances between them. Of course, we have, if we divide 100 by 6, we don't have the equal number, but it tries to makes a balance between these different ACs. It tries to deploy equal number of instances in each of these ACs. So this is being done, fine. All right. So network mapping means that it will guarantee that we will deploy the instances in all the ACs within the region. See, right now you need to understand everything is happening in the same region. The deployments that we are doing right now, the AMI, the load balancer, auto scaling configuration, everything is done inside a region. What's the next thing? The next thing is step number 25. It is about the security of a load balancer, or assigning a security group to the load balancer so that it can receive the traffic from the authorized sources and forward the traffic to authorized targets or known targets. We'll not go too harsh in terms of security group configuration. We could now create a trust relationship between the load balancer and the instance at the backend. But right now, we'll just go simple. We'll create a simple security group for the load balancer, and I think this thing can be skipped. It's not that much important as of now, but some people may face the issue. Okay, let's do one thing. Let's skip this step, because what happens is by default, the load balancer receives the HTTP traffic from anywhere, which we want. Hang on 1 second away. Okay, let's do that, because some people will start facing the issue if we don't create a new security group, because in that case, we have to do some troubleshooting afterwards. To prevent ourselves from troubleshooting, we can just create a new security group from beginning and ensuring that we have the right protocol included in the inbound rules. So I show you the step number 25 and 25 to 29. Okay, see what I'm doing. Now I want an inbound rule, because I want the load balancer to receive the HTTP AT traffic from the users, because we're going to deploy an HTTP website. What we're going to launch? We're going to launch an HTTP website. So I want the load balancer to receive the same traffic, but I have to open that port at the security group level. What is the security group? A security group is nothing but it's a firewall which restricts the traffic which comes in or which goes out from a specific component. Right now, the one which is there, which is default, I don't want that, because I don't have the surety, or I don't have the confirmation that it includes that HTTP AT traffic inbound from all the sources. So to be on safer side, because I want to make sure that I don't compromise, because later on we have to do some troubleshooting if we don't have that. So in this case, what you have to do is, there's something called, there's a line on the top which says, a security group is a set of firewall rules which control the traffic for your load balancer. Select an existing security group, or you can create a new security group. Now, once you click on this one, this will open a new tab for you. Now, don't close the previous tab, because people get confused when switching back and forth between these two tabs. Okay, you have to click on this option. It says create new security group. It opens a new tab for you. Please don't close down the previous tab. Okay, click on create new security group. It opens a new tab for you, a new page for you, where you can just go ahead and start creating a security group. Just be on this page, let me just type it done. Once you're on this page, Great. Now it says that security group name. You can put anything over here. For example, name it as Elastic, or let's suppose I put it as app load balancer SG, and I can copy this and paste same in the description. I put a name and the description. That's it. Fine. And in the inbound, I add a rule where I just allow the HTTP traffic from anywhere IPv4. That's it. Make these three selections or perform these three things. Name the security group. You can copy and paste the same name in the description. Don't change it. And include an inbound rule where you just allow the HTTP inbound from anywhere IPv4. Please do this thing. Let me know what's done with this. So anywhere IPv4. You have to choose anywhere IPv4. Okay. Once you do this thing, you need to simply scroll down. Don't change the outbound. Click on create security group. Let me know what's there. Once you've done this thing, click on create security group. Just have it done. Once you have created this one, you don't have to change the outbound. Simply scroll down at the bottom right hand corner. Click on create security group. Okay. Now what you have to do is that you have to go to the left tab. You have to go back to the load balancers page. Right. So there are two tabs opened. You have to go to the tab on the left hand side. Okay, the browser tab. And you have to cancel the default one. There's a cross one. You can just click on cross and this gets away, or you take away the default one. Now there's a refresh button over there. You hit refresh. Okay. And once you hit refresh, you'll be able to search for the load balancer that you created. Okay. Basically, you have to remove the default one and apply the security group that you just got created. You have to make sure that you hit refresh, remove the default one, and then apply the security group that you just created right now. You have to go back to the previous tab. So basically, people get confused. They are on this tab. They will now say, okay, I somehow need to go to the load balancers now. There's another tab opened on the left-hand side. You go over there, remove the default one or hit refresh, remove the default one and apply the one that you just got created. Yeah, Karima, that's okay. You apply the security group first, right? And then you cancel it out. If you're talking about the default security group coming up again, that's okay. You just look for the application load balancer security group that you just created. You select it and you will have two boxes. You have to cancel the default box. That's it. So what we have done is that we have ensured that the load balancer has only one type of request coming in, which is the HTTP request from all the sources. We haven't included any other protocol, for example, HTTPS, because it's only for the secure website. We have to basically also go for a certificate. We have to upload an SSL TLS certificate. We haven't done that. So any other protocol is not allowed, whether it's HTTPS, it is MySQL, IMAP. It's only the HTTP request which is coming in. That's it. Done. Okay, now what's next? The next thing is that you have to go with the step number 31. I think that's 31, 31, and 33. Okay, so in this case, when you go to the once you scroll the page down, it says listener and routing. Now, a listener is a process of listening to the request. What I want load balancer is to ensure that it listens to the HTTP AT traffic and forwards the request to a target group. Now, which target group you're talking about? It's the one that we created in the previous step. If you just go to the drop-down list, it shows us the target group. This is the same target group that we created earlier in the previous step. So I'm saying, hey, load balancer, please listen to the HTTP AT traffic and then forward that traffic to this target group, which will eventually consist of my targets of instances. Fine. Once you go ahead and do this thing, simply go ahead and click on create load balancer, and your load balancer gets created. Let me know what's wrong with this thing. Based on the document, you have to go with step number 31 to 33. And if you just click on view load balancer, your load balancer is now in the state of provisioning. You can see that the state is provisioning. Not able to see target group. Can you, there's a refresh button. Can you just hit refresh and see if it's showing up? Hit refresh. There's a refresh button on the right hand side of it. It's not showing up. That's weird. Case, first thing first, you have to ensure that you are in the same region where your target group was created. Okay, your region should be the same. Now, if you already have created the target group and it's not showing up, then the only thing that you have to do is that you have to refresh the complete page, which means that you're trying to configure the load balancer, right? You're trying to configure the load balancer. You have to, basically it's not showing up. You have to refresh the complete page. Now, once you refresh the complete page, you will lose the configuration that you have done so far. And you have to start from beginning. But before you start from beginning, make sure the target group shows up. Okay. You will lose the configuration of the load balancer because the entire page is refreshed. Scroll down and look for the target group. If the target group is still not showing up, this means that it's not there. Okay, still showing active. Should I create a new one? Saga, there's a troubleshooting step I asked you to do. When you just give me one response that once you just completely refresh the page, right? You just refresh the page. And if you scroll down, can you see the target group right now? Yes or no? Can you show the target group step again? Why there's a need to show it again? You're talking about the load balancer one. I'll just come to you. The target group is not created, or there could be a reason that you have by mistake switched to a different region. Create a new target group in that case. There's a possibility either you didn't create the target group or you have switched to a different region by mistake. So Sanjay is telling me you're asking me to show you the target group step again. Basically, this is the listener and routing step. Once you go to listeners and routing, you have to go with protocol and port HTTP 80, just keep it as it is. Then it says default action, forward to select a target group. You have to go to the drop-down menu and the target group shows up. You have to select it. Once you select that, so in the listener and routing configuration, you have to make sure that the protocol HTTP 80 is being selected and it forwards the request to the target group. So you have to select the target group in the list. And once you do this thing, thereafter, you have to straight away click on create load balancer. Okay. We're all set as if now. Everything's going perfectly fine based on what we planned. Now, the next thing that comes up is we have to focus on the auto scaling now. The next thing that we have to, so we have to focus on the next part, which is auto scaling. All right. Hang on one second. Based on the documentation, we have to create a launch configuration, which is step number 34. But because configuration was there, it's been deprecated. It's being discontinued from the dashboard. So I didn't have the privilege to change the documentation because I just saw that it's been removed. But that's okay. We create a launch template instead of launch configuration. Launch template basically is the advanced version of it, or basically it gives you some more advanced options. Now, what is this launch template, this launch configuration we are talking about? See, when I discussed with you auto scaling, I discussed with you a few of the important ingredients, and the main thing that I discussed with you, I discussed this thing with you that when the auto scaling has to initiate a scale out event. What exactly is meant by scale out event? If you use the term scale out event, what do you mean by that? So auto scaling, if it has to initiate a scale out event, it has to launch the instances, right? Scale out means launching, scale in means terminating. So auto scaling has to initiate a scale out event, and it has the task to launch instances. The problem lies in this case is that how the autoscaling will understand that what should be the AMI, the instance type, the key pair, the security group, the storage linked with the instance. We basically put this all these parameters in a template or a document. The document is called launch configuration or the launch template. Now, this launch configuration is kind of deprecated now. It's no longer supported. This is deprecated. So you'll not be able to see this thing showing up now, but now they have just removed that from the dashboard. Very unfortunate for us, because it will be easier for us to use this option, but that's okay. Launch template is also easy. So launch template will consist of all the parameters which autoscaling needs to deploy instances with exactly the same parameters. Right? What's an autoscaling group? Autoscaling group is the group of identical instances. Right? So I gave the definition. An autoscaling group is a logical collection of identical targets. What do you mean by identical? They have the same AMI, same instance type, same key pair, same security group. So in this case, to make sure that they have the same identity, they have the same software and hardware configuration, same security group applied to them, you have to put all things in the template. Autoscaling will use this template and deploy identical instances. Okay, so when you go back to the EC2 dashboard, on the left-hand side, you would see a bunch of options out there, right? So under the instances, we have 1, 2, 3. There's a third option, which is called launch templates, right? This is the one, launch templates. Just on the left-hand side, where you have the instances, you have instances, instance types, and launch templates. You have to click on launch templates, go to launch templates, let me know once you're on this page. This type it done once you're on this page. In this, you can find option switch launch configuration. But in my case, it's not showing up. It depends on the region, region to region. You must be using some of the region apart from North Virginia. It depends upon region to region. So if I go click on create launch template, I'm not getting the option as if now, but it could be the regions. If you use a different region, in that case, sometimes options change. Anyhow, we are on the launch templates. I click on create launch template. Fine. Now, once we go to create launch template, the very first thing is that we have to put a template name. I name it as, for example, HTTBT launch template. Fine. And you can just put some description. You can just copy and paste the same in the description. That's okay. Fine. And yeah, first thing first, add a label. I'll go a little bit slow because this is not in the document. Put a template name, put something in the description, or just copy and paste the same thing. Let me know what's done with this thing. Just type it done, assign a name and a description. It's not there in the document because the document I've shown the steps to configure the launch configuration. That's why I'm going a bit slow so that no one lags behind. Done. Now, once you perform these two things, once you just put a name and description, there's something called auto scaling guidance. It says select if you intend to use this template with the EC2 auto scaling, right? You have to check this option. Provide guidance to help me to set up a template that I can use with auto scaling. Just check it right now. Let me know what's done. You have to check this option. Provide guidance to help me to set up a template so that I can use that with auto scaling. Please check this option. Okay, so basically it will show us the important options which the auto scaling needs to initiate a scale out event or increase the number of instances or launch instances for me, right? Once I'm able to perform these three things, I just go down to the application and OS images. Fine. Now, in the application and OS images, you have to choose owned by me. Okay. And the drop-down menu, you have to choose the one that you created earlier. This one. Go ahead and do that. You're saying this image is owned by me. I own this image. I own this image. Fine. So once you create the template, you also have to include the image. So basically, there's a question out there. Difference between image and the template. Image is the subset of template. Image is a subset of the template. Template is a large overview of the things to be deployed, right? And image is a part of it, right? So that's why create the image, because the image has to be included in your document, in the launch template, in the launch configuration, so that the instances can pick up this image and deploy the instance with the same Apache PHP application upon it. Done? Are we done with this? What's next? Next thing is instance type. In instance types, you select all generations, and look for t2.micro. Now, I think t3.micro will also work, but I think that's okay. Yeah, look for t2.micro and select it. In your case, if t2.micro doesn't show up, then choose t3.micro. Please select it, instance type, t2.micro. Just in case t2.micro doesn't show up, then you have to choose t3.micro. Please go ahead and do that. Can you see exactly what we're trying to do? We're giving a checklist, the list of ingredients, the list of the parameters that auto-scaling will refer to, and based on that, it will deploy the instances with exactly the same configuration. This is done. What's next? Key pair login. In the key pair login, choose don't include in the launch template. We don't have to go with the key pair. Make sure that you have the default one selected. Don't include the launch in the launch template. We don't need the key pair because we don't need to SSH to these instances. There's no need for the key pair. Choose don't include in the launch template. Let me know what's done with this. Done. Okay. What's the next thing? You have to straight away go to security group. Okay. Now we want to allow the HTTP traffic from anywhere. So what you can do is that you can go to select exist security group and choose the same security group that you apply to the load balancer. Same one, because this instances have to receive the HTTP AT traffic, right? So you select the same security group that you apply to the load balancer. Same one. Please go ahead and do that. Let's type it down. What's done with this? If you wish, you can create a new one, but just to save our time, because we just have to include the inbound HTTP AT traffic from all the sources. The same inbound rule that we apply to the load balancer. So we're going to be using the same security group because it has the same inbound rule. Done? Okay, what's next? The next thing that you're supposed to do is you scroll down. Don't go for storage volumes. Don't go for tag. This is purely optional. Don't go for advanced details. Okay, we don't have to configure any of the advanced details as of now. No, this is not required. Okay. You don't have to configure anything. So what we have done, we have put a name. The main thing is that we chose the image. We chose instance type. For the key pair, we went without the key pair, and we applied the security group, which allows the HTTP inbound from all the sources. Fine. We have just made these selections. We could have gone to some more details, but right now, these things that we have selected are more than sufficient for us. So rest of the parameters will be taken by default. Okay, we're not configuring the storage, resource tags, advanced details. You will pick the default values for them. Click on create launch template, and your launch template gets created. And then go to view launch templates, and your template it's created. Let me know once you are on this launch templates page. This tab it done once you're on this launch templates page. Okay, so right now you have put a list of parameters for the instance to be deployed. So the instances with exactly the same properties, same AMI, same instance type, same key pair, same skill group would be deployed automatically. Now, what's the next thing? The next thing that we're going to do is that we have to create an auto scaling group from this template. Now, the steps on the document would be exactly the same. It was only that the launch configuration has been deprecated, it's being removed. Now you can easily see the documentation and follow the steps. I'm showing the step number 38 and 39. You need to go back and you have to select your template. Once you make a selection, there's an actions on the top right hand side. You have, for example, launch instance from template. You can launch instance from it. You can modify the template. Now, when you modify the template, it creates versions of the template: version 1, version 2, version 3, version 4. You can delete it. You can delete the version of it. You can set a default version. Default version means that let's suppose you have 5 versions. Out of 5 versions, you want the third version to be default one, which means that whenever you deploy launch instance, the third version is used by default. So default version gets the priority. You can manage the tags. Okay, let's go to this option, create auto scaling group. This is the second last option you have. Because from this template, we want to deploy an auto scaling group. What's an auto scaling group? It's a group of identical instances. You click on create auto scaling group and you come to this page. This tab is done. Once you're done, you have to go to the actions. You have to choose the launch template, go to actions at the top right hand corner. The second last option shows up, create auto scaling group. And this will take you to this page. Okay, Patel, you have to basically choose the template. Fine, you have to choose a template, go to actions, and you have to click on create auto scaling group. It's an option. Okay, this is the launch template. You select it, then you go to actions. Within actions, you have the second last option, create auto scaling group. You have to click on that. You just think that's what I said, sir. But this option is only visible only to you. Reason being because you already have created all the steps. You already done all the steps. That's why the option is visible to you. Perform the steps. Launch configuration was there. You created the auto scaling group, and once you go to the auto scaling group, you get that option by default, which is not a privilege for all of us. You understand the point? So to view this launch configuration, we have to create the launch template first. Now, in your case, the launch configuration is already created. The auto scaling group already exists. That's why the option is showing up for you. Let them complete the steps, because see, one thing I can tell you from my experience, it's not the step which is important. These steps are very, very easy. If I give you this document to perform the steps on your own in the document, you can easily perform the steps. If you perform the steps by yourself, it doesn't mean that you're a champion. I'm talking about all of us. It's not the steps which are important. It's the concepts behind the steps which are important. When you go for the interviews, when you go for evaluations, they will look into your conceptual overview. Steps you can just Google and you can see the steps everywhere. Okay, steps are not that much important, but the concept, the conceptual in-depth concept behind those steps, that's what makes the difference between the person who just knows the steps and the person who knows the concept behind the steps. So focus on the concepts. Don't focus on the steps too much. And no one is awarded if someone performs the steps way earlier before other people. That's why I always recommend don't go too fast, be with other people and focus on the concepts. All right, so I just named the auto scaling group as HTTPD ASG. Name the auto scaling group, right? So you have to name it. Fine. Now, once you name the auto scaling group, it automatically shows you the launch template details. Fine. You don't have to change it. You don't have to change these details because we are picking this launch template to create the auto scaling group from. And once you name it, click on next. Let me know once you're on this page. Basically, you have to assign a name to the auto scaling group. in down below in the section, it shows you the details of the launch template that you've selected. Of course, you don't have to do any modification over here, right? And you have to just click on next, and this will just take you to the this page. What's the next thing? All right. Once you click on next, the next thing that you have to do is step number 40. Okay. In step number 40, what you have to do is, you have to choose, there's something called availability zones and subnets. You have to choose all the availability zones, check all the boxes. These are the same boxes we checked in the load balancer configuration. I'm saying auto scaling, go ahead and try to deploy instances in all the ECs. Please go ahead and do that. You don't have to change the VPC. We are staying the same virtual network. Basically, you have to select all the availability zones in a list. Let me know it's done. What's next? You have to click on next. Don't go with the instance type requirements. Click on next. Basically, you can override the instance types. But we're just going with the t2.micro. We don't have to change it. Click on next. And now you come to this configure advanced options. Just type it done once you're on this page. Once you come on this page, now it is asking you, do you want to include the load balancer in this entire setup? Would you like to do that? You have to choose the middle option that says attach an existing load balancer. Okay. Then it says, what's the target group? You have to select the target group of the load balancer. Go ahead and make the selection. Choose the option in between, attach an existing load balancer, and then make the selection. Go ahead and do that. Basically, we are trying to involve our load balancer in between. We're trying to make sure that the load balancer can be included in between these options or in this entire setup. Please do that. Done. What's next? VPC latest integration options is a user's option, a new option. We don't have to use it. We need to go to health checks. Okay. And you have to check this thing, turn on the elastic load balancer health checks. All right. You have to check it because we want to depend on the load balancer health check in this case. And the health check grace period is 300 seconds. Don't change it. What is grace period? See, grace period means whenever the new instance gets launched, auto scaling will launch new instances. Let's suppose there's a high demand and auto scaling has launched 10 instances. Now those 10 instances are just been launched. They're still initializing. We want the load balancer to give those newly launched instances at least 5 minutes so that they are in running state. See, whenever you launch an instance, you must have seen this thing, the instance goes to initializing phase. In that initializing phase, the instance boots up, it installs operating system, services, applications upon it, script, software. And once everything runs perfectly fine, it shows you running state. Now, the problem is when the instance is initializing, and if I allow the load balancer to start health checks towards that initializing instance, it will fail the health check because instance is still booting up. It is not in running state. So before it comes to running state, if load balancer starts sending the health check towards that instance, which is still initializing, in that case, the instance will not respond with 200 OK message. And by mistake or mistakenly, the load balancer will declare the instance as unfit or unhealthy. Fine. So to prevent yourself from those situations, you're saying load balancer, whenever the instance gets launched, give it a buffer time of 5 minutes. 300 seconds is equal to 5 minutes only, right? Let that instance launch for 5 minutes, be it in running state, let it completely launch. And then once it's completely launched, it's ready, then you start sending the health check towards it. So it takes the first 5 minutes as the grace period. You can see that there's a clear definition over here. Health check grace period, this is the time period delays the first health check to until your instances finish initializing. So there's a time gap between the instance just launched, it is initializing, and between the first health check. It does not prevent instance from terminating when placed in a non-running state. Okay, so so basically the instance is still initializing and the load balancer is sending the health check towards it, it will fail the health check. So to prevent that from failure, you give a buffer time of 300 seconds. Okay, just an FYI. Now you have to make sure that you check this option and ensure that the grace period is 300 seconds. Don't change this value. Let me know once you're done with this. Just type it down once you're done. Let me know once you're done. Let me know once you're done with this. What's next? You don't have to configure additional settings. Click on next. Now I'm going to show you the next step, which is step number 42. Now we have to configure the main thing within auto scaling is the group size and the scaling policy. What is this? What is group size? Group size means that what's the minimum and maximum number of instances you want. I coined a term in front of you, coined a term that's capacity. What's capacity? Capacity is equal to number of instances. If you remember, I discussed this thing with you. Capacity equates to number of targets or instances, the same thing. Number of targets. Capacity equates to number of targets. Okay, so capacity or size is the same thing. Now it's saying that what is your desired capacity? What's the minimum capacity and what's the maximum capacity? Desired and minimum is the same thing. I'm not sure why they've divide these two different things as different, but generally they're the same thing. Desired and minimum capacity means that what's the bare minimum instances you want to be running. It never goes below that. Now, for example, let's suppose I give a very layman example. It's getting hot in Delhi, right? So I'm saying that the minimum temperature I'll need to set in my air conditioner is, for example, I'd say 23 degrees Celsius, fine, or 21 degrees Celsius. And the maximum cooling I can go up to is 18 degrees Celsius. So I can set the cooling temperature, or it's kind of a thermostat. So I'm saying in our case, the desired and minimum capacity is 2. Now I'm going for lesser value. Of course, in a big environment where you're working in production environment, it will scale up to 20s, maybe 200, right? So I'm saying that in normal situation, when everything is normal, there's no high demand, there's no high peak in traffic, the number of requests are below a certain level, I need 2 instances to be running, healthy instances running every time. But let's suppose there's a high surge in traffic. More and more users are trying to access my website. Let's suppose generally in an hour, I have 10,000 visits, 10,000 clicks towards my website. But in that hour, instead of 10,000, it's 100,000 clicks going on. So in this case, I'm saying I want to increase to the maximum capacity, which is 4. Fine, maximum capacity 4. So in this case, what you do is that you set the minimum threshold and the maximum threshold. It never goes below 2 and never goes above 4. We have to set the maximum capacity. See, there's no concept called unlimited capacity. You have to set the maximum threshold. Fortunately, this can be changed afterwards. Let's suppose you put it 4. After some time, I realize 4 is a less number. I can change it to 8 or 10. I can change these values afterwards, but you have to set the maximum capacity. There's no thing called unlimited capacity. At the end, we are consuming physical resources at the back end. So in this case, Amazon Web Services want to ensure that you set the capacity, which is beyond a certain range, which is within some limits. Fine. So we're going with lesser values, but in production environment, you go for higher values. Fine. Okay, just to do that, go ahead and put these numbers. Let me know what's wrong with this. Okay, what's next? Scaling policy or the conditions. See, basically the thing is that auto scaling, we have given it a buffer value, minimum capacity 2, maximum 4. But the question is that what are the conditions which will enforce auto-scaling to increase or decrease the number of instances? Those are the scaling policies or the conditions. For example, I choose this condition, load balancer request count per instance. In this case, the users are my end users are trying to access my website. They send a huge amount of traffic to the load balancer. I can set a value that if load balancer is sending more than 100 requests per target, on an average, every target or every instance is getting more than 100 requests from the load balancer, then in that case, initiate a scale out event and launch the instances, right? And once the request goes below 100, then it will start decreasing or terminating those instances if the requests go down. But right now, I'm saying if the requests go at 100 or above 100, auto-scaling can increase the number of instances. And eventually, if the requests go down, it will automatically decrease them one by one. So in this case, what I will do is that I'll go with the scaling policy, choose target tracking scaling policy, and choose the metric. Now we have the CPU utilization, number of packets coming in, number of bytes going out. We're going to be choosing application load balancer request count per target. Choose the load balancer target group and set the target value of 2 only. Now, of course, you should have in hundreds. By default, it's 50. It should be 100 or 1000, right? But because we're just doing testing, we want to see the faster result, we put the target value as 2. Fine. So I'm saying if load balancer is sending more than 2 requests to each of my instances, this means that there's a high volume of traffic coming in, and now auto scaling has to increase the number of instances. But once the number of requests go below 2, that will start decreasing to minimum size. So I'm saying I start with 2 instances. On an average, each of these 2 instances get more than 2 requests, go up to 4 instances, add 2 more. And once the number of requests on an average go below 2, it will come back to the minimum capacity, right? We're giving a bandwidth. This is minimum, this is maximum. If the number of requests per instance is above 2, go to the maximum. If the number of requests per instance goes less than 2, then you have to go back to minimum. Okay. And we are giving 300 seconds for the instance to warm up so that they get enough time to boot themselves up and be a part of this auto scaling group, right? So basically, you have to choose a target tracking policy. Make sure that you choose the application request count per target. Choose a load balancer target group. Put a low target value of 2 so that you can get a fast result right now. And choose 300 seconds for the instance to warm up, which means that when the new instance get launched, we give them enough time to install everything and be in running state. Let me know once you're done with this thing. You don't have to check this option, disable scaling to create scale out policy. This is not, I'm saying disable scaling means disable termination, which we never do. Okay, so I'm saying that you only increase, don't decrease. There's an option, but generally we don't check this option. There's no target group option for me. Option is not there. You might be looking somewhere else. You have to choose a metric type, application load balancer request count per target. You have to make sure that it chooses the exact metric type. You must be choosing some different metric type. That's the reason. Because the metric type only shows up if you choose the application load balancer request count per target metric type. Then the target group will show up. Done. But because we're doing testing, we're going for lower value. In a production environment, you'll be going with hundreds, 200, maybe 2000, right? So that's what you have to do. Don't check this thing, disable scaling, only scale out policy. Don't check this option, enable scaling protection. If you choose any one of these 2 options, you prevent this test to be terminated. We want the termination to happen if the amount of requests go down. If the target value goes less than 2, we want the instances to be terminated. The additional instances to be wiped out and get back to the normal size of 2 instances. So you don't have to check these two boxes. Okay, now you don't have to do anything else. Next, next, and create. Okay, the rest of the options are useless. Click on next, click on next, click on next, and click on create. So 3 next and create. 2 to 3 next, click next, thrice and thrice or twice. I'm not sure. Yeah, it was twice or thrice, and click create. Basically, those are optional tagging and notifications. Click next, 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 and create. Let me know what's done with this. Next, 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 create. Fail to create one scaling policy. I'm not sure why I didn't get that option. Okay. What you guys can do is, you click on the auto scaling group, right? You click on auto scaling group. You have some options on the top. Details, activity, automatic scaling, right? You have to go to automatic scaling. Let me just go to automatic scaling. Click on the auto scaling group. Once you go to automatic scaling, is this target tracking policy showing up under dynamic scaling policies? No, not showing up. Garima, I'll show you one more time. Guys, you have to be a bit faster now. I'm not sure why all of you face the same trouble at the same time. Your auto scaling group is created, right? What you did right now. You created an auto scaling group and you got this error message, failed to create the policy. We have to troubleshoot it. To help you troubleshoot, you have to click, right? There's a click option. You click on the auto scaling group. Once you click on this auto scaling group, you have all these options on the top. Details, activity. You have to go to the third option, which is automatic scaling. Okay, automatic scaling. You have to click on that option, and it will just take you to the automatic scaling page. You have to verify whether or not this target tracking policy is showing up under automatic scaling or not. If it's not showing you, then I'll help you troubleshoot how to create the policy. It is not, okay? Not showing, okay. So how to create it again? I'll show you. I'll remove the policy at my end. I'll remove the policy and show you. Actions, delete. Okay. So I also deleted my policy. I don't have anything. There's something called create dynamic scaling policy, right? Click on that. Click create dynamic scaling policy. Let me know what's done with this thing. Click on this option now. Click create dynamic scaling policy. Let me know on this page. Click create dynamic scaling policy. Now you choose metric type as application load balancer request count per target. Target group as the load balancer group, and the target value as 2, and instance warm-up period as 300 seconds. The same options. You have to choose the metric, same load balancer group, target value is 2, and instance warm period as 300 seconds. Okay. Basically, you got that option, failed to create the policy. This policy was not created, right? The same thing that you have to configure. Are we all done with this thing? You have to click on create, that's it. Once you click on create, the policy gets created. The message is gone now. Okay, fine. Now, on the left-hand side of the automatic scaling, there's something called activity. Go to activity, and you see 2 instances being showing up. Go to activity, or you can go to activity or go to instance management. You will see 2 instances being launched. So this is basically we got an opportunity to troubleshoot. If you get this message, go to automated scaling and create the policy again. Okay. All right. What's next? The next thing we have to do is testing. Okay. Let's do this thing. You have to go to the step number 51 and 52. Now, once you go to the you're on the auto scaling page, you can see that there are 3 vertical lines on the left hand side. On the left hand side, you have to go to the load balances page. Okay. And there's a DNS name of the load balancer showing up. Okay. You go on the left-hand side within load balancer, and within load balancer, there's a DNS name showing up. You have to copy it. There's a copy button, right? So you have to copy it right now. Just copy it, and you paste that. You just try to access the website. You try to access the website. So I just paste it, press enter. I'll be able to see the page. Now, basically, load balancer is taking my request and sending it to one of the 2 instances running at the backend. Now, what you have to do is that you have to increase the number of requests. It will take 5 minutes for you to get the output. Make some refreshes. Refresh 30-40 times. Now, refresh. There's a refresh button. Let me just show you that. What if I talk about refresh? What do you mean by that? Either you just click on enter, or there's a refresh button, right? So either you just click on, either you just go to the menu bar, press enter, or just keep on hitting refresh. 502 bad gateway means that there must be some issue with the security group, or must be issue with the instances deployment, which means that, or the health checks. In that case, guys, please hit refresh 30-40 times. The DNS name of the load balancer, I need to see that. Okay, now guys, once you've made 30 to 40 clicks, you go back to the load balancer auto scan group on the left hand side. Click on the auto scan group. Go to activity. Now there's a refresh button. Can you see that? You go to auto scaling groups. You click on the auto scan group. Go to activity, and there's a refresh button. I just make a connection between them. You click on auto scan group, go to auto scan group, go to activity, hit refresh button, and now you will see that your 2 instances will be launched. Right? Can you see that? Just try it out. This is being done. We're getting the result. Guys, you have to check your auto scan group now, right? You have to select the auto scan group, select your auto scan group, go to actions and click on delete. You have to select your auto scaling group, go to actions, click on delete, and it says auto scaling group consists of running instances. Just type in delete and click on delete and remove the auto scaling group. And guys, if you want to repeat these steps in your 3 days ahead of you, you don't have to remove the AMI. The first 2 steps you can skip them. Okay, guys, please remove the auto scaling group. Let me know once you're done with this. Okay, initiate it. Now you have to go to load balancers. Go to load balancer, check the load balancer. You have to select the load balancer, actions, and delete load balancer. Now, even if you don't delete the load balancer, you still be in free tail limits. But if you don't need this anymore, we don't need this anymore now. Delete the load balancer, just tap in confirm, and your load balancer also needs to be removed. Please go ahead and do that. You basically have to delete the load balancer and auto scaling group. Auto scaling group deletion will help you to terminate the instances. Okay. Now, what are the rest things? The rest things are free of cost. Regarding AMI is you've already paid the amount to basically in the month of, you can use it till 30th of June without paying further for it. This image can be used till 30th of June without paying anything extra, because you already have paid 10 to 15 cents for it for the month of June. Till 30th of June, you can still use it without paying further. Not able to delete the auto scaling group. Manish, any message you're getting? Any error you're getting back? You have to select the auto scaling group, actions, and delete it. Basically, you have to choose the image, go to actions, click on deregister AMI, and then click on deregister AMI. Let the auto scaling do its work. You have initiated the process. You don't have to do anything at all. You have to deregister the AMI. Once you deregister the AMI, then go to the snapshots under Elastic Block Store. Choose the snapshot, go to actions, and click on delete snapshot. Fine. So once you choose this deregister AMI under AMI, you have to delete the snapshot of the image. Money will be charged extra. You don't have to remove the secret groups. What's there into deleting the secret group? Any error message you're getting, hit refresh, basic computer skills. If your page gets stuck, hit refresh your browser, go to auto scan group again, select it, actions, and delete it. Choose your auto scan, go to auto scan group again. See, basically, I'm not sure why people are so much in terrible confusion. You have initiated the auto scan group deletion. It is there, right? It is removing. There's a cycle going on. Let it be, right? Machines don't work as human beings. They don't have too much of curiosity. You have initiated the process. It is running. It will remove itself automatically. Basically, at the backend, it's terminating the instances. Have some patience. You don't have to sit in front of a computer and wait for it to remove automatically. What you need to do is that you need to understand that everything is being given to you in forms of access. And the form of access, you need to ensure that whenever you access any account which is being signed up using a credit or debit card, that's called the root account. Okay, what's a root account? Root account means that it's a master account and everything that you access on AWS can be easily accessed without any issues, and you don't have any type of restrictions as such. You can easily perform the operations, you can deploy any of the services, and in the root account, you have all the access. Okay, now you must say that, but ours a free tier account. Yes, free tier account is also a root account. It's called root or the master account. So just give me a few seconds as I try to just explain this thing to you by just jotting down some important points. But what happens is that whenever you start working in the organization, you don't have the root account to be accessed. Instead, you would be using or you'd be considered as one of the IAM users. Let's start with the basic concept first. Before you can start clicking and navigating the items, first of all, let's discuss the theory behind IAM, why you need the IAM. Okay, because without theoretical foundation, clicking the things and navigating the things will not make any sense to you. So let's first of all understand the relevance. So the relevance of IAM is IAM stand for Identity Access Management. Let's understand why this term is used, IAM or Identity Access Management. Whenever you start working in the organization, you are being identified as resources. So there are identities that you have in the organizations. For example, you must be working as a developer, or you're working as a manager, maybe a team lead, a quality analyst, a database administrator. You have some identities that you establish by yourself in your organization, right? So in this case, for example, there's a company named as Vodafone, or let's suppose there's a company named as JP Morgan. Let's suppose there's an organization, XYZ, JP Morgan, Vodafone, the company wants to sign up to AWS. The very first step that they will be taking would be, the first step that they'll take is that they will in order to sign up to AWS, they'll be creating something called root accounts, root account or root account. Any organization that wants to get started, will always ensure that it will sign up to AWS, and in that case, it will be using the root account to sign up. Even the free tier accounts that you're using, right now, the free tier account that you're using right now, it's also a root account. It is also a root account, right? So root account is also called a master account. You can also call it as a master account, but AWS we use the term root account for that one. All right. So any company gets started with sign up for a root account. Now, technically, or I would say from the business point of view, the root account is never supposed to do any deployment, implementation, or any type of configuration on AWS. What I mean to say that root account is not supposed to be used for deployments. for deployment of resources, for deployment of AWS resources. You're using the root account for deployment, but from the business point of view, a root account is not supposed to do any type of deployment of AWS resources. It's strict no-no. Now you say that, okay, we're able to do that from our side. Our free tier account is also a root account. We're doing this thing because we're doing this thing purely for hands-on and for testing purpose. You're not using a free tier account as a part of a business, right? Whenever these companies start working, these companies work in a very process-oriented fashion, right? They work in a very process-oriented way. Okay, so in this case, what happens in this case is that these root accounts are being kept separately. They're being preserved just for signing up to AWS, and they're not used for any type of deployment of AWS resources. Okay, they're being locked, or I would say they're being kept separate. They're not supposed to deploy instances, load balancers, auto-scaling groups, EFS, FSX, global accelerator. They're not supposed to perform any type of deployment. So the question really is, who does that? Basically, the second step is that the root account will create identities. Okay, create identities. What are the identities? What do you mean by identity? For example, let's imagine there's a person out there in your organization. His name is Steve. Steve is an IAM user. Okay, Steve is an IAM user. Now, Steve wants that. So Steve is, for example, is okay. I'll put user afterwards. Let's suppose he's a software developer. Okay, he's being hired by JP Morgan, and Steve is working as a developer, and he develops applications, cloud applications for JP Morgan. Now, Steve is a developer. What is this? This is an identity. What is this? This is an identity. Fine. Now, when you identify Steve as a developer, you declare it as an IAM user. Okay, it's an identity. Steve is a developer, it's an identity you create it, and this is used as an IAM user. Now, what you do is that Steve, as an IAM user, will log in to the root account, right? So he will log into the root account and perform all the deployments. So basically, Steve should be doing all the deployments, or an IAM user should be doing all deployments, all configuration, etc., etc. So an IAM user should be able to perform, should be able to perform these things. So IAM user will log into the root account saying, okay, I'll be doing all the deployments and configuration, so I'll log into the root account. Root account will make all the provisioning for this user in two ways. Number one, root account will assign credentials or allocate credentials to this user. Credentials means login ID and password. And number two, apart from allocating the credentials, we'll also manage permissions. Now, allocating credentials and managing permissions come under the category of access management. Okay, that's the reason IAM stands for identity and access management. What you do is that you create the identities. Steve is a developer. Kunal is a database administrator. Prashant is a Linux administrator. This person is a Python developer. These are identities. These identities are called IAM users. These IAM users log into the root account, and the root account will allocate the credentials to them and manage their permissions. These two things come under the category of access management. That's the reason we use this service or term this service as identity and access management. You identify the IAM users in your organization, and you give them access, or you manage their access. This is called identity access management. That's why it's called service identity and access management, right? Now, I give you a very common, I'll give you a simple analogy. Let's imagine there's a businessman who opens a factory. He has a large gigafactory where 10,000 workers can easily work, right? So the owner of the factory will buy land, right? Lease out the land, set up the machines, set up the entire infrastructure. But who will do the labor? Those 10,000 laborers? Let's suppose Elon Musk is involved in, or he's a CEO of Tesla, right? So he manages all the operations of Tesla as a CEO. But who works on assembly line? It's the workers who work in the assembly line, and um, they are responsible of manufacturing Tesla cars, right? So this means that the higher management or CEO, chief staff or executives, they take care of the entire management or the operations, but it's the actual people, the actual labor, or I would say software engineers, quality analysts who do the job. The same concept applies over here. JP Morgan creates a root account just to be on AWS. A root account can be created by your vice president or chief technical officer. So your company's credit card will be used, or debit card will be used to sign up for the root account. Now the question is, who will do the deployments? Linux administration, database administration, Windows administration, development, software development, quality analyst, solutions architecture, being a solution architect, system administration, DevOps, machine learning models. Who will do those things on cloud? It's the IAM users, the people from IT and software background. So JP Morgan, for example, has 10,000 IT and software people, and all of them are migrated to AWS so that let's suppose JP Morgan's entire infrastructure is on AWS. It has 10,000 employees in the form of IT and software teams, so that there are 10,000 employees in IT and software departments. Those 10,000 employees are developers, quality analysts, Linux administrators, database administrators, Windows administrators, solutions architects, and so forth. And they'll be using AWS to perform day-to-day job. So they'll be signing into the root account, perform all the job for the root account, and root account will say, okay, I'll give you some permissions and I manage your access. So that's why it's called identity and access management. You create identities on IAM and you manage your access. I think this is clear why we use the term identity and access management. So this means that once you start working in organizations, you don't have access, you will not get access to the root account as you're getting in a free tier account. Basically, you'll be an IAM user. And being a cloud architect, your responsibilities include designing, provisioning, and implementation of resources on AWS. So you'll be designated as an IAM user. Your company will have certain root accounts. You'll be part of a root account, and you'll be signing up to the root account through the credentials given to you, and you'll be doing your day-to-day job. Okay, this is what the concept is. Now, show you exactly that how this thing is put into perspective. First thing first, how can you differentiate between a root account and an IAM account? Let's start with the root account first. If you navigate to the top right-hand corner, you will see there's a special account ID. It's a 12-digit unique ID. This will be given to you. This 12-digit unique ID is being offered to you. I would say this is a root account ID. Every root account, if you just go to the top right-hand corner and you just navigate, you will see that there's a root account ID. Right? It's a 12-digit root account ID. So every root account will have a unique ID given to that specific account. That root account is used. That root account ID is a special identifier. Okay, AWS will identify or differentiate your account from other accounts using your root account ID. Okay, this account ID is not given to an IAM user. Let me show you that. For example, I just go to IAM. Let's go to IAM right now, and I just go to the IAM dashboard. Now, one thing, if you go to IAM dashboard, it does not require region selection. If you see the top right corner, it shows global, right? Now, why it is a global service? Because IAM doesn't differentiate between regions. When you deploy instances, load balancers, auto-scaling groups, and the databases, you have to choose the regions. But in terms of IAM, it's not region specific because it's just purely account management system or service. Once I go to IAM, I can just go to users on the left-hand side. And I think I may have a bunch of users out there. Let me just navigate over there. Okay, let me just go ahead and delete these users. Okay, and I just go ahead and create a new user right now. So this is my root account. This is my root account. And from the business point of view, the root account is not supposed to do any deployments. It's an IAM user that will do that. You can see the definition. An IAM user is an identity with long-term credentials that's used to interact with AWS in an account. So I click on add users. And for example, I name the first user as Steve. And I set a custom. So Steve is the user ID. I can, for example, the name of the employee is Steve Jobs. I can take the initial of the first name S and the last name as Jobs. Or for example, Rohan Arora, just type in R-A-R-O-R-A. Or I can just type in my first name or the first name of the user as a user ID. So Steve is a username that Steve will be using to sign in as an IAM user. Fine. And I, for example, generate a custom password for this user. Fine. I just go ahead and create this user, right? I'm not going through the details right now, but I'm showing you this thing. It says user created successfully. You can view and download the user's password and email instructions for signing into the AWS Management Console. This is the console sign-in URL, which I'll be giving it to the user. Okay. Now, if you see the format of this URL, this is how it looks. https://, and this is the root account ID. This is the root account ID .signin.aws.amazon.com/console. Right. So basically, this is the URL that I'll be giving to the IAM user, Steve, with a password set for him. Now, let me show you this thing. I just copy this URL and just switch to a different browser. I just go to Google Chrome right now. Fine. Now I just go ahead and paste this in the browser. Fine. So it automatically picks the account ID of the root account. Can you see that? Username Steve, and I set the password. Click on sign in. Now, if these credentials are accepted, Steve will be able to sign in without any issues. Fine. And at the top right-hand corner, you can see that it says account ID, root account ID, and this is the IAM user Steve, which means that the IAM user Steve is an identity under the root account ID, and Steve can perform the deployments based on what account ID gives, what this root account gives to this user. So the root account can allow Steve to access certain services like EC2, load balancer, auto scaling, maybe for example, RDS. That we'll discuss afterwards, how to give access to these users. But as of now, I've set credentials for this user so that this user can sign in to the root account and can perform day-to-day operations. Fine. Now, the issue out there in this case is that Steve is able to sign in as a IAM user. But once Steve tries to get into any of the services, he'll be automatically blocked from accessing any of the services. So why is this case? Why Steve? Because I've already allowed Steve to log in, but what exactly the problem is? What I've missed in this case? As a root account owner, what I might have missed because of which Steve is not able to access any of the services. For example, Steve goes to S3, and let's see what type of error message it gets. You just try to create a bucket right now. Okay, let's go to, for example, some other service right there. If I just go to buckets right now, you don't have any permissions. So I've done half of the job. As a root account owner, I've just given Steve access to log in to my root account, which means that I've managed the credentials for this person, but I didn't give the access to this person, right? So as an IAM user, you're able to log in via the user ID and password that root user gives to you. Plus, root user also has to give you access to certain services like EC2, S3, RDS, load balance, or auto scaling, so that you can use those services. So the type and level of access is also given is also provided by an IAM user, by a root user for an IAM user. So the root user generates credentials for an IAM user, and also the root user is responsible to give permissions to an IAM user. Root account is a master account. Master will not do anything. Basically, the master will sit and give instructions to an IAM user saying, do this thing. I give you the permissions. You have to perform all these operations on a daily basis. So the access management in this case includes giving credentials and also giving permissions. So the next thing that comes into this picture is that if that's the case, then how we manage the credentials? What's the process? To manage the credentials, the thing that we need to understand is to manage the credentials, you have to make use of a concept that's called IAM policy. Let's try to understand the next stuff. Okay, let's discuss this thing. IAM is a web service that helps you to securely control access to the resources. You use IAM to control who is authenticated, signed in, and authorized, and has permissions to use your resources. So IAM is basically it is an account management service which gives you access to creating the IAM users who can sign in, and you give them permissions or authorization. So this is simple, basically overview that how you manage the permissions in a day-to-day business environment. For example, you have a central server running. This server is running different applications. For example, a data scientist will only be given access to a data analytics dashboard. A web developer will only access or get access to the web development tools and dashboard. An administrator generally gets all the access. So there's a server running, a central server running, with different servers and applications running upon it. Data analytics tools are given to data scientist, right? So he can only access those data analytics dashboard or tools. A web developer can only access the web development tools and services. An administrator can only access or all the services on that server. Generally, in a business environment, an admin has almost all the access. Okay, because they have to do certain things which requires the complete access to be given to them. Fine. So this is how we do the access management in an organization. Now, let's discuss what's an IAM user. It represents an entity that's created in AWS. It can be a person or a service, but generally it's a person only. There are no permissions given by default. Nothing is allowed. You have to explicitly give permissions to the user. You have to give permission to the user. Fine. What are the type of access we'll discuss later on. But we need to understand this thing that how you assign the permissions. The permissions are assigned using a concept that's called IAM policies. So once you create the user, and let's imagine this is an IAM user. You perform two things. One is authentication. Authentication means that you set the user ID and password for the user. And the second thing is authorization. Authorization means that what type of things he's authorized to do or she is authorized to do. The authorization is done using IAM policies, which means that what type of access this person gets is been defined or decided by IAM policies. Now, what are the IAM policies? The IAM policy, basically, it's a JSON document. JSON stands for Java Script Object Notation. It's a JSON document which helps you define, permissions for IAM entities. So JSON document, an IAM policy is a JSON document which helps to define permissions for IAM entities. Entities means users, groups, roles. We discuss those things. So an IAM policy is a JSON document. I'll show you exactly how it looks like. So basically through the policies, you define the permissions for the users. If you don't assign any policy to an IAM user, then IAM user will not get any permission whatsoever. So the thing that I missed in this example that I showed you, where I just allow Steve to log in, I missed upon usage of IAM policies. If I go back to my root account, let's go back to the root account. Okay, if I just go back to my root account, I click on return to user list. I click on continue. So right now, this Steve is showing up as my user. I click on Steve's username and it says permissions. Permissions, no resources to display. The thing that I'm talking about is this section. Now, if I click on add policies or add permissions, it says add permissions. And I choose the last option, attach policies directly. Okay, these are the policies I was talking about. These are the IAM policies that you can use to define permissions for the IAM users that you create on the root account. So the root account owner will allow the IAM users to perform certain operations through these permission policies. Okay, for example, I'll explain you this stuff, try to understand the anatomy of this JSON document. I go to administrator access. Now this is a very special type of access I can only give to very few people, because administrator access gives the entire access to an IAM user. Let's analyze it. We'll discuss some more examples, but let's discuss that thing. Administrator access provides full access to the AWS services and resources. Now this is the JSON document that is there. Okay, let's try to understand that. So right now, I'm going to discuss with you the anatomy of the JSON document. Okay, so in terms of anatomy of JSON document, let's try to understand this thing. Anatomy of JSON document means that we need to understand exactly what each line of this document means. Number one is version. Version means that it's a timestamp when this policy was created. You can also put version 1, version 2, version 3, version 4, but generally version is the timestamp when this document was created. So in this case, the very first thing is the version, right? Version is the date of the policy generation. When this policy was generated. Okay, fine. That's the first thing is called version. What's the second thing? The second thing that you can see on this document is statement. What's a statement? Statement is basically a statement. It defines permissions, or it specifies permissions. So a statement is what? Specify permission or permissions. And in each statement, you will see that we have something called, first thing called effect. What do you mean by effect? Effect means that what type of effect this permission will make. There are two types of effect: allow or deny. Do you want to allow access to certain services, or you want to deny access to certain services? One is allow, other one is deny. Effect is allow and deny. Fine. What's the next thing? Action. Action means that what type of action means that. So action means what type of action. Let's suppose I give you some examples. For example, launch instance is an action. Launch instance is an action. Delete load balancer is an action. Terminate instance is an action. What type of actions you would like to perform? Do you want to launch something? Do you want to delete something? Okay, what are the type of actions you want to define? Now, in this case, there's a wildcard notation. The action is a star, asterisk. What do you mean by asterisk? If you see asterisk anywhere in any document, this means all, everything, or any. Okay, an asterisk as an action means all, everything, or any. Fine. What's the next thing? The fifth one that you can see in the list is resource. Resource, right? Now, resource means which resources you're taking into this permissions. For example, EC2 instance is a resource. Application load balancer is a resource. What are these? These are resources. Launch template is a resource. Okay, what are these? These are resources. What are these? These are resources. EC2 instance, application load balancer, right? Auto scaling groups. What are these? These are resources. What are these? These are resources. So resources means that which of the resources you want to include in this permission. For example, let's imagine if resource is an EC2 instance, then the corresponding actions could be, for example, launch instance, stop instance, or terminate instance. These are the corresponding actions for a resource. So once you define the actions, then you have to define the resources on which those actions will be performed. Okay. Now, in this case, if I go back to this administrator access policy, the resource is a star. Okay. So what do you mean by star? Star or asterisk is a wildcard notation. This means that all resources. Fine. This is the perfect anatomy of JSON document. You have the version, statement, effect, action, resource. So in this case, if I just go back to this policy, this is the timestamp. Statement is a kind of you can say that it's a description of the permissions you want to specify. Effect is allow. You can allow or deny. So I want to allow something, action, all the actions, resource on all the resources. Through this policy, I want to allow all the access to all the resources. That's why the administrator access gives full access to the database services and resources. Is this policy clear? Any questions or doubts you have? Now, if I assign this policy to Steve, Steve will be able to perform all the actions. So in this case, for example, I choose administrator access and I just go ahead and click on next. So in this case, what I'm doing is that I'm saying this username is Steve. This person has the administrator access. I just go ahead and click on add permissions. Right? So Steve has this policy assigned to him. So this is okay. Let me show that. Who is the IAM user? His name is Steve. And based on the permission policies, he has the administrator access. This person has the administrator access. Fine. So in this case, if I go back to Steve's account to a different browser, previously he was getting this message. If I hit refresh, you will see that the message will go away. The message will go away. Okay. So Steve has a complete access. He can deploy, delete, launch, terminate any of the resources. Let me just take one more policy. For example, if let's suppose go to the policy, let's suppose EC2 full access. Okay. For example, I take this policy as another example, which is EC2 full access. This one. Okay. So in this case, this is the policy. EC2 is a complete dashboard, right? It consists of load balancer, auto scaling, and CloudWatch. So for example, in EC2 full access, what I've done is action EC2 star, which means that all the actions under EC2 are allowed. Resources, all the resources under EC2, including, for example, images, AMI, instance types, key pairs, security groups, all the resources, even a security group is a resource. All the resources, all the actions under EC2 are allowed. Then I want to allow access to all the load balancer resources. Load balancer has two main resources: target groups and the load balancer itself. Action saying elastic load balancing asterisk, which means that all the action under elastic load balancer for all the resources underneath. Right? Let me show you that. It says, for example, I go with this one. Second statement, effect allow, right? Action, all the action under elastic load balancing. You can create a load balancer, you can delete it, you can configure it, you can modify it. You can see there's a star over here. Resources, all the resources under the load balancer. Load balancer has two resources. One is the target group, other one is the load balancer itself. Okay. I'll not discuss CloudWatch because CloudWatch we haven't covered as of now. Let's come to auto scaling. Auto scaling, for example, effect allow, action, all the actions under auto scaling. I can delete an auto scaling group, launch an auto scaling group, configure the scaling policy, change their desired capacity, resource, all resources are under auto scaling. Auto scaling has two resources: launch templates and auto scaling groups. Okay. And these are some other services or some other effects I want to allow. For example, I want to create a service link role, which we apply to the instance. We'll discuss the rules afterwards. And these are some of the services that I want to allow. For example, transit gateway support of VPC, spot fleet. So in this case, if you see the main part of this thing, under EC2, I've given access to almost all the EC2 resources: instance, images, AMI, instance type, key pairs, secure group. I have given all the access to the load balancer, all the access to the CloudWatch, and also the entire access to auto scaling. This means that under EC2 dashboard, which means that if I just go to EC2 right now, let me just go to the EC2. If I just go to EC2 dashboard on the IAM account, right? Because of this thing, the user has complete access to all the things on this dashboard: instances, elastic IPs, load balancers, snapshots, volumes, placement groups, instances, key pairs. For example, all the left-hand side options you can see, the user should have complete access. In that policy, I've also mentioned auto-scaling group, CloudWatch, and load balancers as separate services as well, because they also come under the EC2 service. Right? When you access load balancer and auto scaling, you have to go through the EC2 only, because they are the category of EC2 services. Right? For example, I say allow all the access to the load balancer resources. I'm talking about all these resources under load balancing, load balancers and target groups. Fine. So in this case, I'm giving complete access through the policy, which is the EC2 full access. All right. Basically, there is no hierarchy as such. Root user, and then we have the IAM users. So we can't have an IAM user under an IAM user. We don't have that thing, because there are only two categories: root user and IAM user. So in this case, what happens is that an IAM user can have special privileges. For example, administrator. Administrator is the most powerful IAM user, right? So the administrator is the IAM. I can give the administrator access to any user, and he becomes or he or she gets the complete access. Okay, because right now the things that I've showed you, these are the default policies. Default policies are the one which are there by default, and you just have to use them, and they're basically common for all of us. The next step we're going to be doing would be groups. What is groups? What are groups? What are they meant for? What's the purpose of behind them? And why do you need them? Okay. What is a group, by the way? Group is a collection of IAM users. Okay, you group the people together based on their skill set. Now, why we group the people together? See, okay, let me take one example over here. Let's imagine, okay, let's take example of Intellipaat. Intellipaat has created group of different batches. For example, there's one group of batch of AWS, there's a second batch of Linux, third batch of data science, fourth batch of AI machine learning, fifth batch of, for example, Python, sixth batch of, for example, let's imagine full stack web development. So there are different batches created. Why different batches are being grouped together? For better management, so that we can ensure that the AWS people can be put in one batch, the full stack web development program people can be put in one batch, and those batches can be conducted separately. Similarly, think about large organization. In an organization where you have hundreds of thousands of people, employees coming and working. For example, JP Morgan has 10,000 IAM users, right? Managing permission of every user would be very challenging. Okay, let's suppose I have 10,000 people in my team, in different teams in a big organization. Some people work as a software developers, some people work as quality analysts, some people work as database administrators, some people work as Linux, Windows, some people work on AI machine learning, some people are the full stack web developers. They all are using AWS. So that 10,000 people I have, let's say 10,000 is a very less number. If you see big IT firms, HCL, Infosys, TCS, to name the few, they have lakhs of employees. Okay, and now we are very quickly moving to cloud computing. So there will be numerous organizations who have hundreds, thousands of people working on AWS platform. So being an IAM users and assigning the permission to every IAM user is a very tough task, because the thing is that if you start doing the permissions management or policy assignation to every user one by one, the chances are that will start making blunders and mistakes. Okay. So which type of blunders and mistakes I'm talking about? For example, I give more permissions to a person that he needs, or lesser permissions that the person needs. Or maybe I give the administrator access to a person by mistake. See, administrator access, as I already told you earlier, gives a complete access. Only very handful of people in your organization, maybe team leads, vice presidents of the engineering department, maybe there's a separate team for the administrators. Very few people will have the admin access. Now, if I accidentally give to some people, they can terminate my instances and shut down my complete servers or my complete network. Fine. So I don't want to take any risk. Now, for the perfection or for the better management of the permissions, I group the user together in different categories. For example, I have one group for admins, right? I group the people together based on their job profile. I have a different group for software developers. I have a different group for operations. I group the people together. People can be grouped based on skill set. People can be grouped based on their job profile. They can be grouped based on the roles and responsibilities that I give to those users. These people can be grouped based on projects they're working on, right? Now, what I do is that I start putting the people or IAM users under these groups. So These admin 1, admin 2, admin 3 that you can see right now, what are these? These are the IAM users, right? Similarly, day 1, day 2, day 3, day 4, day 5, these are the IAM users. Ops 1, Ops 2, Ops 3, these are the IAM users. What are these? These are the IAM users. And they are being categorically put into 3 different groups, right? They're being intentionally put inside 3 groups. So this is group 1, GP1, group 1. This is group 2, and this is group 3, right? So what I do is that I group the people in 3 different categories. Group 1, group 2, group 3, right? Now what I do is that instead of assigning the permission to every user, what I do is that I assign the permission to the group. For example, I assign a policy, simple policy, administrator access. All the IAM users under the group will get the same permissions. Okay. For example, under operations, I assign a policy or 2 or 3 policies. Let's take a few examples over there. Let's imagine I assign 2 different policies or 3 different policies. Let's suppose for the operations guy, I just put in Amazon EC2 full access. Okay. And for example, auto scaling. Okay. S3 is a storage service. We'll discuss afterwards. S3 read only access. So these are 2 policies I've assigned to the operations team. All the people under this team or this group will get the same permissions. Okay, so this is a very neat and clean and process-oriented method of permissions management. So based on the best practices, we never ever assign the permissions to the users directly. Instead, we group them together. We can categorically group them together based on the job profiles, skill sets, based on their projects, their teams, business units they belong to. We group them together in a group and we assign the permissions to the group or policies to the group. And automatically all the team members or users underneath will get the same permissions. Now, this will help you to manage your permissions effectively and efficiently in a big environment where you have hundreds and thousands of IAM users on board. And this is not a very new concept. If you must have heard about Active Directory, AD, Microsoft AD, or there are different tools we use for account management. They use the same concept of groups, right? So in this case, you have to group the users together. It's a DIY exercise. DIY stands for do it on your own exercise. Description of this hands-on or the problem statement. Let me repeat what you have to do. You have to open the following document, which is this one, and log in to the console. This exercise, what's the purpose behind it? What's the use of this exercise? The purpose of this exercise is quite simple. It will give you the insights as to how to create IAM users and then group them together. And while you group them, you assign them policies. Okay. What is the difference between these 2 different components? Let's try to reiterate or refresh the things that what is this users group? I'm just going to just refresh this concept in front of you. All right, let's understand let's reiterate what is a user. Just a brief overview. I'm not sure why I missed that document. Even I downloaded the document yesterday. So what is an IAM user? As we discussed, that an IAM user is nothing but it logins to the root user and the root user account. An IAM user is nothing but it's an entity that get access to the root account, and it is generally used to ensure that you can allow the people in your IT and software business units and teams to get access to root accounts, and they can do day-to-day actions. Now, what is difference between a root account and an IAM account. Just a brief refresher before we can get started. A root account has the complete access. It is a master account. It is the master, and the master doesn't do it. It's not performed to do any type of menial or labor job. It's the IAM user who performs all the actions on daily basis. So an IAM user can be, for example, your software developer, your quality analyst, your Linux or database administrator, networking guy, solutions architect, system administrator, DevOps professional. So an IAM uses nothing but it is it can access to the root account, right? So the IAM user, Steve, gets access to the root account, and the root account will create credentials and manage permissions. Fine. So we have the root account. Any organization who wants to get started on AWS or wants to sign up to AWS will get started with the root account. The root account is not supposed to perform any type of deployments or configuration. Generally, in a production environment, root account has been locked away. It is just used to sign up. It is not supposed to perform any type of deployment operations. The root account will create some identities first. An identity is an IAM user. The IAM user logs into the root account, and root account will give the credentials and manage the permissions for this account owner or this IAM user. So all the deployments and configuration are being carried on by the IAM users. Now, a root account will perform these two things for an IAM user. Will perform authentication, which means that will manage the credentials, and also authorization, which means that manage permissions using IAM policies. An IAM policy is nothing but it's a JSON document which helps you to define the permissions of the IAM entities. What type of actions an IAM user can perform, what type of access this person has, is decided by the IAM policy. And we discussed the complete anatomy of the JSON document or the IAM policy, how it looks like. Fine. Now, we also discussed one example. I'm unfortunately unable to find the slide, so I just logged in. In a big environment, I'm just doing the revision just to make sure that we can refresh the previous stage concepts. In a large organization, it is a very tough procedure to go person by person and start assigning the policies, because the chances are that you start making some blunders or mistakes, right? Because in a business environment, IAM is a security tool. You need to understand this thing. IAM is a security tool. You can't have the appetite or the tolerance towards the security issues, which can haunt your entire infrastructure or your operations. So in this case, what you do is that you group the people based on different. You group the people in the form of IAM users. Or so we discuss this example. So what happens is that when you group people together, for example, these are the IAM users. These blue boxes consist of IAM users. These IAM users get access to, or they're put under groups. So the one you can see in pink boxes, these are groups. These IAM users are put inside the groups or under the groups. Okay, so they're the part of the groups. What you do is that you group the people, or you categorically create different groups based on skill sets, teams, business units, job profile. And once you group the people together, you identify the group of people working in your organization. Instead of assigning the permissions user by user or individual by individual, instead what you do is that you assign the permission based on the groups. So the policies are instead assigned to are assigned to group. So once you assign the policies to the group, all the users or IAM users or people under that group will get the same permissions. This is a very, I would say, process-oriented and neat and clean and organized way of permissions management. Because once you start working in organizations, you will see that things are very well organized and structured. There's no scope of mistakes or blunders. The things have to be organized. So this is a very organized way of permissions management. What Amazon recommends is that even if you have a bunch of users, still use this methodology. Still use this methodology or this process of permissions management. Okay. Having said that, this is what we discussed, and also we discussed the policies I've already given you the brief overview. So in this hands-on, we create 2 or 3 users. I'll walk you through. It's a very simple process, and you group them in the form of developers, in a group called developers, and then you start assigning the policies to them. Now, these policies are basically the tools which developers will use to perform day-to-day operations, and then you assign these users to the group. Okay. What we're going to be doing is that we're going to be performing the first 3 steps. Okay, we'll be performing the first 3 steps. Search for IAM under services. Just type in IAM and just click on IAM, and this will just take you to the IAM dashboard. Let me know what's there. Just navigate to IAM dashboard, and please let me know once you have reached that page. Okay, once you go to IAM, right? So you just have to search for IAM, and it will just take you to the IAM service. You have to click on that. This is called IAM dashboard, right? Now you will see that there are different resources under IAM. You have, for example, you can see you have user groups, users, roles, policies, identity providers. You can access resources by clicking on any one of these resources listed down, or you see there you have the resources on the left-hand side. The same resources that we talked about that are there on this page. On the main page display, user groups, users, roles, policies, and identity providers. What I want to say is that want to convey in this case is that you can just click on any one of these 2 places to navigate to resources. The resource that we are looking for is the users. I'm talking about this one. So the resource that you're looking for is the users. Either just click on the, now in your case, users would be 0. This is one user because this is the one that I created just for explaining the concept. So you can just click on the users, which says number 0, or you can just click on users. In either of these 2 ways, you just land on the same page. Okay, you must have created one. That's why you have one. Whatever the number you have, whether you click on the number or whether you just click on the users on the left-hand side, it will just take you to the same page. Let me know once you have navigated to users page. Just type in done once you're done. So in that case, Garima, you have to work on finding the things on AWS. You have to go to the menu page. See, there's a bar on the top, okay, which says services. Find right to services. There's a search menu. Just type in 3 key alphabets, IAM. Automatically, the IAM will populate. You have to click on that. How to log into as an IAM user? So Vivek, you have to wait for some time. You have not reached the destination yet. That's what we're trying to do. So you want to get the result before you can perform some actions. Wait for some time. That's what we're trying to achieve. What's next? Not able to see IAM option. That's quite strange. There's no search menu showing up on the top. You don't have any search menu. There's a search bar which has this magnifying glass or the search menu. You just go to that search menu, just type in I for identity, A for access, M for management. You just type in IAM and you will see a list of services in front of you. And you have to click on IAM. There's something called add users on the right-hand side. Once I go to user details, what's the next thing? You have to start mentioning the user IDs or the usernames. What you have to do is username. Now, username can have any naming convention because username can be anything. For example, if I want to just type in my initial of my first name R and then my surname Aurora, I can just put that like this. Or I can just type in Rohan and this is my username. My first name is my username. I can, for example, just type in Steve. That's the username. You have to put a username and just choose this option, provide user access to the AWS management console. And then you have to give you, so there would be a question asked to you. Are you providing console access to a person? Choose yes, I want to create an IAM user. So what you have to do is that you have to choose a user, just put anything, Steve, Chris, Kunal, put your first name. Select this option. I want to give the management console access to this user. And in this question, in which you're being asked, are you providing console access to a person? You have to select, I want to create an IAM user. Perform these 3 steps. Let me know once you're done. Choose the username as Steve, choose provide user access to the console, and choose I want to create an IAM user. What I'm saying is that I'm assigning a username for the user, giving my consent that yes, I want to give this user access to the console, the root user access, or the root account console access will be given to this user, and I want to create this IAM user. Okay, what's next? I'm waiting for a few more confirmations. You have to put the username. You have to give your consent that you have to give the console access, and you want to create an IAM user. I'm going very, very slow. This is a terribly slow speed. Okay, what's next? The next thing that you're supposed to do is that once you have given your consent, then the next thing is that you have to set a console password. You set a custom password. Now it says that it must include at least 3 of the following lists of characters: uppercase letters, lowercase, numbers, special symbols, hyphens. You can choose any of the custom passwords out there. I'll just choose one of the custom passwords or the passwords, whatever way you want to pronounce it. Go ahead and set a custom password. Think of a custom password and set it. Let me know what's done with this. So the first name in this case is the user ID, and the custom password is the one that this user will be using to sign in. So first name is the user ID, the username that we just mentioned on the top, and this is the custom password. Through this user ID and the password, this IAM user should be able to sign in to a root account, the root account we're working on right now, from his or her end. So using his or her own credentials, the IAM user should be able to get access to root account. All right. So I guess this is being done. Okay. What's the next thing? The next thing is that you have to uncheck this option. Users must create a new password and next sign in. You have to uncheck this option. Okay. What is this option is all about? The password that you set in, it can be a common password for multiple users. Now, when you check this option, this means that the very first time the user sign in, they're being prompted to change the password and mention their own passwords. Now, this thing we don't need in this case because we're just doing purely hands-on. So in this case, you can just go ahead and make sure that you don't select this option. It is recommended, but it's not mandatory. So this is basically once the user signs in using the custom password that you set in, immediately the user will get a prompt to change the password, and the user can choose a password of his or her own choice. Fine. So once you uncheck this option, which is users must create a new password next sign in. Once these 6 items are being configured, click on next. Okay. Now this is a page where you set the permissions. The recommended option is that you add the users to the group. As if now we don't have any group created, the group will be created afterwards. So what we're going to be doing in this case is that we'll not set any permissions as of now. Okay, we'll not set any permissions. We just on the set permissions, you don't have to do anything. Simply click on next. Let me know once you're on this review and create. On set permissions page, don't do anything. Simply click on next. Just type it down once you're done. Okay, so In this case, this is the review and create option. You have the user details. Basically, you have set the username, the password, and the required password set to no. Permission summary is blank because we didn't assign any policy to this user. And tag value is not that much important. So we didn't mention any tag values. So this is not an important thing. So review and create is a page where it shows you that this is you have configured before you create this review these parameters. We are okay with all these parameters right now. We don't have to do anything else. Simply click on create user and the users will be created. Okay. Just click on create user. So in this case, this is what you get. You get this option where it shows you the console sign-in URL. This link will be used by the IAM users and username and password. Right now, we don't need any one of these details. We can exit safely from here and create a second user. So you will see that at the bottom right-hand corner, there's an option out there which says returns to users list. You have to click on returns to users list and you get this prompt. Continue without viewing or downloading the console password. You don't have to download anything as of now. There's an option that's called continue. Click on continue and you'll be on the user's dashboard. You have to go to returns to users list and continue. Okay. Now we have to follow the process again. We have to click on add users, right? Click on add user again. And we have to follow the same process for the second user. For example, the second user named is Chris. I put in over here. You can just put in any of your friend's name, your name, put any random name, first name. You have to choose provide user access to the AWS IAM console and choose I want to create an IAM user. Put the username again, provide access to the console and choose I want to create an IAM user. Start the process again for the second user. Let me know once we have done these 3 steps. Fine. I'm giving you a few more seconds. You have to put a username, check provide user access to the console, and select that I want to create this IAM user. What's next? Set a custom password. Fine. Just go ahead and set a custom password. And once you set a custom password, uncheck that users must create a new password at the next sign in. So set a custom password and please uncheck this option. This means that user will be able to access the root account via console. There's another method that's called CLI, command line interface, or maybe third-party APIs, in which third-party programs can be also used to access root account. See, for example, if we use CLI, okay, let's suppose if we use CLI, so we can also give access to the CLI part of it. So there are multiple ways to access AWS account. This is the web. This is the web-based or GUI. This is the management console that we get access to. The second method is the CLI part of it, command interface, in which we execute some commands and access the servers and deploy them. And the third part is API or we use SDKs. So in those cases, there are multiple methods or methodologies we can use to log into AWS account. Now, if I say I want to give the management console access, this means that this IAM user will be able to access root account by logging in to the management console. Okay, what's next? You don't have to do anything. Click on next. You don't have any set permissions. Click on next and click on create user. So click next twice, click next twice, next, and create the user. Basically, you don't have to set any permissions as of now. There's no need to set any permissions. Click next, click on click next, and create user. Next will take you to the set permissions. We have to skip it. Again, next, it will just take you to this review and create page. You have to skip it. Click on next. Click on create user, and the user will be created. Click next, and click on create user. So click on next. You'll get to set permissions page. You don't have to set any permissions. To skip it, click on next. You get to review and create page. Click on next and create the user. So click next, next, 2 times next, and click on create user. Now click on returns to users list and click on continue. Right? Click on returns to users list and click continue. Return to user list and click on continue. Right? Now, as a challenge, you have to create a third user by yourself. And I'll help you out right now. Of course, I'll be creating a third user and show you, but as a challenge, you have to create a third user with the same settings. You choose the same password. Of course, the username should be different. The username should be different, but as a challenge, create a third user by yourself. That's great. Okay, so I click on add user in my case. Name the last user as Kunal. Right? Choose provide user access to the console. Choose I want to create an IAM user. Right? Choose a custom password. Okay, and then I uncheck this option. User must create a new password at the next sign in. So the same thing you have to do. You have to choose a username, give that user access to the console access. You want to create an IAM user, set a console password, and then you uncheck this option that the user must change the password. Click on next. You don't have to set any permissions. Click on next and click on create user. Click on return to user list, click on continue, and you're back on the user dashboard. And as if now you have 3 users that you have already created on this IAM dashboard. So this is being done. Okay, we're on the same page. So as if now we have performed the first 3 steps successfully. Okay, now let's do the last 3 steps. These 3 users will be now formed. Let's suppose these 3 users are my software developers. They need access to certain tools. Now, if I just open the list of services in, okay, let me just do one thing. Let me just open in a new tab. Can you see that if you don't have to just go to a page, but if you just go to view all services, you will see that on the AWS Maven console, there are a set of developer tools. Okay, these tools are required by developers to work on the development of some applications, release new software, and so forth. So you have developer tools like, for example, Code Start, Code Commit, Code Build, Code Deploy, Code Pipeline, X-Ray, Cloud Shell, Cloud9, for example. These are the developer tools, right? Which most of these tools, most of which will be used by developers. I want these software developers to access some of these tools. You don't have to learn about these tools. It's not in the scope of this course, but just to apprise you of the fact that these developer tools will be used by developers a lot. So we have to give access to them, the basic, so they can do the basic development on cloud. For example, Code Pipeline is used to create the entire it uses the method of CI/CD, continuous integration, continuous deployment. So the entire pipeline is created starting from the commits to the deployment. So it creates the entire flow of how the software is released. I'm giving one example. Now, I want this that all these 3 users will have certain access to some of these tools under developer tools. They should be having access to some of these tools out there. In this case, what we shall do next? We should be going to user groups on the left-hand side. So on the left-hand side, where you can see the menu options, we have users. We have to go to user groups. Okay, and you can see the definition. A user group is a collection of IAM users. Use groups to specify permissions for a collection of users. So click on users groups on the left-hand side. Let me know once you're on this page. Okay, what's next? You click on create group and it says user group name, enter a meaningful name to identify this group. Fine, click on create group. You name the group as developers, right? Just put a name and select all the 3 users. So click on create group, enter a meaningful name, for example, developers, and select all the 3 users in the list. Let me know what's wrong with this thing. So I'm saying that all these 3 users will be the part of the group called developers, they will be having the same access to my developer tools, the same type of or the same level of access or same type of access. Please go ahead and do that. Okay, what's next? Under attached permission, so this is being done. You create a user group name and then you have added these 3 users. What's the next thing? It says attach permission policies. I've listed down these 4 policies that I need to, or these type of 4 permissions. These 4 permissions I want to give to my IAM users. The first one is AWS code commit full access. This is basically used to host private key repositories. Now, you can search for the policy. For example, there's a search menu. It says filter policies by property or policy name and press enter. For example, let's type in CODE code and COMMIT code commit. Press enter, and I will see that I will see a list of these 3 policies. Please search for code commit and let me know once you are able to list down or filter out these 3 policies. Right now you have to, once you just search for code commit, you have to select AWS code commit full FULL access. Right, policy selected. If you see on the top, even I was confused initially when I started working on this with this dashboard. They've just changed a few months back. Can you see that in your case it will show you selected 1 out of and the total number of policies. So selected 1 out of the total number of policies, this means that this policy is selected, and this is applicable to all of you guys. Once it is showing 4, you must have selected 4. That's why whatever policy you have selected, it will show you those policies only. No worries if you selected 4 by mistake, that's okay. No worries, don't change anything. Fine. So the overall numbers can change because I have some customized policies. That's okay. I have some additional policies added. I've customized them. That's why. Fine. Okay. So you have added 1 policy. I guess we're on the same page. Now you will see that there's an option which says clear filters. Now you have to clear the filter and look for another policy. Okay, so click on clear filters so that the filters are being removed, and you're back to the same page where you can filter the policies. The next policy that you're looking for is AWS code deploy full access. Now, either you can just put in code deploy full access or just type in code deploy and just type in FULL, right? And you need to select code deploy full access. Go ahead and do that. Basically, this is a tool to release a software or upgrade the application version on multiple instances at the same time. Please go ahead and do that. Just type in done once you are done with this thing. Okay, done. Now the same thing, you will see that on the top, it says selected 2 out of 850 in your case, right? The same thing you have to do now. You have to click on clear filters. You have selected 2 out of the overall number of policies you have. Now the next policy you're looking for is code build developer access. And this is for building a build and test server. It is a part of the software development lifecycle. So it is code build developer access. So you can just copy and paste as it is, or just type in code CODE build, or you just press enter. You will see that it says code build developer access, and you will see that once you've selected it, it will show you selected 3 out of 880, and will show you that this is being selected. You have to go ahead and clear the filters, right? Now, as a challenge, you have to search the 4th policy by yourself and select it, which is Amazon S3 read-only access. Go ahead and just do the stuff by yourself. I'll show you, but just to make sure that you just do it by yourself, search for the fourth policy and select it. Now, the 4th policy that I'm looking for is S3 read-only access. Read. If you just type in S3 read as a keyword, so basically I'm just making you comfortable looking for the information on the management console, so that you don't have to struggle later on afterwards once you have to start. Because see, it's a skill that you have to adopt, that whatever information you're looking for, you can just search by just typing some keywords, and the information comes in front of you. Whether it's looking for a service, looking for a policy, you have to attune yourself or adapt yourself in searching for the information looking for by just tapping certain keywords. I choose as to read only access, and you will see that on the top it says selected 4 out of 880, and I click on clear filters to clear the filters out, and this is being done. Fine. So overall, so far so good. We have grouped the people together under the same group name as developers. These 3 developers have been selected, and we have added 4 policies out of 850 in your case, right? We can attach up to 10 policies to this user group. Fine. So as if now it's been done, click on create group, the bottom right hand corner, and it says, so I go to user groups right now, my group has been created. Just do that. Okay. So I click on the group name. So this is my user group called developers. These are my 3 users. Fine. And if I go to the permissions on the right hand side, these are the permissions added. This means that all these 3 permissions, yeah, it's under permissions. All these 4 permissions, I'm sorry, all these 4 permissions, S3 read only access, code deploy full access, code commit full access, code build developer access. All these 4 policies are under the permissions menu. All these 4 policies are being applied to these 3 users. Testing part is really easy. There's nothing too much technical about testing the things out. We need to understand one thing, that when you need to test an IAM user, you have to either log out from the root user account, because you can't have 2 login sessions on the same browser. Either you can open the private window, or you can use a different browser. So for example, if I go to Google Chrome, right, there's an option called new incognito window, right? So for example, on the main browser window, I have the root user logged in. I've logged in as a root user. I just go to file and choose new incognito window, and the incognito window I can sign in as an IAM user. So on the main Google Chrome browser session, I can just log in as a root account owner, and I can open an incognito tab and sign in as an IAM user. If you have 2 browsers, I think that most of us have 2 browsers. Maybe you have Mozilla Firefox or Google Chrome or Microsoft Edge, whatever you have. You can sign into a different browser, or you can use a different browser and sign in as a root user. The crux of the story is that you can't have 2 successful logins on the same browser session or on the same browser. Either use an incognito window, private window, or use different browser for IAM users to sign in. Fine. Now, how an IAM user will sign in, or what's the process? There are multiple ways how to find that link, but if you could just go to a dashboard, right? You just go to the dashboard, and you pay attention to the right-hand side of this page, this one. The right-hand side of this page, you will see that there's something called sign in URL. This one. Okay, this is the link that your IAM users would be using to sign in. Now they can also go to aws.amazon.com and sign in as an IAM user. They have to put in the root account ID and their username and password. That can also be done. Or you can just give link to the IAM user, and this link already contains the root account ID, right? If you see at the top right hand corner, every root account gets a special unique root account ID. So the format of this link is https:/, the 2 forward slashes, then this is the root account ID that you have, .signin.aws.amazon.com/console. So this link can be used. This link can be used. So in this case, what we're going to do next is you just go ahead and copy this link, right? First of all, please find this link and copy it. Let me know once you have done this thing. You have to go to the dashboard on the left hand side, right? Just click on the main dashboard, and on the right hand side, you'll find under the AWS account, you'll find the link. You have to copy this link. Just do that. I'm not able to see permissions. Where exactly we're in right now? We already bypassed, or we have already surpassed that permissions question that you put in. I've already shown you how to see the permissions. Now you're not able to see the permissions, but you're still working on the groups configuration. Okay, now you just copy this link. So I'll use Google Chrome in this case and paste this link. Right now, of course, it will automatically pick the root account ID. You put the username and the password, click on sign in, and then you should be able to sign in on behalf of this IAM user. Right now, this IAM user is trying to access a root account only. This is not a different account. Steve, in my case, is an IAM user who's trying to, or who has accessed root user's account by logging in via his own credentials. If you see the top right hand corner, it says account ID. This is the account ID of the root account, and this is the IAM user Steve. Now, if you go to any of the services, for example, you go to EC2, right? You would just go to EC2 right now, you will get that API error message. Why? Because the policy that we selected, the policy does not, the policies, they don't include, there's no inclusion of the EC2 access over there. Fine. So in this case, this is the API error message you will get. If you go to EC2 dashboard, or if you just go to the main page, you try to access any of the service, you'll be basically being get that insufficient error message, or you'll be kicked out of that specific service because you don't have access to. If you go to view all services, and these are the developer tools you have, for example, code commit. You go to code commit, you'll not find any error message, right? The reason being because code commit, you have full access to it. So if you go to any of the service, it will show you insufficient error message, API error message. But for example, if you go to code commit, you will see that there's no error message it's showing up. Fine. So you can log in and just try to access some of the services, but try to access those services, for example, code commit, code deploy, code pipeline, S3 read only access. You will see that there will be no error message that will get. But if you just go to any of the services, haven't understood any policy, you'll start getting the error messages. Please go ahead and navigate through these options once. Let me know what's done. Shubham is saying, I forgot user credentials. You have to go to users list, click on the user, and under users, you have security credentials. Under security credentials, you will see that it says console sign in. Click on manage console access. Over here, you can set a custom password, right? So you have to go to users, then you have to go to security credentials, users, security credentials, and click on manage console access. Once you go to this third option, you'll automatically get the option to reset the password. Again, if you can follow the instructions by yourself, I've already shown the instructions. If you do it right now, do that. Otherwise, there's no need for testing. It's optional. Fine. This completes the concept of users and groups. Not able to find the dashboard. Let's navigate to the next concept. The next concept that we shall be discussing is the concept of policies. We discuss about the policies. What's a policy? A policy is a JSON document that helps you to define the permissions of IAM entities. Okay, so if you see the complete anatomy of the JSON document, the version, statement, effect, actions, resources, all these things are they are being put under these are the part these are the part of a JSON document. Now we discuss IAM policies basically are used to define the permissions. Let's understand the two types of policies that you can leverage. You must have seen those two types of policies, but I'll demonstrate and explain you in depth that what's the difference between these two different types of policies. So, okay, what are the policy types? Under the policy types, there are two different types of policies. Number one, we have the policy that is AWS managed. AWS managed is a policy type. The next one is customer managed. These are the two different types of policies that you can start leveraging. Now, what are the differences? The differences are that the first major difference is that the AWS managed is a default one. Default means that it is there for your use. You don't have to configure it. It's already being created for you. You start using it. Fine. The custom managed policy in this case is customized by AWS customer. Who said it is a customer? We are the customers. We are the customers, right? We use AWS for our deployment, so customized by AWS customers. So we can customize and create our own custom tailored policies. Second thing, so AWS managed is a default policy and custom managed is customized by AWS customers. Fine. In terms of AWS managed, what happens is that this is basically used in those cases in which you are not looking for any type of customizations. I would say that the AWS managed are there by default. They fail to provide you, or I would say that they don't provide flexibility or customizations. I'll give you a few examples afterwards, but they are not being custom tailored based on special business requirements. So it doesn't provide no flexibility or customizations. So it doesn't guarantee any type of flexibility and customization for you. And it's there, it's created, and you start using it. No flexibility, no customizations. On the other hand, it gives you flexibility and customization options. So in this case, what happens is there will be few scenarios where the AWS managed policy may not be suitable for you. Few situations. Of course, there are more than 800 AWS managed policies. You should be using them. But there could be few scenarios. I think there was some question put that question that, for example, I want to make sure that the user gets complete access to the EC2 dashboard, but which I need to refrain that user from terminating the instance. Users should get complete access to EC2 apart from terminating instances. Now that's a special requirement. That requirement cannot be alone fulfilled by AWS managed, because AWS managed policies are set. So in this case, you start using customer managed. Customer managed policies are the one that you can use based on your requirements or needs, which may change over the time. See, there are more than 1 million customers on AWS platform. It is kind of hard to customize the AWS managed policies for those more than 1 billion customers, because businesses have some special needs, some special requirements which change over the time. So Amazon says we give you a bunch of, or more than 800 policies, which we think you're going to be using it a lot. But in few cases, when you think that you have to create your own policies, because you have to set up your own infrastructure, you may have some special needs and requirements that you should be taking care of, or you should be working on them. So in that case, you create a custom managed policy. We give the tools to you to create a policy by yourself on your own. So in that case, you're going to be using the custom managed policy. Okay, so I give the example which Prashant has given. For example, let's suppose Amazon EC2 full access is a What is this? This is a AWS managed policy. Full access means that user can even terminate the instance. But the problem is that I want that users should get full access except terminating instances. In that case, I need to create a custom managed policy saying that Amazon EC2 full access is given to the user except terminate instance. So in this case, I have to create a customized managed policy and apply it to my users or the groups. Fine. That's where the customization comes into play. Now let's take a scenario. I give you Google Drive links to share with you the documents. What is a Google Drive? A Google Drive is nothing but what is a Google Drive? A Google Drive is nothing but it's a online backup storage or online storage service. Google Drive, Dropbox, Microsoft OneDrive. What are these? These are the online backup options. Virtual storage, you can say that, right? Now, when I put something in the Google Drive, it's not necessary I have to put the same data on my hard disk, on my computer's local disk. I can have some documents on the cloud. I can share the links with the users and share the documents, share some data with you. Fine. So in this case, we use these tools as online backup storage. S3 is also one of the online backup storage options which Amazon has built on its own. So if you go to AWS Management Console, there's a category that's called storage. Telling you for the sake of understanding, there's an option called S3. S3 stands for Simple Storage Service. It's an online backup storage that you use for your businesses. Simple Storage Service or S3. Okay. So in this case, Simple Storage Service S3, what is this? Basically, it's an online backup storage. It's an online backup or storage service. Okay. And it helps you to put a lot of unlimited amount of data that can be accessed from anywhere on the web. So it allows you to put unlimited amount of data that can be accessed over the internet, right? So you can put untold quantities of data. There's no any limitation. You can put any amount of data that can be accessed over the internet. Okay, so it's an online backup storage service which Amazon gives to you. Now there are two building blocks of S3, two major building blocks. Number one, the number one building block is an S3 bucket. So for example, let's imagine this is an S3 bucket. All right, so what is this? This is an Amazon S3 bucket. Now, what is an Amazon S3 bucket? It's a fundamental container. What do you mean by a fundamental container? It's a kind of a storage option to store your data. It is a fundamental container that can contain your data. Okay, so an S3 bucket is a kind of a container. The data that you put inside this bucket is called an object. So in this case, an object, it's nothing but it's a fundamental entity. It's a fundamental entity. So in this case, object is a fundamental entity that you put inside the bucket. Now, an object is a simple file, right? For example, it can be a PDF. It can be a document. It can be a spreadsheet, a PPT, a PNG image. It can be a JPEG image. It can be, for example, an HTML file, a CSS file, a Python file, a Terraform file, JSON file, YAML file, AVI file, MP3, MP4, etc., etc. So the data can be of any format. The object that you put in can be of any format. So there is no hard and fast thing. The data can be of any format, PDF, docx, xlsx, ppt, png, jpeg, html, css, python script, terraform file, whatever the format is, it does not matter. You can simply put a data or object inside a file inside a bucket, and you can store it. And you can store any amount of data inside it. Basically, the storage size is unlimited. AWS has not put any restrictions upon it. So this, I would say, the storage capability, it is kind of unlimited. The storage capacity is kind of unlimited. This is one more thing. An account. If I'm talking about account, I'm talking about root account only. Can have maximum of up to 100 of these S3 buckets. This is the limitation. Fine. If I show you some policies on S3, we have used one of the policies that's called S3 read-only access, right? You used one policy that's called S3 read-only access. Let's imagine. Let's go to policies. Let's take one example over there. Let's go. So these are my policies. For example, I just type in S3. Okay. Under S3, I have these policies. For example, let me show that. S3 read full access, read only access, right? So these are the two main policies I have for the S3. If I target only S3 buckets or S3 service, full access and read only access. Full access will give complete access. User can put some data, take some data out. Read only means he can only read the data inside the bucket. He can't remove or put some data. Okay, S3 full access and S3 read only access. Okay, so what do you mean by that? I'll list down some actions under S3 full access and S3 read only access. Under Amazon S3 full access policy, these are the actions allowed. One is list action. What do you mean by list action? I give a simple example over here. If I go to my Google Drive, I can see a list of files. First file, second file, third file, this is a list. If I go to my main Google Drive folder, the main drive, I can see a list of folders, right? What is this? This is a list action. I can list the main folders and the files within the folder. Okay. Consider S3 bucket as a folder and files are as objects, subfolder. Yeah. So in this case, what happens is, when I go to the S3, for example, let's suppose I go to S3. I go to S3, right? I can see a list of buckets of 26 buckets. Buckets are the containers for data stored in S3. These are the kind of folders or containers. I can see a list of 26 buckets. If I go to any of the buckets, I can see a list of objects or the data inside the bucket. This is called list action. Okay, understood? Now, for example, I want to get the data out of it. I want to download this Linux mastery.pptx or terminal saved. I want to download this file. I choose it, and can you see this is option called download? I can also download the same. Let's suppose I want to download some file from the Google Drive. I right click, and what do I do? Click on download, right? So I right click on the file and click on download. Similarly, I can just go to the bucket, right click, or I would say I choose it, go to download, right? This downloading action is or getting access to that data is called get action. What is this? This is called get action. Okay. Now, the Amazon S3 read-only access has both these actions allowed: list action and get action. However, S3 full access has two main actions that it allows. One is put action. Put actions mean I can put some data inside this S3 bucket. If I go back to the buckets dashboard, can you see there's an option that's called upload? This means that I can upload a file to the S3 bucket. I go to upload, click on add files. Now you don't have to learn this thing. I add a file and choose upload. So uploading the data to the S3 bucket is what? Put action. And if I delete the data from the bucket, for example, I upload the data, I click on close, I choose the RTF file and click on delete. And I just type in, for example, permanently delete. So what is this? This is called delete action. What is this? This is called delete action. So full access will give me list action, get action, put action, delete action. Amazon S3 read-only access has only these two actions allowed: list and get. Listing the items, getting the items out of it, putting the items, deleting the items are come under the full access. Read-only access will only allow to list and get the things. That's it. You can see a list of items and you can get the items out of it. That's it. Fine. Let's do a scenario based on this thing. What the scenario says. The scenario is I have, let's suppose, 100 buckets under root account. A root account has 100 buckets. Out of these 100 buckets, I have 2 buckets which I want to target. I want to work on these 2 buckets. This is my bucket 1. This is my bucket 2. Okay. Now, out of these 100 buckets, I have 2 buckets. I want an IAM user whose name is Steve to get the read-only access to my one of these 2 buckets or 100 buckets and full access to the bucket 2 and no access whatsoever, no access to rest of the 98 buckets or rest of the buckets, whatever the buckets you have, rest of the buckets. Absolutely no access to rest of the buckets. Based on this scenario, we'll be performing a hands-on and create a customer managed policy via which user gets the read-only access to one bucket, complete access to the second bucket, and rest of the bucket should be completely denied for him.
Just a quick info, guys. Intellipaat offers an advanced certification in cloud computing and DevOps by IAM Web. Through this course, you can learn all the important concepts of cloud computing, DevOps, AWS, Azure, Linux, and Python. The course features live classes with IIT faculty and industry experts, campus immersion at iHub IIT Roorkee, and includes certifications from both iHub IIT Roorkee and Microsoft. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials in our Achievers channel, whose link is given in the description below. With 24/7 support, placement assistance, and EMI payment options, this course without a doubt can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of cloud computing.
First thing first, it says create and attach your first customer managed policy. And this is the complete workflow, which has been broken down into 5 basic steps. The first step is to create two Amazon S3 buckets, and it makes sense because based on the scenario that I've laid down in front of you, or I've jotted down the complete scenario, we need 2 buckets. Then based on those 2 buckets, we need to create a customer managed policy. That this is an important stuff because this is where we'll be spending most of our time and effort. Then we have to create an IAM user and attach the customer managed policy to that user so that we can see whether that user gets the level of or the type of access that we want to give. And then we have to do the testing stuff, or we will be testing this entire implementation afterwards. In step number 1, we have to create 2 Amazon S3 buckets. Now, buckets, to create the buckets it is one of the most easiest part out. Okay, I'll show you how to create the buckets, and I'll show the step from 1 and 1 to 7. Okay, now you have to create the buckets with default values, which means that if I haven't mentioned anything in terms of the steps that you have to do to create the bucket, if it's not there in the document, then this means that you don't have to do that step. So you have to follow only those steps which are there in the document. I've excluded other parameters which are advanced in nature because right now we don't have to go to the advanced level of S3. We just have to have 2 buckets for us for this hands-on. So you can search for S3. Okay, now once you just type in S3, it says services, and you will see S3 scalable storage in the cloud. You click on the S3, and this will take you to the S3 dashboard. Now, even the S3 dashboard, you will see that it is global in nature. Global doesn't mean that a bucket can be can spread across all regions. We have this global kind of interface. The reason being, if you see my bucket list, all the buckets that belong to separate regions can be seen on a single page. You don't have to switch back and forth or navigate between different regions to access the bucket in separate regions. So once you go to global page, you can see the list of buckets on one page that reside in separate regions. Fine. Now, let's do one thing. I'll just show you how to create a bucket. And there's one thing that we have to be aware of. We'll be adding some prefixes for our convenience so that we can easily differentiate between these two buckets. I click on create bucket, right? And it says bucket name. Fine. Now the bucket name, first thing first, has to be unique, which means that no 2 buckets can have the same name. Okay. Bucket names must be unique. So this is a important fact. Bucket name must be unique, which means that no 2 buckets across AWS. In AWS infrastructure or platform, no 2 buckets can have the same name. For example, no 2 people have the same Gmail IDs, or no 2 people have the same phone numbers, right? So in this case, no 2 buckets can have the same name. So you have to think of a unique bucket name and make sure that you choose lowercase only, because no uppercase or no, I would say, you can't use caps. No capital letters allowed. So lowercase only. Fine. It can be alphanumeric. You can use a combination of numbers and alphabets to choose the name. It can be alphanumeric, and there are only 2 special characters allowed. What are those 2 special characters? The 2 special characters that are allowed are hyphen and dot. Right? So these 4 things you should be aware of. The bucket names must be unique, which means that no 2 buckets can have the same name. For example, if I just put the bucket name as test, right, and try to create a bucket, it will throw me an error message, bucket with the same name already exists. Fine. Now, you have to think of a unique bucket name. Now, what you can do is that you can just type in your, for example, your first name, and just type in, for example, just type in IAM policy, for example, IAM policy demo, right? And just to make sure that we'll add, because we create 2 buckets, we'll add 2 prefixes. I will add 1 prefix for, like, for example, ONE1 for the first bucket, or just type in first, FIRST, right? Because we'll add the prefix first for the first bucket and prefix second for the second bucket. Or you can just type in ONE1 or TW2 for the second bucket. It's all up to you. So for example, I put in Rohan hyphen IAM policy demo hyphen first. And the second bucket would be this one. For example, this would be my second bucket name. I'll not put it right now over here. So for example, I just put second for the second bucket, just for the sake of example I'm giving to you, right? So that's how you have to differentiate between these two different buckets, right? Go ahead, choose a name, make sure that you prefix or append first or ONE at the end of it. Go ahead and do that. Now you can just copy this bucket name because we're going to be just pasting it for the second bucket name, but we'll just change the prefix of it. You can just copy it, right? I just right click and copy it, because the second bucket I'll be creating will have the same name, except I'll be putting second as a prefix for this bucket, for the second bucket. Please assign a bucket name. You can put your first name, right? Hyphen IAM policy demo hyphen first, because some people may struggle to choose a bucket name because bucket names are unique, and you may be trying to choose a bucket name which already exists. So for simplicity and to make sure that you don't face issues, put your first name hyphen IAM policy demo hyphen first. Okay, I'm just putting in, yeah, just go ahead and do that. Now, the buckets are contained inside a region. You should not be bothered about the region as of now, because we're not doing any advanced hands-on in which we have to be contain ourselves in a specific region. But just an FYI, you can choose the region of your choice. Whichever region is selected, don't be bothered about it. You simply have to go at the bottom. There's an option that is create bucket. Click on that, and your bucket gets created. Those regions are disabled regions on your account. That's okay. Don't be bothered about it. Go ahead and click on create bucket. Go ahead and click on create bucket. Just tap in done once you're done. And this is what the bucket you have. So in my case, this is my first bucket created. Are we done with this? We need 2 buckets to get started. Based on these 2 buckets, we will be configuring the customer managed policy. We shall just perform this operation again. We click on create bucket at the top right hand corner. Fine. Now paste the same bucket name, but just remove first at the end and put second. That's it. If you put 1 for the first bucket before, just put in TW2 for the second bucket, so that you can differentiate between these 2 different buckets that you have. This will help us to easily differentiate between them. Fine. Of course, the bucket names are unique. Just for the sake of convenience, just having the same bucket name, but we're just changing the prefixes. Once you put second for the second bucket, go straight to the bottom and click on create bucket. Please do that. Let me know once your buckets are being created. As you can see, I have 2 buckets. One has a prefix as first, and the second has a prefix of second. Prefix or suffix, whatever you want to say. So I've added first at the end of the first bucket name and second at the end of the second bucket name. Done. Fulfill the first prerequisite, or I would say we have performed the steps till 7, right? So we have performed steps 1 to 7. Fine. Are we all done? We have the 2 buckets in front of us that we're going to be using, or we'll be using these as objects, or I would say these as the target points to create our policy. Okay, great. What's the next thing? Now, in the next step is that we have to start working on the policy configuration. Now, this is where I have to go very slow, because this is the very first time you are getting engaged in the process of creating a customer managed policy. The process is quite simple. It is just that once you perform this once or twice, you become aware of the entire process. So we'll just go with the second step. The second step is step number 2, create a custom managed policy, right? Now, what you have to do, all of you, what you have to do is that you can have this S3 dashboard opened up. Don't close this page. Just type in IAM. Now you have to open an IAM tab. So what you can do is that just open IAM, right click, and you can just open that in a new tab. Because why I'm saying to open that in a new tab, because you have to copy and paste this S3 bucket name afterwards. It will be easier for you to do that. So I open IAM in a different tab, right? So I have S3 dashboard on the left-hand side. On one tab, it's opened up. On the second tab, I've opened IAM. So please go ahead, access the IAM dashboard. You can, for the convenience, try to open that on different page or a different tab. Please go ahead and do that. Just tap into once you're done with this. Now, once you go to the IAM dashboard, you're going to be looking for IAM resources. You have the policies. In this case, now I guess you must have 0 policy, 1, 2 policy. Basically, this shows me that the number of customer managed policies. I have right now 30 customer managed policies created. You may have 0, 1, 2, whatever number you have. That doesn't make any difference. Or you can just click on policies on the left-hand side. You click on either of these two options, you land to the same policies page. Okay. So once you land to the IAM dashboard, click on policies. Let me know once you're on the policies page. Just type it done once you're done with this. Policies page under IAM. Okay. I'm on the policies page right now. Now, what's a policy? It's an object in AWS that defines permissions. Fine. There are 2 types of policy that I've discussed with you. One policy is custom managed and the policy is AWS managed. We're going to create a customer managed policy based on the 2 buckets that we have created. I click on create policy at the top right hand corner. And this gives me a page in front of me. Let me know what's on this page. Just type it done. It says specify permissions, policy data. So click on create policy and you land to this page. Now it says select a service. This clearly demonstrates to you that you have to select a list of services: auto scaling, CloudFront, EC2, IAM, Lambda, RDS, S3, SNS. These are this is the combination of the services that you can see. Now you need to click on S3, right? Because the service that we would be working on, or the service for which this custom managed policy would be configured, is S3. So we are trying to create a custom managed policy for the S3 service. Fine. You have to click on S3. Click on S3, and then it takes you to the S3 configuration page. Click on S3. Let me know once you are on that page. Please go ahead, click on S3. Let me know once you're on that specific page. I'll show you one more time, just in case if some people got confused. Click on create policy, right? You will see a list of services in front of you. Now the service that you're looking for is S3. Click on S3, and this is where you have to start applying the configuration, or you have to start implementing the steps. By S3, based on the scenario that we are working on, we need to create the policy for S3 buckets. That's the reason. Based on the scenario that we are working on, we need to create the policy for S3. That's the reason. I hope that you are aware of the scenario. Now, what's the next thing? The next thing is that it says actions allowed. All actions? The answer is no. First thing first, we'll be targeting our bucket which ends with first or ONE. My intention is, or I want to do this thing is that I want that the user should be able to get read-only access to the first bucket. Read-only access to the first bucket. Regarding the second bucket, the user should be able to get the full access or complete access. For the second bucket, the user should be able to get the complete access. We'll first target our first bucket. For the first bucket, we want to allow read actions. So in this case, if I go back to this policy editor, you will see access level, list and read. Fine. You have to expand list and choose all list actions. Please go ahead and do that. Okay, now once we choose all the list actions, let's go to read. Okay, go to read and choose all read actions. Please go ahead and choose all read actions. Let me know what's done with this. Now in the read, you will see that it says get. So that we can include get action, especially we can get the data out of the bucket. Select all the read and list actions. Let me know what's done. Done. Are we done? Have we selected all the, so you have to select number 1, all list actions. Number 2, all read actions. Are we done with this? Because right now we are targeting our first bucket. Now, what you can do is you scroll down. We're not going for write permissions management tagging. These things would be excluded. Then go to resources. We have already chosen which actions, list action and read action. Especially read action, I've listed all the get actions so that I can read the data. I can get the data out of the bucket. Now, if you want, you can click on collapse all so that you just collapse and the things become very neat and clean. You're easy to navigate. You just click on collapse all and basically all the options get collapsed. Basically, the main thing is that you have to ensure that you have chosen all the actions under list and read. Fine. So the page becomes neat and clean and tidy. The next thing is that you have to go to resources. The first resource that you should be targeting is the bucket. Now you have to apply the permissions at 2 levels, bucket level and object level. What's a bucket? It's a container. Right at the bucket, it says get bucket resource ARN for the get bucket location and 48 more actions. It's saying that whatever actions you have chosen, that's okay. But can you please specify which bucketing you're targeting? You may have 100 buckets in your account, but which specific bucket you're talking about? There's an option that says add ARN. Okay, what is ARN? I'll let you know. But click on add ARN and let me know once you're there. Just click on add ARN right at the bucket name. Let me know once you're on this page. Just type in done once you're done. I'll show you one more time, just in case if you're confused. There's a separate section for resources. Okay, now we have to target 2 resources, bucket and object. Under bucket, it says specify bucket resource ARN for the get bucket location, and it says add ARN. I click on add ARN over here, and this is what I get, right? Now I can just put that the complete text of it right now, but line by line, but I just go with visual. Let's suppose if I choose any bucket name, it says a star. What do you mean by star? You don't have to select it. I will be mentioning about bucket name. It means all the buckets. So if I by mistake choose star, this means that this policy I'm going to create right now applies to all the buckets, which is not the case, which is not applicable in our case. So you have to unselect it and you have to specify the exact bucket name. Okay, so go back to the bucket dashboard, copy the first bucket name as it is, and you're going to be pasting it. Automatically, the Amazon resource name of the bucket. Now, ARN is a special identifier for specific resources. The ARN of your bucket populates. So you have to copy and paste the first bucket name as it is in any bucket name list. Please go ahead and do that. So basically, it will automatically populate the ARN of your bucket. Fine. Now, once you have put your first bucket name, so ARN stands for Amazon resource name. It's a special identifier you give to a bucket, which Amazon gives to your buckets and some resources. Once you have done, what next? Click on add ARNs. Add ARNs. Can you see that? There's an option at the bottom right hand corner. The option is add ARNs. Go ahead and do that. Done. You will see that once you click on add ARNs, your first bucket ARN or Amazon resource name populates. Are we done with this? Right? So you've right now you've targeted your first bucket. You're saying that this read-only access I'm going to mention for the first bucket. Okay, what's next? You scroll down and now you have to target the objects. What's an object? It's a file or data that you put inside the bucket. So once you scroll down, the last item it shows in the list, and this entire list is object. It says add ARN to restrict access. Go ahead and click on add ARN right to the object name. And this is what you'll get. Click on add ARN right to the object name. Let me know once you're on this page. I'll show you one more time. You have the object as the item last in the list. You have to click on add ARN right to the object name. Okay, click on add ARN. Fine. Once you're on this page, you have to again copy and paste the first bucket name. Please do that. What's the next thing? Under the resource object name, choose any object name. So what do you mean by that? This means that this policy applies to all the objects in my first bucket. You have to, again, you're saying that I want to apply this thing to all the objects. What does the star stands for, or this file kind of notation means? All the objects. In this case, the previous step targeted the specific bucket. The second step targets the objects inside the bucket. So the previous step targets the buckets that I want to list down. Once I mention the bucket name, now it asks me that which object inside the bucket comes under this policy. Okay, so when you apply the permissions to restrict access, you have to apply the permissions at the bucket level first, and then to the object level. Because maybe you have some objects that you want to restrict, and other need to be taken out from the restriction. Fine. Have we done with have we done this thing? You have to mention the copy and paste the bucket name, first bucket name, and under resource object name you have to choose a check, or you have to check any object name, which means that all objects in my first bucket will be included, or the policy that I'm going to create right now would be applicable to all the objects under the first bucket. Are we done with this? So this means that any data, any folder, any file inside this bucket would come under this policy. So this policy I'm going to create right now will apply to all the objects which I'll be putting inside my first bucket. Are we done with this? Okay. Go ahead and click on add ARNs. Add ARNs. And you will see that this under the object, it shows you a single line where it shows that this is the bucket name / us a wildcard notation, which is asterisk. This means that now this policy is applicable to all the objects or folders inside this bucket. Done. So to reiterate what we have done, we chose list and read actions, all the list and get read actions over here. And then what we did, those list and read actions will be applicable to the bucket which ends with first. And inside the bucket, it is applicable to all its objects. So the list and get actions or read actions is applicable to my first bucket and all the object that it may contain. Okay, we're clear about this thing. What's next? Can you see there's an option out there which says add more permissions? You have to click on that. Click on add more permissions. Okay. Once you click on add more permissions, it says select a service. I click on select a service, and which service will be selecting now? S3. Okay. Click on S3. Let me know once you're on this page. Click on add more permissions and choose S3. Add more permissions and choose S3. Okay. Now we should be targeting the second bucket. For the second bucket, we need to allow the complete access. Fine. So over here, under the access level or under the actions, what we should be selecting? All. Okay. So you have to choose all S3 actions. So if you choose all S3 actions, automatically all the actions get selected. Please do that. Let me know once you're done. Okay. So I'm saying that for the second bucket, I want to include all the actions, whether it's list, read, write, permissions management, tagging, nothing is being excluded. Fine. What's next? I scroll down, and now as a challenge, you have to go ahead and specify the bucket ARN for the second bucket. Go ahead and as a challenge, you have to add the ARN for the second bucket. I'll show you the solution afterwards, but I'll give you a minute to try it on your own. If you're confused, that's okay. After a minute, I'll show you exactly how to do it. Because you have done this in the previous step for the first bucket, just try it on your own for the second bucket as a challenge. So in this case, I click on add ARN right at the bucket, and I just go ahead and copy and paste the second bucket name. Simple. Fine. I copy and paste the second bucket name. I show one more time. I click on add ARNs on the bucket. Under any bucket name, I just paste the bucket name. Automatically, the other fields are populated. You don't have to change them. Click on add ARNs. Done. I'll give you a few more seconds just in case if someone has not done that. Now scroll down. As a challenge, go ahead and apply the object. I'll give you a minute. If you're unable to do it, that's okay. I'll show you. Go ahead and perform the object restrictions now. You click on add ARN. Under any bucket name, paste the second bucket name. And under any object name, you have to check. Right? So under the any bucket name, put the second bucket name. Under the resource object name, you have to choose all the objects. So you have to tick it. You have to check it. So I'm saying any object under the second bucket shall be included as part of this policy. Are we done with this? Okay. Go ahead and click on add ARNs. Click on add ARNs. And that's been, this is done, right? Fine. Now we have targeted both the buckets. Click on next. Okay. So on the next stuff, it will show you exactly that what you have to go to review and create. First thing first, you have to enter the policy name. I can just type in my, for example, I put any random policy name. It doesn't matter. Just put a policy name. And in the description, you don't have to type in anything. So basically, just go ahead and enter a policy name. Please go ahead and do that. Click on next and enter a policy name. Right? You can choose any policy name. It doesn't matter. You can just put in, for example, demo policy, my customer managed policy, my first policy. Put anything over there. Okay. Once you go ahead and do that, scroll down, and it will show you the list that you've selected. Okay. And scroll down and click on create policy at the bottom right hand corner. Can you see that? So once you put the policy name, no need to add a description. It shows you the permissions that you have selected. It's okay. This is permissions defined in the policy. That's it. You can click on edit and you can change it up. You can make the corrections before you can create the policy, but we don't have to do it. Put a policy name, No need to change the description or add a description. It's purely your choice. We don't have to change the policy. Simple, go ahead and click on create policy. Okay, and your policy gets created. Please go ahead and do that. On the top, it will show you this thing, this message. The policy is being created, right? So we have performed 2 steps. We have created 2 buckets, and based on those 2 buckets, we have configured a customer managed policy. Fine. Are we all clear till now? You're on the same page? Manideep Singh, in real time, how we define the policies by using JSON code or using the console. This thing that we're doing right now, it is a replica of real time only. Okay, and using the JSON code, the policy, if you click on view policy, automatically generates the JSON code for you. If I, for example, go to JSON version of it, this is the JSON code that it generates. So right now, whatever we are doing, it's real time only, or it's the reflection of the real time things that we'll be doing. So if you just go to the JSON, click on the policy, click on JSON on the right side of it, the policy data that you have used, it automatically generated the JSON policy. Okay, so guys, what's the next thing we are going to do? The next thing that you're supposed to do is you have to add a user. You have to create an IAM user, and you need to attach a customer managed policy to the user, right? So you have to go back to the IAM dashboard, go to users on the left hand side. Now you have 3 users in front of you. You still, guys, you still have the users create. I suppose no one has removed the user. You still have the users. So yes, we have the users listed down. Okay. Now what you can do is that you can pick any one of these users, right? For example, I click on my first user, Chris. Fine. And yeah. Okay, so what actually one more time. You have the list of users in front of you, 3 users. Click on any one of these 3 users. You have to click on any one of these 3 users. You'll just go to the users dashboard. This will save our time because we already have created these users. Is it done? Okay. So once I click on any one of these 3 users, I can see the users details. For example, the summarization, I can see the ARN of this user. Even the user is user configuration has the Amazon resource name, the date it was created, right? Now this user is a part of a group. Once you click on the specific user and you just check out the user details, you can see that there are a bunch of options laid out in front of you: permissions, groups, tags, security credentials, and access advisor. You have to go ahead and click on groups. Okay. Once you go to the groups, you have to choose a group name and click on remove. So I'll show you. So I'll just connect all these dots. You go to the user details, go to groups, and then you have to check the group. Once you check it, the next thing that you have to do is you have to remove it. So I want the intention is I want to remove this user from the group so that there's no conflict in terms of policy, because you remember I chose Amazon S3 read only access as one of the policies. I don't want this user to be a part of any group as of now, because I just want to add the customer managed policy that I just got created. So you just have to go ahead and click on remove. It says remove user from the group developers. Click on remove. Just type it down once you're done with this. And you will, this will prompt you this message on the dashboard. This user does not belong to any groups. Are we all done with this? You just pick any user randomly from the list. So you can just pick any one of these users. Click on the user ID or the user name. You'll just go to the user's dashboard and you can see the bunch of details for that specific user. You have to go to groups and you will see that this user has a user groups membership. You have to select this group and click on remove. It says that, are you sure, or you want to remove this user from group called developers? Click on remove. and then you'll get this prompt. This user doesn't belong to any groups. Are we all done with this? You have to perform this action only on one of the three users. Don't perform on all the three users, only one of the three users, right? Are we all done with this? Now left to the groups, there's a tab that's called permissions. You have to go to permissions, and then there's an option on the right hand side which says add permissions. So you have to go to permissions on the left hand side of the groups, and within permissions, just on the right hand side, there's an option that's called add permissions. Once you go to add permissions, now what you have to next is that you have to go to add permissions, and there's something called add permissions. Add permissions and create inline policy. Click on add permissions. Okay. Once you go to add permissions, the option on the right hand side is it says attach policies directly. Okay, you have to click on that option, attach policies directly. Basically, it's we are saying that we don't have to add the user to a group. We are going to attach the policies directly. Please go ahead and do that. Okay. Now, once you go to attach policies directly, it says all types. Okay. So what it says, types. So in the types, you have to choose customer managed. Can you see that? Once you go to attach policy, in the all types, you can see it says customer managed. You have to select it. Please go ahead and do that. Okay. Once you choose customer managed, you'll be able to see the policy that you created. You have to select it. So you have to choose customer managed, and you have to select. So once you choose add permissions, you choose attach the policies directly. In the type, you choose customer managed, and automatically the policy that you created will show up. Please go ahead and do that. Done. Okay. So what we have done is that we have removed the user from the group so that there's no conflict in terms of policies, because in that policy in that group, we gave the read-only access. So we want to make sure that there's no conflict in terms of policies. We remove the user from the group, and they're trying to add this customer managed policy, right? So what's next? You have to click on next. So it shows you that this is your username, Chris. Fine. And this is the permission you're going to add to it. Now you need to go ahead and click on add permissions, and the permissions will be added. So now what you can see that this user we are working on is added this customer managed policy. So we have gave this special access to this specific user, right? Are we all done with this? Are we all done? So what's the next thing? The next thing we're going to be doing is that we have to test the user. We have to go ahead and test the user, right? So we have to test the user access. So basically, you have to log in on behalf of this user. Now, as a challenge, go ahead, use a different browser or an incognito window and log in on behalf of the user. Just type and tell once you're done with this. Sanjay, if you remember the group that we got created, that group has the S3 read-only access. If you go to the group right now and go to permissions, the permission that we added to that group was S3 read-only access. Okay, so to avoid, I would say to make sure that there's no conflict, because we created a special policy for the S3 buckets, and this gives S3 read-only access to all the buckets. To avoid the conflict, to make sure that there's no issues out there, that's why. Because sometimes, see, generally what happens is that when you apply the permissions at the user level and at the group level, the user level permissions get high priority. This means that technically this should be null and voided, this one. Okay, so the user permissions gets high priority, just to make sure that sometimes we're not sure whether the user is a part of group or not, just to make sure that we don't make the users a part of any group. To test it, we have removed that. Otherwise, if you have just not removed the group, that would not have caused any issues for us. Okay. Now, guys, as a challenge, you have to go ahead and you have to log in on behalf of this user. Process how to log in on behalf of an IAM user. You can use an incognito window, a private window, or maybe you can use a different browser, because on the same browser session you can't have two logins. So in real time, see, it's not about real time or unreal time. If you want to see, generally what happens is, yeah, in generally if you add a special permission to a user, whether it's real time or it's a testing environment, the user permissions have always the upper hand, high priority. Fine. So it all depends whether you want to make the user the part of a group or not. But yes, you can go with any one of those two approaches. Either you remove the user from the group itself if you don't want to add those permissions, or you add the permissions above it. Both these two approaches will work. Okay. Now I'll just go ahead and log in on behalf of the user. So I go to my dashboard. On the right hand side of this dashboard, I just copy this sign in URL, and I just go ahead and use Google Chrome, a different browser, to just log in. So guys, as a takeaway, an important point, when you have the user being applied the permissions at the group level, and you specially assign different permissions or any policy to the user separately, the user permissions will always have the upper hand or higher priority. But still, you have to try to ensure that you don't have any conflict between these two different permissions, group permissions and user permissions. But the user permissions are applied first. Okay. Now I just go ahead and just log in, and just try to log in on behalf of this user and see that. Yeah, I just do that. I just log in on behalf of this user. Okay, I'm sorry, I picked a wrong user. Hang on 1 second. So I just want to change the user ID. Yeah, so I just put in Chris in this case. Right, click on sign in, and I just go ahead. So I've logged in on behalf of this Chris. This username is Chris. Now, as a user, if you just try to navigate to any other service which you haven't got access to, for example, this user goes to EC2 service, automatically he will get the API error message. Okay. The reason being because we haven't given access to any other service apart from S3. So if I go to the home page on behalf of this user and I choose S3, so the user will be able to see two buckets in front of him. Of course, I have all the buckets, so I'll just filter out these two buckets only so that there's no confusion, right? So these two buckets are there. You'll be able to list down these two buckets. Now, what you have to do is, once you're on the buckets list, click on the first bucket. Okay, let me know once you are on the buckets dashboard. On IAM users page, you have to log in. You have to log in on behalf of IAM user. Now, sometimes people get confused. They switch back to root account and they try to do the testing. I've seen this thing, right? You have to log into the IAM dashboard, IAM users dashboard. And from there, you have to see a list of buckets. You have to access the list of buckets on the users dashboard, not the root accounts dashboard. So you need to access the list of buckets on S3, or I would say S3 buckets on behalf. So basically, on behalf of an IAM user, you have to access this bucket list, right? Now, you need to click on the first bucket, the buckets with which ends with first or ONE, right? Once you go to the first bucket, you will see that on the right hand side there's an option that's called upload. Okay, click on upload and then click on add files. Upload and add files. So for example, I click on add files over here. Okay, now you can choose any file from your computer. Okay, so On the bucket list, you just click on upload, choose add files. Add files. You need to just pick any file from your computer. You need to pick any file from on your computer, right? Go ahead and just upload it. Now automatically the file name shows up that this file you're trying to upload. Fine. You simply scroll down and click on upload. Now there are two ways to upload. Either you just upload it right like this, right? Or you just drag and drop the item. Now you will see that it will show you access denied. It will show you access denied. Fine, because for the first bucket I don't have any permissions. Or what I can do is that I can drag and drop the item like this. I can drag and drop the item to the list and click on upload. Try to upload anything from a machine to the first bucket. Please test it. For the first bucket, the upload was done successfully. Can you verify that? Upload should fail for the first bucket. Make sure that you're not doing that on the root account, because this is a very common scenario that people fall into. Right? Make sure that you log in on behalf of an IAM user. If you see the top right hand side, you will see that it shows you the account ID and the IAM user. So on behalf of the IAM user, if you access the first bucket and try uploading something, it should reject you. Okay, that's what we want to ensure. So if upload is successful, there are two chances. Number one, maybe you're just trying to do that on the root account. Number two, the policy that you configured was not done properly. Okay, what's next? You need to go to the second bucket. You just click on the buckets on the left, on the top, and of course you'll be going back to the bucket list. Click on the second bucket and now try to upload something. I click on upload, and now it will be a success for the second bucket. You can just access the bucket list. If you just click on close right now, you can just click on the buckets on the top and you will be back to the buckets page. So for the second bucket, I was trying, when I tried to upload this simple file, this small file to the bucket, it was a success. Because based on the policy, the user have no access in terms of deleting, or I would say putting something inside the first bucket. But for the second bucket, the user has complete access. Right? Now, just to test it further, you can just click on delete. Right? And if you just try to delete the item or the object from the second bucket, it should be successful. Just try to delete the same object from, just type in permanently delete and click on delete objects. You should be able to delete your object or data from the bucket itself. Okay. So overall, on behalf of this user, you logged in, you try to upload something to the first bucket, you got that, which was expected. You try to perform the same operation for the second bucket, and it went with success. And you were also able to successfully delete the same object that you uploaded before. So this puts our policy into test. We saw its effectiveness, that how we configure the policy and how it can come into effect. Okay, let's discuss the concept of IAM roles. Why exactly we need roles? Because see, the thing is that users, groups, roles, and policies, these are different components of IAM. Purpose of users, groups, and policies. But what is the usage of roles? To perform confined permissions? Okay. Perform confined permissions, all right. One specific access, all right. Who wants to give inputs? See, roles are used for temporary access. That's a good thing. That's what I was looking for, temporary access. But I elaborate this temporary access to ensure that you understand exactly what you mean by temporary access. But that's a good point. We want to give access for specific tasks only. Okay. So we need roles let me just elaborate what the roles are, and I'll discuss with you two benefits of roles. It's because see, the roles can be used for, now for examples, included one answer, temporary access. Basically, the thing is that roles uses something called security token services, which give you temporary access for a specified duration. I'll come to that. And in AWS, we use rules for multiple reasons, but there are two main reasons that we're going to be using rules for. I'll elaborate those two different reasons, give you some examples, and based on one of the examples, we'll do some hands-on so that you clearly understand the relevance of roles. Okay. Roles are required in those cases when you need to engage two resources together and have them communicate to each other. See, right now, or let me just give you one example. We discussed IAM users, right? Who are the IAM users? IAM users are the people. They are the human beings. They are the IT people, the IT and software guys who will be interacting with resources like instances, S3 buckets, right? They will be interacting with resources like S3 buckets, EC2 instances, load balancers, auto scaling. They will do the deployments on daily basis. They will provision those resources, configure them, terminate them when they're not required. So we as the users, we interact with these different services, right? For example, we discussed the concept, we focused on the scenario of an IAM user. As an IAM user, for example, Steve needs to communicate with two buckets. And based on this customized policy, he should get read-only access to bucket 1 and complete access to bucket 2. Right. So as an IAM user, it was his responsibility to communicate with these resources and perform his daily job. And based on whatever permissions I've assigned to him, he will get that access and he can perform those actions. So over here, there's an IAM user who is trying to interact with the AWS resources, which includes my buckets. Okay. Now, what I say that now I don't want to use this user in this case. Okay, user. Okay, let's suppose user is there. Let's imagine user is there. I also want the buckets to communicate. Right now, or the scenario that we saw, user communicated with the buckets. Okay, but I want the bucket, for example, bucket 1 to communicate with bucket 2. I want bucket 1 to communicate with bucket 2. There should be a kind of a communication or synchronization. So in this case, this bucket 1 will need an IAM role so that it can communicate with the second bucket. The main purpose of an IAM role is to initiate resource access. If one bucket wants to communicate with another bucket, if instance wants to communicate with the bucket, this means that in this case, there's no human being involved, right? So in this case, we use the concept of IAM role, right? So the purpose of the IAM role, I'll just list down the functions. I'll give you some examples. Try to understand those examples. And the best part about the IAM roles is that when you start configuring the resources, the roles are configured automatically. Okay, you don't have to create them at every single point of time. But of course, from the exam point of view, from the certification point of view, from the interview point of view, from enhancing your knowledge perspective, it is important that you understand its relevance. Okay, let's understand the concept of IAM role. Okay, so the purpose of the IAM rules, there are two main reasons why we use the rules. One is that it facilitates resource interaction. It facilitates resource interaction. If resource means, for example, the resources or the services that we use in AWS, S3 buckets, load balancers, auto scaling groups, database instances, EC2 instances, whatever the services we are using, these are resources only, right? It facilitates resource interaction. Second thing is that it is also used something called for cross-account access. Now, this is out of the scope of the course, right? But I'll give you the example of it. I'll give you the, we'll discuss, we'll do the hands-on. We'll just do the hands-on on this one, right? This is out of scope of the, because this is very advanced topic, but I'll give you the example of it. We'll not do the hands-on on this one. We'll do the hands-on on the first use case. So I'll give the examples of both of them. Let's come to the first main point. It facilitates resource interaction. So this is a scenario that you need to understand, that how it provides resource to resource interaction. Let's try to understand this. Resource interaction means that in AWS, when there are two resources that need to communicate for any reason, maybe it is synchronization, passing on the data, maybe, for example, giving access to a service to stop another service, or send the logs for that service, or maybe, for example, have that service config changed automatically by the service. In this case, we call it as resource to resource interaction. I'll give you one example over here. The example is, let's imagine I have these end users. These are my customers. These customers, they upload their images. These customers, they upload their images to a web application. For example, you have deployed a Python web application, right, on an EC2 instance. Fine. So the users upload their images to the Python app running upon the instance, and the system is trying to push those images and store them inside an S3 bucket. Now, we already discussed what an S3 bucket is. An S3 bucket is nothing but it is a fundamental container. It's an online backup service which can contain your data, right? So this is, for example, my Amazon. Okay, now I want the instance to put those images to be stored inside this bucket. Okay, so users are trying to upload some images. You must have seen, whenever you try to access a PPT or PDF on Intellipaat website, they are being extracted from the bucket only. Okay, so generally what happens is that the companies, they store the content in these buckets, right? So as a user, you're just uploading some images. For example, you're trying to interact with a social media platform like Instagram or Facebook, something like that, and those images are being stored inside the bucket. Now, for this type of it, so over here there are two resources which are interacting. Okay, and if this has to get the images out of it, download the images, then also the instance needs access. So over here there are two resources communicating. Which are the two resources? This one and this one. All right, now instance is trying to communicate with the bucket so that it has the ability to put or get the images out of it. It has the ability to put or get the images out of it. For this reason, I have to create an IAM role, right? Attach a policy to it. For example, the policy is Amazon S3 full access, right? I attach a policy to it, to the instance. So I attach a policy to, I just link the policy like we link the policy with the users and groups. Similarly, a link or attach a policy with the role, and then attach this role with the instance to the instance. So once I attach a role with a policy which gives complete access to the S3 buckets, the instance will have the complete access to put or get the images from S3 buckets. So over here, who is getting permissions? Is this a user? No, it is the instance which is getting the permissions. If if there's no instance over here, if there's a user, then I could have created an IAM user in this case, right? Because there's no user involved, there's no human being involved or a person involved. This instance is a resource which wants to communicate with another resource, but it's an S3 bucket. For this type of interaction or communication or access, the instance need permissions. And for that, I create a role, attach a policy to it, and then link this role to the instance so that the instance has those permissions to apply some actions or do some actions towards a bucket. Okay, I'll give you another example. Let's imagine this is my bucket in North Virginia. This is my main bucket. Okay, I want that whatever data is being put inside this main bucket, it's being synchronized, or it is replicated, duplicated in a different bucket, which may be in a different region. For example, for the backup purpose, to make my data more redundant, I have another bucket in Mumbai. Okay, I want that the entire data gets synchronized and replicated from main bucket, and this is my secondary bucket. This is my backup bucket. This is only for the backup purpose, backup, or this is a secondary bucket for me. So I want to make sure that I have a copy of the data synced and saved in Mumbai as well. In that case, this main bucket needs to be attached an IAM role. If I don't attach an IAM role to it, I can't have its data synchronized to the second bucket. So in order for my main bucket to sync its data or synchronize its data to the second bucket, to another bucket in a different region, this main bucket also needs certain access. Fine. So what is the moral of the story? What's the crux of this entire conversation? Roles are assigned to the resources so that they can easily communicate with each other and we allow them to have certain level of access, whether it is replication of the data or it is doing some actions, for example, putting the images or getting the images. Fine. I think that this point is clear to you. Okay, so we'll just do a hands-on on this scenario. Fine. Now let's take something called cross-account access. Now cross-account access is out of scope of this course. We'll not do the hands-on this one, okay? Because it's very advanced. It is discussed in SysOps or professional examination, but for the sake of giving the example, because you didn't understand why we use the IAM roles for. In the cross-account access, what we do is that, for example, let's take one example. What do you mean with cross-account access? When you start working for organizations, for large enterprises, which have hundreds of thousands of employees working on AWS, you will find out they will not have only one root account. They will have multiple root accounts. For example, let's take one example over here. Let's imagine there's a company named as SpaceX, right? SpaceX is a esteemed organization which specializes in space exploration. Now, SpaceX says, I will go for 2 root accounts. One root account is for production live servers. So this is my root account. It is purely for production purposes. Okay, this is where, so in the root account, this is where live applications are maintained. This is where live applications are maintained. You're right. Your live servers are running, which are in production. Okay. Then SpaceX says, I have a different root account for development purpose, development and testing. So we call this root account as development. This is a second root account we have. The name of the root account is called development. Now this development root account is kind of a sandbox. Sandbox means that it is used for development and testing of applications. Used for development and testing, right? So for development and testing of new applications, new services, new software releases, it's used. Fine. So SpaceX as an organization has divided its I would say it has adopted a strategy where one root account is for production, where live servers are running, and root account for development is only for development purpose and testing purpose. Right now, under the production, so let me just divide this thing so that there's no confusion. Under the production account, I have a bucket, an Amazon S3 bucket. Now this S3 bucket is used as a code repository. Code repository means that this is where I would say that my application's code is updated, right? So it consists of source bundles or packages, HTML files, CSS files, and if I want to update my application, I need to update my code repository, right? So it's kind of a GitHub or where my my software packages are maintained. I have an IAM user over here under the developer account. So for example, this is an IAM user, right? And this IAM user is my software developer. His name is Steve. I want Steve to get access to this bucket so that he can update the applications, update the code, push the new changes to it. Now, the problem is that this is not allowed by itself. Even though these two accounts are belong to the same organization, which is SpaceX, but these are two different root accounts. From AWS perspective, these are different entities. These are completely different entities. From the Amazon's perspective, these are different accounts, even though they belong to the same organization. That's okay. So this is not allowed by default, right? One root account cannot be straight away start accessing the other root account resources. So in this case, what needs to be done? In this case, there's an IAM role needs to be created. There's an IAM role needs to be created, right? And this person, Steve, would be using this role. Basically, there's a special action which we call it as switch role. If I show you on, okay, it is under the IAM account. Let me show you that. If I log in on behalf of an IAM user, you will see there's an option called switch role. Let me show you that. Okay, so I just go ahead and just paste it. Okay, I'm just trying to log in on behalf of an IAM user. You will see that once I just log in right now, you're gonna see that at the top right hand corner, from where I can log out, there's something called switch role. Can you see that? Switch role. Now, using switch role option, if I have the arrangements already made at the backend, this IAM user can log into a different root account and access some resources. Switch role. Okay, so using this special option that's called switch role, the IAM user will be using this IAM role and then will get access to the S3 bucket. Fine. This IAM role will have some policies with, for example, will have policy signed. For example, the policy is Amazon S3 full access. Okay, and this IAM user will use switch role action, use this role, and hence get access to the S3 packet. Fine. So in order to enable the cross account access, you also need the roles. So there are two main reasons why we use the role. Number one, to enable communication between two different resources, and number two, to allow a different root account user to access your resources. And because this is cross account access, in this case the roles are needed, and a special option is used, switch role, based on which the IAM user can access your resources based on what you have, what access you've given to what access you've attached to that role. So the external user, because this IAM user is an external user now, it's not my account user. That external user can access your resources based upon the role that you've set in for that person to use. What are the policies attached to that role? So if I was attached the policy which is Amazon S3 full access, then the external user should be able to get full access to S3 packets. Okay. Any questions you have? Now at the back end, what happens is roles generate something called tokens. By default, tokens are valid for 1 hour. This doesn't mean that the role is valid for only 1 hour, but at the back end, they generate some tokens. And we call it as a security token service, or STS. So these tokens are generated at the back end. These are temporary tokens which are generated every 1 hour. Now this is the DIY exercise. This means that with minimum support, you can just follow these steps. Now I'll walk you through the steps. They're very easy. I don't think there will be any challenge that we'll be facing in terms of connectivity and accessing or I would say performing this complete hands-on. And also you'll understand the CLI part of AWS. So right now we are trying to access or communicate with resources using this graphical user interface. Fine, this web page. But we'll also see the command line interface version of AWS as well. So using CLI, we can also interact with the resources. So this will also touch upon the CLI part of AWS. Okay, so if you go by the document, this is what the document is. I'm going to just copy and paste its contents one more time, just in case if you missed it before. So the very first step that it says that create an IAM role so that the EC2 can get full access to S3 packets. Okay, so in this case, I'll show you the process how to create an IAM role. It is quite easy. I'll be a bit slow in terms of showing you this step, and you have to follow along with me. So as I show you and explain you have to do the steps at the same time. Okay, because you don't have the screenshot space document to follow along. Now I create these DIY exercise so that you're being pushed to perform the steps by yourself without the help of any document. Okay, because ultimately you have to start executing these steps without any help or with least help. So in this case, you have to understand that how you need to navigate to different services and start applying those different concepts that are important. All right. Now, having said that, I just go back to my browser, and you have to go to the IAM first, right? So you have to navigate to IAM. Now, this page we have accessed multiple times before. You have to go to IAM, and under IAM, you have to search for roles. Now, if you just go and just look for it, you can easily find it out. If you, for example, just go and see over here, under IAM resources, where you access all the resources, you have a separate section for roles, or you can find roles on the left-hand side. Okay, you have to go to IAM, and then you have to navigate to roles page. Click on the roles. You have to navigate to roles page. Go to IAM. Go to roles. Be you trying to log in on behalf of an IAM user. Okay, so you have to log in as a root user. So just keep an eye on the right-hand side. Make sure that it only shows your root account ID. If it's showing you an IAM user, you have to sign out and log in on behalf of a root user as you were signing in before. Guys, you have to go to IAM dashboard, and then you have to switch to roles. Go to roles. Once you go to IAM dashboard, go to roles. What's next? Once you go to roles, right now, you will see that you sometimes you will have some roles created automatically, because whenever you configure some of the resources, some roles are created automatically without even you noticing that. But that's not what exactly you need to see. Hang on 1 second, I missed to read this rule. What you have to do is that you have to create a new role from beginning so that the instance can access the buckets. Now we are trying to apply the first principle or the first example that I showed you. And the example that I showed you is where the instance should have access to access the S2 buckets. This example we try to apply. Now, if you just go to this instance this roles dashboard, I'm sorry, and you can see that an IAM role is an entity identity that you create and has specific permissions with conditions that are valid for short durations. Now, this is a temporary access. Doesn't mean that it only works for some time, but at the back end, it generates some tokens which are valid for an hour by default. Now you can just click on create role, and you'll come to this this page which says selected trusted entity, right? Make sure that you choose AWS service, which is selected by default. Okay, because we are trying to have the services or resources communicate. And under the use case, you have to make sure that you select EC2, this one. Okay, so go ahead, click on create role. And once you click on create role, make sure that the trusted entity type that you have selected is AWS service, and the use case that you've selected is EC2. Please make these two selections. Let me know what's wrong with this. Now, this role is created so that the EC2 instances can have access towards the S2 packets. Please perform these two. Please make these two selections. Let me know what's wrong with this. Done. We're done with this. So we have selected the trusted entity type as AWS service, and the use case that we're selecting is the EC2. So because we want this role to be created for the EC2 service, so that the instances can access these two buckets. Now, once we do that, we click on next. Now we have the list of policies. The policy that we are looking for is S3 full access. Just type in S3 FULL. Press enter, and you have to select Amazon S3 full access. Please go ahead and do that. So to this role that we're going to create right now, the policy that we need to select is Amazon S3 full access. Please make the selection. Okay, what's next? You just go ahead and click on next. Okay. Then it will ask you for the role name. What's the name of the role? So basically, you can just put in any role name, put any name. Even if you put your first name, that's okay. Enter any role name that you can remember afterwards. It's a simple, because let's suppose I've put the role name as Amazon EC2 S3 Access IAM role. You can put any role name over there. Just go ahead and do that. Enter any randomly, just assign any name to it. Please do that. Enter any meaningful name. Now, once you are done with this assigning this name, there's a description. You don't have to change the description. Now, you will see that it says trusted entities. Now, basically, if you see, it says effect allow action STS assume role. Now, STS stands for security token service. At the back end, this role will generate some tokens which expire after some time, but these tokens are generated so that the instances can use those tokens to access these services. And the service is ec2.amazonaws.com. So it will generate this. It will use the concept of security token service, or STS, to generate some temporary credentials or tokens for my EC2 service. And if I scroll down, it says that what is the policy that attached to this role? Amazon S3 full access that we selected in the previous step. You don't have to change any one of these entities. On this page, the main thing that you have to change is assign the role name. Don't change the description. The selected trusted entities is the same, because it says that this is being created for the EC2 service. So the tokens, the temporary credentials will be generated for EC2 service. And EC2 service will get the complete access to my S3 service. Click on create role and your role gets created. Please go ahead and do that. After you name the role, you just have to just scroll down, just see the information, just for the sake of just going through the information, see that and just understand what exactly the information means. Go ahead and click on create role. Your role gets created. Please go ahead and do that. So once the role gets created, we'll just do the next step. That is launching the instance. So this role has to apply to the instance at the time of launching the instance. Okay, this role will not automatically apply to all the instances. When you deploy the instance, you have to explicitly or exclusively apply that role to it. In the next step, we'll deploy the instance and apply the role, log into the instance and test it. So the next step is that we have to launch an instance with all the basic settings. And the only thing that we have to do is that we have to include the advanced details, which is selected as the IAM instance profile, which is an IAM role. Okay. So what you're supposed to do, you have to switch back to your IAM account. You have to stay on the root account, right? So this entire process has to be done in the root account only. So within the root account, I just switch to EC2 dashboard. Just do that. Okay. Once I go to the EC2 dashboard, I go to launch instance, click on launch instance one more time. Right. And I assign a name or a tag to the instance. Fine. So in this case, what I will do next is that I will just go ahead and assign a name to this instance. In terms of application and OS images, I don't have to change it. Keep it as it is as Amazon Linux AMI 2023 AMI, right? So default AMI, default instance type, but it's T2.micro, right? So there's no need to change it. Under the key pair, you can create a new key pair or select any of the existing one. Okay. So for example, I can click on create new key pair, and I just type in, for example, IAM role demo -kp. Okay. I just put a simple key pair name and click on create key pair. Okay. As if now perform these three actions only. Initiate launching the instance. Fine. You have to initiate launching the instance, go with the default AMI, default instance type, and create a new key pair. I would advise to create a new key pair. Sometimes we tend to delete the private keys from our computer. So please go ahead and do that. You have to launch instance, initiating launching instance using default AMI, default instance type, and create a new key pair. When you initiate launching the instance, make sure that the AMI is Amazon Linux 2023 AMI. Okay, it's a default one. We don't have to change it. When we go with the instance type, it is T2.micro. We don't have to change it. Keep it as it is. Under key pair login, you have to click on create new key pair. Okay. You don't have to change any of the details. For example, I click on create new key pair, enter a name, simple enter a name, and click on create key pair. You don't have to change the RSA, or I would say the key pair type or private key file format. Don't change any one of the things. Simply assign a key pair name and click on create key pair. Fine. So you don't have to change the key pair type. Keep it as it is as RSA, right? Don't change anything over there. I would say don't change anything in the options below. Enter the name of the key and straight away click on create key pair. Please do that. Let me know it's done. Okay, what's next? Once you click on create key pair, right? So it will download the key. Then under the network settings, you check all the boxes. Basically, it says that allow SSL and HTTP from anywhere. If you want, you can check all the boxes. Please go ahead and check all the boxes under this thing, security group. Please make sure that you don't change the source. Don't change it. Just tick all the three boxes, right? The three ticks. 1, 2, and 3. Allow SSH, HTTP, and HTTPS from all the sources. Please go ahead and do that. What's next? Let's do the next thing. If you scroll down, there's something called advanced details. If you remember, under the advanced details, we go to user data and paste a script. If you remember, right? Now you have to go to advanced details, right? Expand it. And under advanced details, you have to look for a third option, which is the IAM instance profile. Okay, the IAM instance profile is nothing but it's a role assigned to the instance. It's a role that assigned to the instance. So under the IAM instance profile, you have to look for the role that you created and applied, so that this instance gets the permissions to access the buckets based on this role attached to it. Please go ahead and do that. So under the advanced details, you will see that you have the third option out there, which you have to look for, which is the IAM instance profile, and apply the, so in the drop-down menu, select the role. And once you assign the role, straight away click on launch instance. Once you assign the role, straight away click on launch instance. Go ahead and do that. Let me know what's done. Once you apply the role, please go straight away and assign the once you assign the role, after you assign the role, go straight and click on launch instance. Instance launched. Fine, simple. So what we have done, what new thing we have seen? We have seen that how to apply the role to the instance. Let's wait for a few seconds, and we'll just connect to the instance. Let's wait for a few seconds over here. Let's just type in done. Once you're done. Now, what's the next thing? The next thing is that you have to connect to the instance via SSH. So over here, if I take you back to this thing, it says that step number 3, connect to the instance via SSH. You have to connect to the instance. Now, how you go about doing that? You select the instance as it is, right? You go ahead and make a selection, right? So basically, this is the browser-based shell prompt that we use. We can use PuTTY as well if you are comfortable using PuTTY. You can use terminal as well if you're comfortable using terminal. So in this case, we'll be using the browser-based shell prompt. We have to select the instance. There's a check mark, select the instance. On the top, there's an option that's called connect. Click on connect, and you will see that it says EC2 Instances connect to EC2 Instances connect, right? You have to straight away click on connect over here, and we'll be invoking the browser-based shell prompt to connect to the instance. Please go ahead and connect to the instance. Step notes done. Okay, connected. All right. What's next? The next thing that you're supposed to do is you need to run the following command to list the buckets. I'm sorry. Run the following. Okay, what's the next thing? The next thing is that you have to run this command to list the bucket. See, the thing is that we have used the Amazon Linux AMI as an AMI to deploy the instance. This Amazon Linux AMI already has the CLI package installed. CLI stands for command line interface. Now you can run the commands from the instance to list your buckets. Now, these commands start from AWS. Then give a space. Then you type the name of the service, which is S3. Give a space. And what action you want to perform? I'll just type in LS. LS stands for listing. AWS S3 LS. This will show me a list of buckets in my account. Press enter, and you'll be seeing a list of buckets. Please go ahead and do that. Run the command to list buckets right now. So once you log into your instances shell prompt, or you log into the instance by SSH, just type in AWS space S3 space LS. Press enter. You'll see a list of buckets in front of you. If you don't see the list of buckets, this means that you must have removed the buckets in your account. That could be the reason. Fine. Please go ahead and do that. it will show you a list of buckets that you have created. See, whatever it is showing you, it will show you the list of buckets. Whatever the Ritesh, you must have removed the buckets. That could be the reason. The next thing is that you have to enter a bucket name. I would say you have to run this command to create a bucket. Okay. So in this case, you have to enter this command AWS space S3 space MB. MB stands for make bucket. What was the previous command we typed in? AWS S3 LS. LS will list the buckets. LS stands for listing. LS stands for LS is for listing, right? MB stands for MB. It is make bucket. Make my bucket. So this is to create a bucket. So AWS S3 MB space. You have to enter the bucket name. To enter the bucket name, just type in S3 colon 2/. Okay, just type this portion of the command right now. Type this portion of the command. AWS S3 MB space S3 colon 2/. Type this portion of the command right now. Let me also down. Now you have to think of a unique bucket name. Unique means we discussed that no two buckets can have the same name. For example, just type in Rohan Intel IAM role S3 bucket, right? Something like that. You have to think of a unique name. Now, for example, you can just type in your, for example, I give sometimes, okay, so just type in your first name, for example, right? First name hyphen IAM role hyphen S3 bucket. Now this will be unique. This will not clash with my name, with my bucket name, because your first name is different from mine, and you can just use this kind of bucket name. Press enter, and it says make bucket. The bucket is created. Please go ahead and do that. You have just executed the command to create a bucket from the instances shell prompt using the CLI commands. Are we done with this? I'm not able to put commands. Or you can just type in AWS space help. For example, let's type in AWS S3 help. Okay, so for example, you want to see the list of commands for the S3 bucket. Just type in AWS S3 help. I can see all the commands for the S3 bucket. For example, you can see that CP for copy, MV for moving, RM for removing, right? So I can see the list of commands. For example, sync, make bucket, MB, remove bucket, RB, LS for listing, and for every single thing, they have given the documentation, right? You would see that there will be documentation available for all of them, right? You can see that synopsis, options, available commands, and for the available commands, they will give you the complete description. For example, let's press Control Z. For example, AWS S3 LS, or let's suppose MB help. So I can see exactly that what this MB means. Fine, if I've seen the MB command, MB creates an S3 bucket, synopsis MB. What are the arguments that I need to pass, and what's the format of the command? So this is where I can see all the documentation. Fine. Okay, you can see that this is the example they've used. All right. Now, what's the next thing? Now you have just created the bucket right now. You have just created the bucket. Now to extract the list of buckets again, just type in AWS space S3 space LS. Now you'll be able to find the same bucket that you have just created. Now I have a list of a lot of buckets. Just type in AWS S3 LS. I'll run a grep command too, because I have more than 30 buckets right now. Rohan Intel. Yeah, you can see that this is the bucket that I've just created. Now let's reverse this entire thing. The next thing that we'll do is that we will remove this role from instance. I've listed down the steps that you have to do. You have to remove the role from instance now. How to remove the role? I'll show you. Go back to instance dashboard, right? Go back to the instance dashboard, right? Once you go back to the instance dashboard, look for the instance that you have launched. Okay, please go back to instance dashboard, select the instance that you're working on. Please go ahead and do that. I'll go a little bit slow. Go back to instance dashboard and select the instance that you're working on. Choose it. Just type in done. Once you have done this thing, go back to the instance dashboard and select the instance that you're right now working on. Right, you have to switch back to the instance dashboard. Check or select the instance that you're still working on, that we have already connected to. Now you have to go to actions on the top, right? Once you go to actions, you have to go to security under actions, and you have to look for modify, and you have to click on modify IAM role. After select the instance, go to actions, then go to security, and under security you have to click on modify IAM role. Select the instance, actions, security, modify IAM role. Now, once you click on modify IAM role, right, it will show you the role. You have to choose no IAM role and click, right, choose no IAM role, click on update IAM role, and this confirm detach and press detach. I've already listed down the steps. You have to detach it. Choose no IAM role, choose update and detach. Just type it done once you've done this thing. Yeah, okay. Basically, once you go to actions, security, modify IAM role, and you choose no IAM role, click on update, right? So basically, there's an you have to type in detach in the box. Once you click on detach, then the detach becomes enabled. Let me show that one more time. I choose it, go to actions, security, modify IAM role, choose no IAM role, and click on update. Now, detach is disabled. It says to confirm detachment, enter detach in the field. Just type in detach. Once it is typed in detach, the detach option gets highlighted, and I click on detach. Okay. Are we all done with this? Okay. Now, as a challenge, you have to go back to the shell prompt and try listing the buckets now. As a challenge, if you're already connected to the browser-based shell prompt, that's okay. Or you can reconnect and try listing the buckets and let me know what you're getting in return now. You have to go back to the shell prompt or reconnect to the instance. Go ahead and try listing the buckets. Basically, the thing is that when you remove the role from the instance has lost the ability or the credentials or the authority or the access to access S3 buckets. When the instance has a role attached to it, it has all the privileges. You were able to, from the instance shell prompt, you were able to create the buckets, make the buckets, I would say list the buckets. But once you remove the role, after you remove the role, the instance has lost the access. It has lost the privilege. Now, if you want to test it further, if you connect the role again, the instance will be able to perform the same actions. But the moral of the story is, the crux of the entire conversation is that once the role is removed, the instance loses access, right? So the role is used in this case so that the instance has the privilege or the authority to access the buckets. But once you remove that role from the instance loses the access. Is this clear to you now? Fine. Now, if you want to test it further, for example, if you want, now this is optional, I'm not pressing you to do it. If you go to the same option and attach the role again, right? If you go to the same option and you and you try to attach the role again. For example, I go to my instances, select it, select the instance, actions, security, modify IAM role. I choose the same IAM role, click on update, right? I have this updated right now. Now I list the buckets. It's working now. Once you attach the role, you get the same access back. Yes, that's what's kept under security. Fine, that's it. There's only one thing we left out is multi-factor authentication. What do you mean by multi-factor authentication? What exactly it's meant by? What do you mean by that? And what's the purpose of it? Why we use the multi-factor authentication as one of the methods to authenticate? Now you must have seen this thing that nowadays we are going towards two-factor authentication. What do you mean by two-factor authentication? Whenever you make any banking transactions or you sign into any of your accounts, you know you're being presented with an OTP and one-time password. So that one-time password ensures that even if you, for example, you have signed into any of your applications, or you just trying to make any banking transaction by going to a banking website, or to complete a transaction, you have to punch in the OTP, right? One-time password. So why you have to why this two-factor authentication is becoming very popular, or it's very ubiquitous? The reason being because it enhances security. It becomes nowadays, because of the sophisticated tools and a lot of things that are going on, it becomes your passwords can be very easily compromised, right? Passwords can be compromised, username and passwords can be easily stolen, can be compromised. But OTP is a kind of thing which cannot be guessed beforehand, because any OTP that's generated is valid for a few minutes. And if you sign into the same application again, let's suppose after 24 hours, you have to make use of a new OTP, right? So the one-time password, apart from putting in the ID and password to make any online transactions, banking transactions, or log into any of your accounts, ensure that you have the double the amount of security that you have. Now, this OTP type of authentication has been used in businesses from past more than a decade. If you remember, I'm not sure if you have seen this thing. There's something called Gemalto key fob or RSA key. This is a key that you must have seen that some businesses still use, even though it is now kind of becoming obsolete. These are the keys that people carry with them, especially the people who work in IT and software departments or teams. These are the cards or keys that are given to them. Secure ID key. These are the keys that are given to them, right? So now again, they are kind of becoming obsolete now. They're not being used so much with the advent of advanced technologies. So these keys we were used to use before. The cards, these keys and cards used to generate a pin every 30 seconds. And we used to use these pins generated by these keys or these secure ID cards, so that every time we sign in to our business applications, we use a new pin. It's kind of OTP. These secure ID cards or these keys used to generate the pins every 30 seconds. So if we're working for banking clients or for security applications, these keys were used. This key is called Gemalto key fob. The technical, I would say that the exact, we call it as RSA key for the sake of convenience, but it's called Gemalto key fob. So this Gemalto key fob is a secure ID token which generates a pin every 30 seconds, so that you can sign in security to your application, right? Now, AWS has given you the same type of capability. You can buy these tokens and you can link it with your IAM accounts or root accounts. I think the cost of one unit is 15 to 20 US dollars. And what happens is that either you can buy these keys and link with your accounts. So what do you mean by buying these keys and linking with the account? The reason, or I would say, what I want to say is that whenever you want to log into any of your account, whether it's a root account or it's an IAM account, IAM user account, you can sync these keys with your sign-ins. So every time you sign in by punching in your user ID and password, you also have to put in the PIN generated by these keys. Okay. Amazon has come up with another option with you for you. Apart from using these keys, which is still the viable option and or available option, you can also make use of your smartphones or any of your mobile devices, your iPads, your tablets, your smartphones. Install the app upon them, and those apps can generate these keys randomly every 30 seconds, right? That concept is called multi-factor authentication, or MFA. Okay, for example, let me show you a simple setup. I just go to IAM right now, and I just go to the users list, right? Now I have 3 users, Chris, Steve. Now to enable the IAM, it's a one-time procedure. One thing, yeah. So we have authenticator apps like Microsoft Authenticator, Duo, Google Authenticator. So there are a lot of authenticator apps which are available for free on the App Store or the Play Store. You can buy them. I think you don't have to buy them. I would say that just subscribe for them and download them. So there's no need to buy anything. These are free software. There are also some options to purchase, but I think the options that are available as for free, they are the best options because Google Authenticator, Microsoft Authenticator are widely used. So let me just show you that. Okay, now I'll show you this thing. For example, let's imagine. Let's suppose this is this iPad that I have with me. This belongs to this user named as Chris, right? So basically, the thing is that the devices has to be owned, or I would say it should be in the physical custody of users every time, right? So if Chris wants to sign in to his AWS account, every time he will be having the device with him, and the Authenticator app installed on his device will generate a PIN based on which he will sign in. Okay, so let's imagine that this iPad belongs to this user, Chris. And Chris says, okay, I want please enable or please make this device, this iPad, as the MFA device. Okay, this iPad is the MFA device for Chris. So I need to perform activation. It's a one-time process. Chris and just fetch the details of his account. And you will see that I have permissions, groups, tags, security credentials. So I have a bunch of options out there. I go to security credentials right now. Okay, once I go to security credentials, you will see that under this console sign in, there's a multi-factor authentication. Now you don't have to do this hands-on right now. So it says assign MFA device. For any user, I can link up to maximum 8 MFA devices. So I click on assign MFA device. Now it says, are you using an authenticator app, a token, a key? What are you using? Now the keys and TOTP token are the same thing, which you can buy from. I'm talking about these RSA keys, right? These RSA keys can be purchased. These are the secure ID tokens you can buy from them. So I'm not using any one of these options out there. Instead, I'm using Authenticator app installed on user's iPad, and name it as, for example, Chris iPad. This is the device name, iPad Pro, or so this is the device name that I put in, and I select the MF device as the Authenticator app. Because I'm using Authenticator app, this is called virtual MFA, virtual multi-factor authentication, right? So once I put a device name, I use Authenticator app as my accepted method for enabling MFA. I click on next. Okay, it says install a compatible app such as Google Authenticator, Duo Mobile, or Authy app. See a list of compatible applications. So it's showing me the step-by-step process. So the very first step is that I have to install an Authenticator app on user's device. So we go back to the user's device. I can just go to the App Store. Now, of course, if you're using Android, it would be the Play Store that you can be using. So I go to the App Store, and I can find a bunch of options out there which are free and paid both, but free are absolutely acceptable. They can be used. They have all the features. So you don't have to purchase any authenticator software. So if I go for Authenticator, I look for Authenticator right now. Yeah. So you can see that we have Microsoft Authenticator on the right-hand side. This one. This is also free of cost, widely used. The one that I'm using is Google Authenticator. It is free of cost and widely used. So you can use any one of these two options. You have also Authenticator app, this one as well. This is also, I've seen people use them a lot to authenticate with some other applications. But for business point of view, Microsoft Authenticator and Google Authenticator are used a lot. So personally, I'm using Google Authenticator. So imagine that this device belongs to a user. I installed Google Authenticator app upon this device, and it says add code. I click on add code. Now I'll be clicking on the first option which says scan a QR code, right? So which QR code is asking to scan? I go to the second option and click on show QR code. So using the device's camera, I should be scanning this QR code. So just go, I click on this scan QR code. It opens my camera. I just go ahead and scan this code, right? Now, once I scan this QR code, it automatically detects that this account belongs to this user, Chris. You can see that, right? So it says Amazon Web Services, Chris iPad @ root account ID. Now, this is the pin, a 6-digit pin, which changes every 30 seconds. You will see that there's a timer which is ticking in the right-hand side. So after this timer expires, a new pin generates. Now I need 2 pins to complete activation. 2 pins are required to complete the activation. So in this case, I make a note of the first pin, 988629. 988629. Okay. So I'll be waiting for the next pin to show up. 881950. Okay, 881950. 881950. Okay. I click on add MFA, and this is being done. Now you will see that under the multi-factor authentication, this virtual MFA device is being added. This is being done, right? So now this user, Chris, can use this device as the MFA device. Okay, so the next time he signs in, what's the process he will follow? Let me just show you that how he will sign in, or how he should sign in. So I just open a different browser, and I log in on behalf of this user and show exactly that what he needs to do. So you will see that the details like the username and the password is still punched in. So using the username and password, this user will click on sign in. Now immediately it will ask for the MFA code. So this user will just go ahead and open Google Authenticator and see that what's the new pin he's getting right now. It's 738047. 738047. He clicks on submit, and you will see that he's able to sign in securely. If the pin is incorrect, he'll be blocked, or I would say he'll be asked to put a new pin, right? So this adding the MFA code or these pins to be punched in will ensure that every time the person signs in, uses a new pin, because if someone if the ID and passwords have been compromised, at least these pins are still I would say the devices with the user, these pins are randomly generated. So it's very hard for anyone. I would say it is kind of impossible for anyone to guess these pins. It's kind of OTPs generated on your cell phones, or the OTP is generated because OTP is valid for only a few seconds or few minutes, beyond which they expire, and you have to use a new pin every time. So this increases the level of security of your accounts. Now, why you have to increase your account security? Because one thing you need to understand, it's not only the account you're signing in. This is holding your complete infrastructure. This is your door, the window to your complete infrastructure. If someone gets the unauthorized access to your account, it can be catastrophic. The person can stop the servers, steal your data from databases, or I would say completely dismantle your infrastructure. It is important that you understand the relevance of IAM. It's a security type of service. So IAM also comes under the security category, and enabling multi-factor authentication on the accounts ensure that in case of events, if your passwords get compromised or stolen, then you are not leaving any chance or room for your accounts to be accessed by unauthorized users. Okay, this is what exactly the process is. Now I showed you how to do that on the IAM account. Now, based on the best practices, even the root account owner should be enabling the multi-factor authentication. So if I go to the dashboard, you will see that it says add MFA for root user. There's an option over here on the top. I click on add MFA, and as a root user, I can also enable the MFA for my own account. I can just click on assign MFA, and then I can just follow the same process. Based on the best practices being laid down by Amazon Web Services, the root account owner must have the MFA enabled, because root account has the highest access. If the root account is compromised, it can lead to disaster, right? So in this case, root account must have the MFA enabled. Of course, if you also enable this feature on IAM users, it would be an added bonus. Having said that, this is what exactly the MFA is. Now, as a homework, you can just try this thing on your own. You can use your smart devices, your Android phone, your iPhone, your iPads or tablets, whatever you have, and just try it by yourself. It's a very simple process. Okay. All right. Now let's discuss the next topic. Okay, let's get started with S3 now. Okay, so storage classes are being purpose-built to provide the lowest storage cost for different access patterns and virtually any use case. And it includes those with demanding performance needs, data residency requirements, unknown or changing access patterns, or archival storage. It is selected based on the data access, resiliency, and cost requirements. Because see, the thing is that the cost of your data changes based on what's the storage class you have chosen for your data storage. Let's go with the first storage class. That's called standard. Now, standard is a default storage class which is by default used. When you start storing your data, by default, we go with the standard. Now, standard gives you the highest durability, highest availability, faster access to data. This gives you the highest performance, but this is the costliest of the entire fleet of storage classes. So standard storage class is basically, it offers you high durability, availability, and performance object storage for frequently accessed data, delivers low latency and throughput, appropriate for a wide variety of use cases. So basically, standard will put the data in all the availability zones at the backend. If you go with the standard storage, it will store the data in all the availability zones behind the scenes. So when you, for example, you store the bucket in North Virginia, maybe you store the bucket in, for example, in Singapore, wherever you want to store the data, you will see that the data will be stored in, the data can be stored in all the availability zones at the backend. So standard will use all the availability zones to store your data into. So it delivers low latency and throughput and appropriate for a wide variety of use cases, right? And if I say it delivers low latency and throughput, you can get faster access to data. High durability, high availability, which means that your data is being striped across all the availability zones. Hence, your data is highly durable and available, or it is more redundant in nature. It is used for the cases, for example, cloud applications, dynamic websites, content distribution, mobile applications, gaming applications, and big data analytics. So if your data is very critical, you want to make it more redundant, and you want a faster delivery of the data. You want that data should be accessed very fastly, right? Faster delivery of the data, and the data is very critical for you, and you have to create multiple copies and store in all the availability zones. In that case, you make use of standard as the preferred storage class. What's the next option we have? So, okay, so what are the key features? It has low latency and high throughput performance. It gives you high durability across all the availability zones. Now it is 99.99999. It is 11 nines of the durability. So basically, it stripes the data and puts the data in all the availability zones at the backend, which means that if one of the ACs goes down, your data will still be available to you. It gives you high availability. It encrypts your data. Lifecycle management we'll discuss afterwards. We can also put the object into a lifecycle and get it deleted after some time. Key thing to note is, what are the key points to note? Standard is a default storage. which gives you the highest amount of durability because your data is stored across all the areas of the backend, all the variability zones. You get a very faster delivery or faster access to your data. So this gives you, but this is costliest. And these are the use cases. Fine. So if you don't have any budget issues, you want the fastest performance or the best performance in terms of making your data more redundant because the data will be stored in all the areas at the backend, and you want very fast access to your data, then you go with the standard. Okay. Now, one thing, standards also is used for those cases when the data is frequently accessed. Frequent access means that once in a day or once in 2 days, you access that data. Frequently accessed data. How frequently or infrequently? How often you access the data? So if you access the data very often, then you go with standard. Now, if you don't access the data very often and you want to bring down the cost of the storage, then you make use of standard IA. IA stands for infrequent access. It is standard version of infrequently accessed data, which means that any data that you don't access often and you want to bring down its cost. So it is basically an ideal for the data that's accessed less frequently. Any data that you don't access very often, very frequently, you just store that as standard IA. Required rapid access to the data whenever required. It offers high durability, high throughput, low latency. There's a low per GB storage cost and per GB retrieval charge. See, per GB storage price is so in terms of storage cost, it is cheaper. In terms of storage cost, this is cheap. However, if you retrieve the data, if you download the data from the bucket, then there's a per GB retrieval charge. That's why it's used for it's called infrequent access storage. It is used in those cases when you don't you want to bring down the storage cost. You don't access data very frequently, but if you access that data, there will be per GB retrieval charge. I'm saying if you don't access the data very frequently, means that you access the data once in 30 days. Once in 30 days, right? So if you access the data once in 30 days, if that's a frequency, then you go with the standard IA. So it's ideal for long-term storage backups and as a data store for disaster recovery files. So disaster recovery files are not accessed very frequently. You'll not be accessing your disaster recovery files quite often. So in those cases, you can go with the standard IA. Okay. Key features, you get the same low latency, high throughput performance of standard. Your data is highly durable, put across all the variability zones, and high availability, right? So yeah, the key features are saying it's only the storage cost is a bit less. Okay. Now let's imagine that you're confused between standard IA and standard. See, standard IA is used for those cases or for that data which you don't access very often, whereas standard is for that data which you access quite often, very often, once in a day, once in 2 days or 3 days. If the frequency of the data is very high, you put it as standard. But if the frequency of data is low, if you don't access the data very frequently, you go with standard IA. Now you're confused right now that which one of the two I shall be going with, because sometimes you don't have any insight that which data you'll be using very frequently or which data which should not be using very frequently, right? So you have unknown or changing retrieval patterns, access patterns. So in that case, you go with the third option, which is called intelligent tiering. It automates your object based on the frequency of access or how often you access the data. It will put your data into different categories and automatically bring down the storage cost. Let's discuss it. It automatically moves objects between optimal access tiers. It optimizes storage cost based on access patterns, and it's used for data lakes and applications with changing and unknown access patterns, right? So this is the cycle that goes through. For example, today on day 0, you put the data and the data will be stored in the form of frequent access tier. Now, what's a frequent access tier? Frequent access tier means that the data will be stored very frequently, which is the costliest. Now, if you don't touch or you don't access or you don't open that data or download the data for 30 days, there's no access to the data. It's lying in the bucket for 30 days straight. If you don't even just pull the data out, you get the data, retrieve or download the data, meaning you don't access the data for 30 days.
it's put into a cheaper storage category that's called infrequent access tier, which is 40% cheaper in terms of storage cost. Now let's imagine that for 90 days straight, you don't access the data. For 90 days, for 3 months, the data is lying in the bucket. It is unused, unaccessed. In that case, it will put to the archive instant access tier and save up to 68% of your storage cost. Now for 180 days, for 6 months continuously, there was no access to the data. The data is still lying over there. In that case, it would move to the deep archive access tier and save it up to 95% off on your storage cost. So based on the frequency of access, if you don't access the data very frequently, or you don't access the data very, very often, then that case, it will put the in a cycle, and eventually gradually it will bring down the cost of the storage. Now, there's a very common question people ask me, what if I open the data in between? Let's suppose the data is lying there in the form of archive instant access tier. It is still lying over there, and I open that data, retrieve the data. What happens? If you retrieve the data, you access the data in between, when the data is still going through this complete cycle, it's in between, it's staying, let's suppose, in the form of archive instant access tier category. Any data, if you try to pull it from in between this life cycle, then the data is put in the frequent access tier again, and the cycle repeats itself. So during this life cycle, during this complete transitioning, if the data is lying in any of these different access tiers, and you retrieve the data from there, the data is the cycle restarts. The data is restored in the form of frequent access tier, and then the cycle repeats itself again. This is called intelligent tiering. There's a small automation cost imposed upon you, very small negligible fee, but eventually it will bring down the storage cost. One thing you need to understand, even though S3 is a cheaper storage compared to on-premises, it's not that much cheap, right? From business point of view, you have to be very cautious in terms of using S3, because you never know when your storage consumption goes very high in a given month, and the bill goes to thousands. So in this case, from business point of view, you have to make sure that your storage cost is up to the mark where your company can afford it. Because if you don't have a control upon storing your data and managing your data properly, the storage cost can go exponentially very high. So S3 is not a cheaper storage. In terms of it's not dirt cheap. It's not that it's disposable cheap. Of course, compared to the on-premises infrastructure deployments, it's cheaper, but you can't say that it's in pennies, because for the amount of data that you consume, your storage cost can go very high. So these type of strategies that we use eventually bring down the cost of our storage. You'll see a lot of questions in the interviews in these certification exams from these storage classes. You'll be given some scenarios. Based on the scenarios, you have to predetermine, or you have to judge that which is the best and the best suited storage class. Okay, let's go to the next step. Okay, one thing, the infrequent access storage class doesn't accept any object less than 128 kilobytes. If you put any data less than 128 kilobytes, it will be stay in the frequent access tier, right? Which means that if any object is less than 128 kilobytes, it will stay in this category, frequent access tier. Any object less than 128 kilobytes in size will never go through the cycle. You'll be built based on the frequent access tier. Okay. Then we have something called one zone IA. What is one zone IA? One zone IA means that you store the data in just one availability zone. This is a cheaper version of standard IA. So if you have any data requirements where your data is not accessed very frequently, but you're tight on budget, then you can store the data in one zone IA, where the data is stored in just one single availability zone. Comparatively to standard IA, it's 20% cheaper. It is ideal for those customers who are looking for a lower cost option for infrequent access data. So behind the scenes, Amazon Web Services will pick only one availability zone and store your data over there. Okay. So the number of copies being generated and saved across all the AZs, they eventually will cut it down to just one AZ. They will save the storage cost and they will pass on that benefit to you. So if you're going for a storage option which is quite cheap, and you don't access data very frequently, you just go with the one zone IA. It's a lower cost storage option for infrequent access data because the data is stored in just a single AZ. Now, there's an issue. If that AZ goes down, your data is lost. So it doesn't guarantee you a high amount of data durability or redundancy. Fine. What are the use case? It's used for storing secondary backup copies of the on-premises data, or easily recreatable data with that can be reproduced, or maybe replicated data. So if you're using the data for secondary backup as a second, it's a secondary backup for you. You have multiple copies of the data, and in that case, if you, for example, lose that data, that's okay. You're not going for a very high amount of data durability or availability or redundancy. So you want to bring down the cost of the storage, and you want to make sure that you're not looking for a very high amount of data redundancy. In that case, you make use of one zone IA. Fine. Let's go with the next level, archive. What do you mean by archive? Now, the three classes I'm going to discuss with you, they come under archival storage. Archival storage is that storage, or it's that option in which you put the data that you don't access for months or even years. So if you have a long-term data retention plan for months or years to come, then you go for archival options. The three archive storage classes we have: S3 Glacier State Retrieval, S3 Glacier Flexible Retrieval, and S3 Deep Archive. Right, these are the three archival storage classes. Let's start with the Glacier Instant Retrieval. Whenever you think of archiving the data for long-term retention of the data, think of Glacier, S3 Glacier. S3 Glacier Instant Retrieval is used in those cases when your data needs to be archived, but you want immediate access to it whenever it's required. Okay, so it's designed for really access long-term data that requires immediate retrieval, save up to 68% of the storage cost compared to infrequent access storage class. It's ideal for long-term digital preservation of the data that's accessed once per quarter. Once in 3 months, if you access that data, you can store that in Glacier Instant Retrieval, which is very cheap. Okay. Now, one thing, it's designed for that data which is really access long-term data, but it needs immediate retrieval when there's a need that arises. For example, medical images, news media assets, genomics data. Let's take the example of medical images. Let's imagine there's a hospital. Now the hospital has a complete database where they stored their patients' medical history. For example, CT scans, MRI scans, blood tests, and they have to keep the patient history because let's suppose a patient comes to them after a few months, and the patient needs immediate assistance. Maybe there's an emergency. So the previous history of the patient has to be retrieved very faster, right? The patient can come after 1 year or 2 years, maybe after a few months. You never know. And if the patient is coming back with certain issues, and the doctors have to retrieve certain history, the past history from the hospital's database, they need immediate access. The data is archived. The CT scans, MRI scans, brain scans, or the blood test to see the complete past medical history of the patient. So medical images, because images, CT scans, MRI scans, or whatever scans, ultrasound scans, those images take a lot of space and they have to be archived somewhere. So if there's a comparison that need to be made after a few months, then in case of emergencies or urgencies, those images need to be retrieved much faster. News media assets, news media companies, basically they have to store their videos, their photographs, because when there's an urgent need, they have to retrieve those images, and maybe they have to publish some new news articles, genomics data, research data, because in terms of research go for years and years, right? And if scientists have retrieved some data, some research papers which were archived maybe a year back, then they need that immediate access to make sure that the research is still being carried on without any delays. E-papers. So basically the things that if you have any requirement of any data which needs to be archived, but in case of emergency or in case of urgency, you get the immediate access to it. You store it as the Glacier instant retrieval. Okay. What's the next thing? So this is what we have discussed. Then we have Glacier flexible retrieval. Now this is a lower storage cost option to back up your data, where you get some flexible retrieval options, maybe expedited, maybe bulk, maybe standard. So basically, low cost retrieval archive with low retrieval fee. It is suitable for that archive data which doesn't require immediate access. For that archive data which does not require immediate access, and it needs a flexibility to retrieve large data sets of data at no cost. There are 3 retrieval speeds that you get in flexible retrieval: expedited 1 to 5 minutes, standard 3 to 5 hours, bulk 12 hours. So you can set 3 retrieval speeds on your data if you have flexibility in terms of data storage. If you expedite, you can download the data in just 1 to 5 minutes time frame. If you go with the standard retrieval, it takes 3 to 5 hours. If you go for bulk retrieval, it will take you 12 hours to download the data back to your computer. So instant retrieval is cheaper option. Flexible retrieval is cheaper compared to instant retrieval. So flexible retrieval will give you 3 retrieval speeds. Okay. Use cases: backup, disaster recovery, offset data storage needs, and some data that may be occasionally retrieved in minutes. And you don't have to worry about costs. Okay. Last option that we have in terms of storage class is deep archive. What is deep archive? Deep archive is used in those cases when your data needs to be stored for many years to come, many years, right? So Glacier Deep Archive is used in those cases when your data is being stored for multiple years. The organizations like public sectors, health insurance organizations, medical insurances, or financial bank services, the banking organizations, they use Glacier Deep Archive. For example, I have my account in Citibank. I contact Citibank saying, I want to get my credit card statement or my transaction statement for year, let's suppose 2019. Now, if I go to Citibank website, I can only retrieve my statements in the past 1 year only. But I want to go back into 2019 and get the transactions from there. So Citibank will open a ticket with their IT services. IT services will go to their archive storage, get the data out of there into the front for the year 2019, 2020 financial year, and send me the transaction history. Right. So financial services, banking services, public health sectors, they have the obligation to store the customer's data for years to come. Okay, they can't say no to me saying that, okay, no sir, we can't provide you that, because this is their professional duty to make sure that our data is preserved with them, and we can always ask them for data which we have right to access whenever we want. So Glacier Deep Archive means that it's used for long-term digital preservation of the data that's being accessed once per year. It eliminates on-premises tape libraries, which is kind of now, I would say, obsolete now. It has 2 retrieval speeds: standard 12 hours, bulk 48 hours, right? So to download the data, you have to wait for at least 12 hours, half day. It is designed for lowest cost storage, designed for long-term data retention. If you want to retain the data for 7 to 10 years to come, right? So for example, financial services, healthcare, public sectors, they use the Glacier Deep Archive. I've gave the example of Citibank. Maybe you have some medical insurance, or maybe any long-term insurance with LIC or Star Health. So they have to keep your data for years to come, right? So in those cases when they have to put that data and store it for next 7 or 10 years, at least, then they will be going with the Glacier Deep Archive. Having said that, these are the different storage classes I've discussed with you. Okay. Now I was discussing that you can make use of S3 as a version control system, right? So you want to make sure that you can store multiple versions of the same file. Okay, let me show you that. If I go back to my, okay, let me just close this root account. It's getting confusion for me. See, right now, one thing you need to understand. If I go to my any bucket, let's suppose I upload some data to it. I add a file. I add a, let's suppose, a YAML file. Now it's a YAML document that I upload to it. Any file, right? Now you will see that if you see the timestamp, it says June 15, 2023, 8:51. This is the timestamp it has. Now, let's suppose I upload the same file again. I upload the same file again. By default, what it will do, it will overwrite the file. If I show you the timestamp, if I show you the timestamp, if you compare that with the previous timestamp, you will see that there's a difference. This is the new timestamp, and this is the previous timestamp. So why I pasted the timestamps for you? I pasted the timestamp for you to emphasize on a single important fact that by default, whenever you upload the same data again, the name of the object is same, and you upload the same file again, the previous file gets overwritten. Whether I make the changes to this file or not, it doesn't matter. If the file name is same, I upload the same file again and again, the previous file gets overwritten. Now this may not be what I want. I want to make sure that I can use a concept called versioning, where every new upload means that a new version is being generated. Okay, let's discuss that. So what is versioning? Let me discuss this thing with you. Versioning is basically, it helps you to keep multiple versions of the same object in one bucket. It has to be enabled explicitly, and the existing objects are not overwritten. So the purpose of the versioning is that you can store multiple versions of multiple variants of the same object. The existing objects are not overwritten, which means that it doesn't overwrite the previous data. Instead, it keeps multiple versions of it. Okay, so let me show you that. If I just go ahead and remove this data first, and let me just delete this data, just permanently delete it. Right. Okay, so how do I enable versioning? You will see that on the top, there's something called properties. If I go to properties, you will see that we have the bucket versioning enabled. I would say option showing up. I click on edit and choose enable and click on save changes. You will see that the bucket versioning is enabled now. Fine. Now I'll just go ahead and upload my file again. Now you will see this thing. I'll do one thing. I'll upload this file 4 or 5 times. Okay. So I will just go ahead and try to overwrite this file. See what happens. So I'm just trying to upload this file multiple times. Yeah, so this is the, I think, 4th time I'm uploading the data. I just do it one more time. Let me just upload it one more time. So I've uploaded the same data with the same name multiple times. Fine. Now, if I go to this object page right now, I can't see any change. But as soon as I click on show versions, I can see all the versions of these files uploaded. Whether I make the change or I don't make the change. I could also make the change. For example, I go to the same file again and I make some changes. Let's suppose I open this file. Let me just copy this file, put that in the desktop. Okay, let's imagine I open this file and I make some changes to the code. For example, I change certain aspects of this file over here, and okay, anyhow, I've just changed certain aspects of this file, and I just go ahead and upload the same file again. Okay, so I've made certain changes to the file and uploaded it again. Fine. Now, if I click on show versions, or I click on the object and click on the versions, you will see that the file has changed, and these are the versions of the file. So every new upload that I made, with or without the changes, if the file name is same, the previous file was not overwritten. This is what, as a developer, I want. As a developer, I need to make sure that I can store multiple versions of the same file. As a developer, I want to store multiple versions of the same file. Now, these are the version IDs. These are generated for every version. These are auto-generated. And every version ID has a corresponding timestamp. Can you see that? Now, based on the timestamp, I can see, okay, I want to retrieve the file to the older version or from the previous version based on the previous state. So I can click on any one of these version IDs and get the data. For example, I click on this version ID and download the data from this version. Now, the question that comes in, why a company will, or my developer will store multiple versions of the same file? So think from developer point of view. Let's imagine you're making some changes to the file and you're pushing those changes to the production, right? You're making changes to the file and you're pushing the file into production. Let's imagine after changing certain aspects of the file or your software or your code or artifacts, you started facing some production issues. You released a new software by changing the code, the backend code, and after you push those changes, those new changes, by updating those files, you're starting facing some serious production issues. Now, what is the common approach? You go back to the previous version, push that previous version in the meantime to fix that issue, and then you start finding bugs with your new code. You roll back, right? You have to roll back to the previous version. It's a very common thing, right? Sometimes we make some new changes. It's unprecedented, or I would say you can't. Sometimes even you do a lot of testing. Sometimes out of blues, some production issues start happening after you make the changes to the code. So in that case, you have to quickly retrieve back to the previous version of the file, and you push it. In the meantime, you start finding bugs with your or issues with your new file. Maybe you have put some incorrect entries. You have to rectify them. Again, put that into test and then push it. So it is quite important that in those cases, in those events, you have to retrieve the previous version of the file. But there's one downside of the versioning. Versioning will eventually bump up or accentuate or increase your storage cost, because every version takes its own space. Okay, so imagine, say right now I'm talking about only 178 or 175 bytes of data. Imagine your business generates 5 GB of data every day, right? And there are 2 versions on an average per GB generated. 2 versions per GB. So on daily basis, your business is generating 5 GB of data, and you're generating 2 versions per GB. So that 5 GB becomes 10 GB, double the amount. And you multiply by 30 days in a month, it comes out to be 300 GB, right? I'm taking a very minimal use case. Generally, businesses generate a lot of data on daily basis, 10 GB, 20 GB. So if you have multiple versions generated per GB on daily basis, then in that case, it will automatically increase your storage cost. So versioning, though, even though it's a wonderful feature, it is used by developers a lot, but it can increase the storage cost to a very high level. Okay. Now, once you open this document is basically this is based on the hands-on, or this is based on the idea that how you can host a static website on an Amazon S3 bucket. When I discuss with you the basic functionalities of the use cases of S3, I also pointed out that S3 is also used for static website hosting, right? So it is also used for static website hosting purpose, and This means that without any running a server-side script, you can deploy a static website on an Amazon S3 bucket. So in this case, we will be just creating a new bucket from beginning, because when you make a new bucket, there are a few options that you have to select or deselect. Explaining those options, and thereafter we will just go ahead and enable the website hosting, upload the index.html document, make it public, test our website. Okay. Let's get started with the first step, which is creating a bucket. Now, you must have the buckets created, but I want you to create a new bucket from beginning, because this is where you have to enable some options which you haven't gone through before, which are new for us. I'll discuss with you some of the permissions that you need to enforce, because we haven't discussed permissions, but now I'll just help you to understand that how the permissions of these buckets really function, how you apply the permissions for these buckets. Okay, so having said that, I just go back to the S3 dashboard. So you have to go to the S3 dashboard, and you have to create a bucket. I'll give you the standard naming convention that you can. I would say that because later on, once we discuss the replication process, we need 2 buckets. Okay, so when you click on create bucket, what you can do is you can put a name. I can just give you the format of the name. For example, let's type in Rohan, because the bucket name should be unique in nature. So I'm just putting my name to have that uniqueness in the bucket name. Intel S3 bucket. Now, whatever region you are using, right, put the name of the region at the end of it. For example, in the short form, I'm going to type in VIR. Okay. Why I'm saying, why I'm asking you to put VIR at the end of it. Okay, what you can do is that don't put VIR, put source. Okay, I'll let you know exactly when once we start discussing the concept of replication. One is a source bucket, other one's a destination bucket. As if now use this format. The name should be your first name, last name, hyphen Intel, hyphen S3 bucket, right? And then put source at the end of it. The lab that we'll be doing next will be using these names. Okay, I'll let you know exactly why I'm. Once you start doing that lab, you'll understand why I'm asking to put source at the end of it. Okay, using this format, enter your bucket name. Let me know once you're done. First name and your last name combined, hyphen Intel, hyphen S3 bucket, hyphen source. Make sure that you put source at the end of it. That's important. If you don't want to put your first name and last name combined, you can just put your last name or only first name, but make sure the bucket name should have source at the end of it. Because later on the lab that we'll be performing will need to identify between 2 buckets. One is source bucket, other one is the destination bucket. Hosting a static website. Now region name is not required. Just go with this format. Don't put the region name. Just put your first name and last name, hyphen Intel, hyphen S3 bucket, hyphen source. That's it. Don't put the name. We are doing this hands-on on hosting a static website using Amazon S3 bucket, right? And we are in the process of performing the first 7 steps, steps 1 to 7. The document has been put in the chat, and this document is also within the S3 folder of Google Drive. I'm going to copy and paste the link. The name of the document is hosting a static website using an Amazon S3 bucket.docx. You have to follow this document. And based on the document, you have to enter the bucket name. This is the format that you have to pick up. You have to pick. So this should be the format of the bucket name, which is first name, last name, hyphen Intel, hyphen S3 bucket, hyphen source. You have to put source at the end of it. That's important. What's the next thing? The next thing is that you don't have to change the region, state in whatever region you're right now. So it doesn't matter which region you choose. The region could be anything. So there's no need to work upon the region. Let's come to the next thing, which is object ownership. Now, this thing needs to be changed. See, whenever you apply the permissions have to be applied at two levels. I'm talking about the S3 service. When you start applying the permissions for S3, there are the two levels at which you can apply the permissions. Number one, the permissions can be applied at the bucket level, and number two, at the object level. Already gone through the IAM policy demonstration, the customized policy, where we apply the permissions at the bucket level and at the object level. Now, this object ownership is kind of applying the permissions at the object level. By default, the objects that we upload to the S3 bucket are private in nature. Private means that only you as a bucket owner can access it, and you can change basically that object is not visible on the internet, or it remains private. Now, we want to have the capability or earn the privilege to make that object public. Let's suppose I have 10 objects private, 10 private objects. Out of those 10 private objects, I want to make 5 of them public. Public means I can create shareable links, and by clicking on those links, or I can include those links in my code, the users can access my those 5 objects. For example, this Google Drive link that I given to you, what is this? This is a shareable link. This is not private, right? Similarly, I can create shareable links of my objects, include that in my application code, or I can share those links directly and make my objects public. Now, ACL stands for access control list. You have to enable ACL and gain the ownership of the object, so that being an owner, once you gain the ownership, then later on you can change the permissions of the object. From private, you can make them as public, or from public you can make them as private. Basically, you gain the authority and the privilege to change the permissions of object. So how to gain that privilege or that authority? Just go to ACS enabled, click on ACS enabled, and make sure that you have chosen the bucket owner preferred, which means that you're the bucket owner. You created the bucket. This bucket resides in your account. Being a bucket owner, you're taking the full ownership of the objects now, and afterwards you will have the privilege to change the permissions of those objects. You can change their default accessibility from private to public, or vice versa. So go to ACS enabled, enable the access control list, and choose bucket owner preferred in object ownership, so that you claim the ownership of these objects and you gain the rights to change their permissions. What's next? This is where you gain the rights to change the permissions at the object level afterwards, once the bucket is created. Now let's work on the bucket permissions, right? By default, the bucket is private, which means that you cannot make the portion of the bucket public in nature. Now, in this case, you have to uncheck this option, block all public access, and choose acknowledge that I'm making this thing, and this might result in this bucket and the objects public. You have to uncheck this option and choose acknowledge. Now, why I want to make the object in the bucket or the entire bucket public in nature? Because we are going for static website hosting, right? We cannot host a public website unless and until if you don't change the setting, right? Please go ahead and do that. Now, this does not mean that your bucket becomes public in nature, because you have to make certain objects public afterwards. But right now at the bucket level, you also are kind of claiming the ownership that at the bucket level, I want to do certain operations which can make the entire bucket or some of its objects or all the objects public in nature. So you have to unblock public access, block all public access, so that you can host a static website. And you have to just give your consent. This is kind of a forewarning that turning off the block all public access might result in this bucket and objects within becoming public. That's okay. Amazon just wants to notify you that you're doing this thing. What is the consequence of this thing, right? So it doesn't mean that you're putting your bucket and objects to security threat, but it's a forewarning to ensure that if anything that is very confidential to your organization, you don't unintentionally expose it to the public. So that's the security warning. That's it. It's nothing that we're doing out of recommendation or out of best practice. Because if you're going for website hosting, these settings need to be unchecked. Okay, now what's the next thing? The next thing is that you have to go to the bucket, and there in the documentation, please enable the versioning. Because later on, we'll be doing some lifecycle management configuration. So the lab on that one, please enable the versioning. Let me know once you're done. This is not there in the document, but this is an add-on from my side. Please click on enable and enable the versioning. So I reiterate what you were supposed to do. You were supposed to put a standard bucket name format. Have you already given to you what format you have to pick? Make sure that you put source at the end of it. Okay, so we picked a bucket name. No need to change the region. We enable the access control list and we claim the bucket ownership so that later on we can change the object permissions. Then we just went ahead and we unchecked block all public access, so that the reason being we want to make sure that we can host a static website upon this bucket. Fine, this is what we did. And thereafter, I ask you to enable the versioning. You don't have to go for tagging. As if now we don't have to discuss encryption, we'll just discuss it as a separate topic. You don't have to change any of the advanced settings. Okay. After enable versioning, straight away click on create bucket. Let me know once your bucket is created. Please click on create bucket. Now, once this bucket is created, the next thing is that we have to enable a property which is static website hosting. Static website hosting is a property, right, which has to be enabled. So how to enable that property? Let me show you that. To enable that property, I'll let you know exactly what the steps are. You have to enable the website hosting, that property that you have to enable. Step number from 8, and I just take you up to 8 to 14. Steps 8 to 14. Okay. Now, in this case, you have to click on the bucket, right? Once you click on the bucket, you will see that on the top, you have certain options to navigate. Now, the option that we're looking for is permissions. Okay, click on permissions. You click on the bucket. On the top, there is a layer of different options out. You have to go to the third option from left, which is permissions. Objects, properties, and permissions. Once you click on the permissions, you will come to this page. It's not permissions, we already have changed. Actually, I thought that we have to unblock public access. You have to go to properties. You have to go to properties. Permissions we already have applied when we made the bucket. You have to go to properties. The option from this, from the second option from the left. Once you go to properties, you have to go straight at the end of the bucket, right? You'll find out there's a under property, you have this thing called static website hosting. Fine. So what you have is that under static website hosting, click on edit and choose enable, right? So once you click on edit and choose enable, what it says, static website hosting enable, hosting type, host a static website. Make sure that you have, please make sure that once you have made these two selections, go to properties, no permissions, it was taken. You have to go to the left-hand side of the permissions, that's properties. Navigate to the bottom most, you see the static website hosting option. You have to click on edit. You have to enable the static website hosting, and the type of hosting that we're going for is host a static website. What is the second option all about? Redirect request of an object, which we are not doing, but I want to explain you. So sometimes what happens is that if you're going for a static website hosting, you can redirect your access. So for example, this is your first bucket. Let's suppose I have this bucket 1, and this is my bucket 2. Let me just create a different bucket. This is my second bucket, right? So I just go ahead and create a second bucket. Now, redirect request means that if users try to access my first bucket, that first bucket will redirect that request for the website access to the second bucket. Sometimes you might have seen this thing whenever you just go to a domain, that domain is for example, xyz.com, whatever domain you type in, sometimes you're being redirected to a second domain name, right? So similarly, redirecting request to another bucket or domain means that when you try to send a request to a specific bucket, you can redirect its request to the second bucket. That's an optional behavior, or that's an option that you can have. Sometimes you want to discontinue the first bucket. In the meantime, you want to redirect the request, whatever the reason could be. But this is a feature that we can use. So any request for accessing the website is going to the first bucket can be simply redirected to the second bucket, right? So this is not jump server is, you can say that. So this is what the redirection means, which we're not going for, which is not applicable in our use case. We're just going to host a simple static website. Now let's come to the 2 main pages. So if you configure the home page of any website, the default home page is index.html. Now you have to type in index.html in the index document. Now make sure that everything is in lowercase because it is case sensitive. I've seen some people just type in uppercase I. So make sure that it is lowercase only. It is case sensitive. Don't put uppercase or caps I. Everything should be in lowercase. Put index.html in the indexed document option. Just type in terms of this. Okay, what's the next thing? The next thing that you're supposed to do is that edit document is optional. Edit document can be configured, for example, if you want to configure a 404 page not found. Sometimes you're trying to access any page. For example, if I just go to aws.amazon.com, aws.amazon.com, and I put a / my first name, right? So it will return me 404 page not found, something like that, right? If I try to look for any page on aws.amazon.com/Rohan, which doesn't exist, it says, sorry, this URL doesn't exist, no longer available, perhaps looking for something else. This is the error pages you can configure, right? Which we're not doing as of now. We're going to skip it. It's optional. Redirection, because we're not doing any redirection, so we don't have to configure the redirection rules in this case. So once you configure the index.html document, that's more than sufficient as of now. Click on Save Changes. And once you click on Save Changes, again, scroll down to the properties, and you will see that this domain is generated. This is called bucket website endpoint, which is not functioning as of now because we haven't uploaded index.html page. But just for the sake of navigating and see that it's been enabled, you can just scroll down to the properties and see that the bucket website endpoint is generated. Click on Save Changes. You'll be back to the properties page. Scroll down to the bottom. Ensure and confirm that the bucket website endpoint is generated. Now this endpoint will not lead to anywhere because you haven't configured the index.html page. Just type it down, once you're done with this. Now what's next? The next thing is that you have to configure an index.html document. It is step number 15. Now I've already have added an index.html document for you in the Google Drive. If you go to the S3 folder, you will see the index.html is already configured for you. I will also give this index.html document to you. Done. Okay, what's next? The next thing that you have to do is that if you just go back to the document, let me just go back to the document now. I'll show you step number 16 and 16 to 21. So right now, you have to go back to the bucket, right? You're still on the properties. On the properties, you have the objects. You have to click on the objects, and you have to upload the same index.html file that you just got downloaded. Okay, click on upload, click on add files, add the index.html file that you just saved on your local computer, right? Just add the file. Don't upload it right now. Later on, you have to change its permissions before uploading. But as of now, go ahead and add the file. Don't upload it as of now. Click on upload and add this file. Let me know what's done with this. You have to go to the objects, click upload, and only add the file. Don't upload it completely as of now. I'll let you know you have to change its permissions first. Once you upload it, go to permissions and choose grant public read access. Once you add the file, before you hit upload, there's an option that says grant public read access. And then you have to give your consent that I understand the risk that I'm doing this thing. I'm making this public. That's okay. It's a forewarning. It's a security warning, but it is nothing that we're doing out of recommendation. You have to go to grant public read access, and you have to check or give your consent that yes, you're doing it with full intention. Now, once you have done this thing, you have to finally click on upload. So basically, you have to make the object public before you need to upload it. So basically, you have to change its permissions. You have to change its permissions to ensure that this index.html file is publicly accessible. Are we done with this? Now what's next? There's a close button on the top, on the right-hand side. There's a close option. You have to click on close so that you exit from this uploading page, right? You'll be back to the objects page now. Once you click on close, you'll be back to the objects page. Now, the next thing is that you have to test your website. So step 22 to 25. Now, what you have to do is you need to go to properties again, the option which is right to the objects, the second option from the left. You have to go to the bottom most where you configure the static website hosting. Now you have to click on the bucket website endpoint. Click on it, and now your page will show up. This is a public link. If you share this link with any other user or any other person, he or she will be able to see the same website. Please go ahead and do that. Done. So this completes the hands-on. Don't delete the bucket as of now, because the next part of the document is asking you to delete the bucket. This is just for the cleanup process. Right now, don't remove any of the buckets or its objects. Again, steps are not important. Concepts are important. I explained you the concepts of permissions, how to apply the permissions at the object level and at the bucket level. What is the concept of static website hosting, redirecting requests, right? Those things are important. For the next lab, that's called lifecycle management. Now, what is lifecycle management? If you remember, we discussed the concept of versioning, right? We discussed that concept. And when I discussed with you the concept of versioning, there's one thing I pointed out was that when you check the multiple versions, okay, for example, let me just see the bucket that I've created. Yeah. So I discussed with you the benefits of or the advantage of the versioning, that you can maintain multiple versions of the same object and the objects are not overwritten. This feature is primarily used by developers who want to use a code repository or artifact repository, and they can maintain multiple versions of the code. They can track those changes. The downside of this versioning is that because every upload, when you upload the same file again and again, with or without the changes, it will take the space inside the bucket. So this will eventually shoot up your storage cost. Okay, this is the downside I discussed with you. Now, the storage cost is directly proportional to which storage class it belongs to. Which storage class it belongs to, right? We discussed storage classes. Standard is the default and the costliest. Standard is the default and the costliest storage class, right? Now we want that we use versioning. Let's suppose I'm a I work in a developer team, and as a part of development team, it is mandatory for us to use versioning. But at the same time, our management has put strict budget restrictions on us, and we cannot consume the storage up to beyond a certain limit. So our storage expenses should be within the budget. Lifecycle management ensures that you put your objects into a cycle, a life cycle, and after a gap of few days, it slowly and gradually transitions itself to the storage class which are cheaper. And also the objects can be deleted from your buckets permanently, right? So when you put your objects into a life cycle, they will be automatically changed to a cheaper storage class, a lower cost storage class, and they can be removed permanently from the bucket. Now, when you apply the lifecycle management, it's being categorized into two different categories. One is the current version. Current is the latest, most recent. This is the latest. This is the latest or most recent. And the one which were uploaded prior to this one, these are the previous versions or non-current. These are non-current or previous versions. Previous versions. These are the non-current or previous versions, right? So there are two categories of versions. The latest, the most recent is the current, and the versions that are prior to that are non-current, right? Now, the lab that we're going to do, basically, it will target the non-current versions. I want to make sure that after a gap of few days, these non-current versions are being changed to a cheaper storage class. For example, standard IA or one zone IA. And after a gap of, for example, 180 days or 150 days, they are being removed from a bucket on permanently basis. So I will transition these previous versions to cheaper storage classes. And then after a gap of few days, they are being removed or deleted from a bucket permanently, right? This is what you're going to be doing. Now, I've already jotted down the requirements of this simple exercise. It's very simple. I can guarantee that you can do it very in a very less time frame. It's not a configuration which requires a lot of thought process or a lot of clicks, right? Simple process. So what you have to do is that you have to go back to your bucket, the same bucket that you create in which you enable the static website hosting, and then you have to go to management. Under management, you go to life cycle. You'll see that there will be life cycle rules. Please go ahead, go to the bucket, click on the management, and look for life cycle rules. You have to go to the management. Just beneath the management, there's something called life cycle rules. Let me know once you have reached that place. You have to go to the management, and you have to go to lifecycle rules. Okay, once you're there, you have to click on create lifecycle rule. So you have to create a rule based on which you want to recycle or put your objects into a life cycle in a simple process through which they can be transitioned to lower cost storage classes, and then they can be removed from your bucket if you want. You have to enter the rule name. For example, name it as test life cycle rule. Okay, enter a name. Let me know what's done. You can put any name. There's no any naming convention that you have to go for. You can choose the same name. Just type in done. Okay, now what's the next thing? Next thing is that choose a rule scope. I explain you this thing. It says limit the scope of this rule using one or more filters. That's a default one. It says that do you want to limit the scope of this life cycle? For example, I enter a prefix, let's imagine .png. This means that it will only recycle or put the PNG images in the life cycle. It will be applied to only .png images, or I put, for example, .mp3 or .avi. So I can explicitly select that there's only these files with these extensions of this format will be targeted. I can limit the scope of this rule. But right now, we'll not do that. We'll choose this option, apply to all the objects in this bucket, and give you consent. So you're saying it doesn't matter whether it is an AVI video, an MP3 video, an MP3 song, MP4 video, JPEG, PNG images, PDF, spreadsheet, whatever the format of the file is, I want to apply to all the objects. I'm saying that it doesn't matter whether I apply it to PDF, PNG, JPEG, AVI, MP3, or document, PPT, whatever the format of the file is, the extension of the file is, I want to apply to all the objects of this bucket. What's next? Now, you have to go to Lifecycle rule actions. Based on the problem statement, we need to be targeting non-current versions. Non-current means the versions before current, previous versions. You have to select these. So you have 5 checkboxes. You have to choose the second checkbox, move the non-current of the objects between storage classes, and 4th checkbox which says permanently delete the non-current versions. So basically, you have to check these options. I'm saying I want to apply the life cycle to these options. Check and permanently delete the non-current versions. You have to check both options. Please go ahead and check these options, 2nd and 4th. Basically, whichever option has the non-current inside it, move non-current versions of the objects between different storage classes, permanently delete the non-current versions. Basically, this is the 2nd tick and the 4th tick. I'm saying I want to move the previous version of the objects between different storage classes, the non-current versions, and also I need to remove them permanently from my bucket. So basically, the thing is, you have to check. This is the 2nd checkbox, and this is the 4th checkbox. Please go ahead and check these 2 options. Whichever options has a non-current inside it, you have to check it and explain exactly why we did so. Now, based on these 2 different actions that we applied, we'll be start measuring the days, the number of days, and what would be the process to transition. The 5th option is for multi-part upload, which we're not doing it right now. This is basically, it doesn't apply to any of the current or non-current. Multi-part upload means that if you try to upload something and it doesn't get uploaded properly, multi-part upload is a concept where a large file is broken into multiple chunks and uploaded to the S3 bucket. Now, if that process is stopped in between, then there are few chunk of the files which show up in the bucket. So I'm saying that any incomplete upload needs to be removed. So that doesn't apply to the non-current or current. I'm saying that if I'm trying to upload something and the complete file is not uploaded, then remove the remains of it. Right? Now, what's the next thing? Now, based on the requirement that I have proposed or I have mentioned, these are requirements. Requirement number 1: the non-current versions of the objects should be transitioned to standard IA after a gap of 30 days. By default, standard is selected for every object, which is the cost list. Standard IA, as we discussed, is used for infrequent access objects, which is a cheaper version of standard. So I will put 30 days over here. Okay, so what you have to do is that make sure the storage class is chosen as standard. So under the transition non-current version of the objects between different storage classes, the first rule that you have to choose is choose the storage class to standard after a gap of 30 days. So I have to put 30 in the box. Now, if you put 29, it will throw an error message. Let me show you that. If you put, let's suppose if you put 29 over here, it says minimum of 30 days is required. Can you see that? Minimum of 30 days is required before you can transition to standard IA. So there's a gap that you have to give. So we'll go for minimum 30 days gap. So I'm saying my objects will be saved as standard by default. After a gap of 30 days, they should be changed to standard IA, the previous versions, the non-current, so that I can reduce their cost. Go ahead and do that. You don't have to go for the third box number of newer versions to retain. That's useless as of now. Go ahead and do that. Done. Okay. So it helps us to fulfill the first requirement. The non-current versions of the object should be transitioned to standard IA after a gap of 30 days. Now, I need to move the non-current versions to one zone IA after a gap of 30 days. So can you see that there's an option which says add transition, right? You have to click on add transition. In the drop-down menu, choose one zone IA. Now, one zone IA is again cheaper than standard IA. We're going standard is the cost is standard IA is cheaper. One zone IA is comparatively more cheaper to standard. So we are going to the lower bottom to further reduce the price. So you have to put 90 days as gap. Please go ahead and do that. Let me know what's done with this. You have to click on add transition, choose a storage class as one zone IA, and the number of days is 90 days. Just type in done once you're done with this. Now, as a challenge, you have to do the third. So this is the second step we have done. As a challenge, you have to do the third one by yourself. I'll show you the solution. You have to click on add transition, and you have to perform this third one by yourself. Do it on your own. Let me know what's done. I'll show you the solution. I'm not running away from showing you the exact solution of it, but use the same method. Do it on your own. You have to further move it to the cheapest storage class, which is a Glacier Deep Archive, which has a maximum retention period of 7 to 10 years. I would say which has the average retention period of 7 to 10 years. Glacier Deep Archive is used by financial services, health sectors, insurance companies. They have to retain the data for years to come. It takes 12 to 48 hours to retain the data, but Glacier Deep Archive is the cheapest of all the storage classes. So I want to say that after a gap of 120 days, so from day 0 to day 120, on day 120, the data, which is the previous version of the data, should be transitioned, should be changed to the cheapest option, which is the Glacier Deep Archive. Do it on your own. So I just click on add transition, choose Glacier Deep Archive, right? And put 120 days. So I'm saying on day 120, any data which is in the previous version category or the non-current version category should be transitioned to Glacier Deep Archive, which is the cheapest of all the storages. Now, for Glacier Deep Archive, for data which is small in size, there could be some cost involved. You can choose I acknowledge that it is a one-time life cycle. Now, this is not applicable to us because we're not going for day 120. Okay, this is not applicable for us. So just choose it. I acknowledge that there could be a one-time cost imposed upon me if I start transitioning smaller objects. Right, the cost is very negligible in sense. Just check this option. So I'm saying on date, so we start from standard. On day 30, it becomes standardized storage class. Day 90 was Zone IA, and day 120 Glacier Deep Archive. We are further going down and down and reducing the prices, the cost of our storage, especially that data which is the non-current. Fine, and we give a consent that if we start transitioning very small amounts of data, which is less in size, we could be incurring a one-time life cycle request cost for that, which is not applicable to us because we're going to be removing this rule afterwards. Right? Done. What's next? The next thing is that now we want these non-current version of the objects to be removed from the bucket by retaining the 5 latest one. In the number of days, you have to put in 150. And there's a box which says number of new versions to retain. Optional, you have to put 5. Now you say, what is this number 5? below. So first thing first, please configure this thing right now. Now, if you see over here, what it's saying is there's a chart that it says, there's a chart over here. It's review transition expiration actions. You can see this chart. It will show on your page. So on this, based on this chart, what it says is that on day 0, an object becomes non-current. On day 30, it's moved to standard IA. On day 90, it's moved to one zone IA. On day 120, it's moved to Glacier Deep Archive. Okay. Now you see that it says 0 newest non-current versions are retained. You're saying that I'm not. You also have the option to retain the versions to the same classes. For example, let's suppose if we didn't go for that option, but I'm saying that let's suppose on day 30 I choose the latest non-current versions and keep them in standard. So I haven't done that. So I'm saying on day 30, move it to standard, move all the objects non-current to standard. Day 90, one zone IA, day 120, Glacier Deep Archive. On day 150, 5 newest non-current versions are retained, newest, and all other non-current versions are permanently deleted. All other non-current versions are permanently deleted. So what I mean by that, you just go ahead and click on create rule and the rule gets created. Created the rule. And this is auto transition only. This is automatically transitioning your files. This is automation only. Now what you can do is that you don't need this rule anymore. Choose a rule and there's an option called delete. Click on delete, right? Choose a rule, click on delete. It says delete lifecycle rule, click on delete. Just remove it, you don't need this anymore now, okay? Please go ahead and do that. You have to go to day 3 version and click on it and retain that data, right? So for example, if I go to my bucket right now, if I go to my this bucket, right? So based on the timestamp, I can go to any of the dates on day 3. I can click on that specific. So based on the timestamp, you can click on that specific version ID and you click on download and you can retain the data from there. Whichever day or date based on the timestamp you think your file was absolutely perfect, in perfect state, you can go to the versions of that file and you can see the timestamp, and based on that you can click on that specific version ID. Click on that version ID and then click on download. That's how you can retain it. Next thing, replication lab. Now what you have to do next is, now what we're going to do next is that we have to understand replication. What is replication? Replication means that you want to enable the replication between 2 buckets, which means that if you put something inside the first bucket, that same data gets, I would say, a copy of that data is generated and saved in the destination bucket. Okay. Now the prerequisite for this exercise that you have to have 2 buckets in 2 separate regions. What you have to do is that first thing first, please go to the buckets dashboard, right? And this is your, so basically you choose the name of the bucket, right? What you have to do is that you have to enter the same bucket name, but the second bucket that you're going to create would have the, I would say, would have the prefix as DEST. DEST stands for destination. Okay, so the bucket name should be the same, but in the previous bucket you put prefix as source, but this time the prefix should be DEST, right? So what you have to do is that initiate the process to create a bucket, put the bucket name as it is, copy and paste it, just replace it, the source, with DEST. So right now we are trying to do the next hands-on, which is replication, cross-region application. Just put it DEST at the end of it. Let me know now with this. And this time you have to choose a different region, right? You can choose, for example, so I would say with respect to the previous bucket, this bucket should be in a different region. this bucket should be in a different region. For example, I choose Mumbai. My first bucket is in North Virginia, the source bucket. The destination bucket, I'm just going to create that in Mumbai. So put DEST at the end of this bucket, remove source, and choose a separate region this time. Because we're going for cross-region application. The buckets are in separate regions and we want to replicate the content between them. Now, in this case, you don't have to disable or enable object ownership or block all public access because we're not using this bucket for static website hosting. Okay, don't have to do any one of those settings. But yes, you have to straight away go down and enable bucket versioning. Now, as a prerequisite for this replication, both the buckets should have the versioning enabled. The source bucket already has the versioning enabled. The destination bucket should also have to have the versioning enabled. So as a prerequisite, if you're enabling the replication between two buckets, the main prerequisite is that the versioning should be enabled on both of them. Please go ahead and enable the versioning, right? So basically, in the second bucket that you just going to create right now, you have to make sure that you put DEST at the end of it, remove source. So DEST stands for destination as a prefix. You choose a different region for this bucket, right? And you have to straight away, you don't have to change object ownership or block or public access, nothing is required. You have to enable the versioning, that's it. Fine. Once you have performed these three changes, straight away click on create bucket. Let me know what's done. Okay. Now, why did I ask you to put separate names for these buckets? Because so that you can easily differentiate. Our intention is that if I put any data in the source bucket, a copy of that data is produced automatically and saved in the destination bucket. So it is unidirectional in this case, from source to destination. Now, the versioning has to be enabled on source bucket. Fine. So you can see that two buckets right now, one with the prefix source, other one with the prefix as DEST, which stands for destination. You have to click on source bucket and then go to management. You have to click on the source bucket and go to management, the same option where you configure the lifecycle rules. You have to click on the source bucket and just go to the management. Okay. Once you go over there, once you just go to the source bucket and go to the management, under lifecycle rules, there's something called replication rules. It's set to 0. There's no replication rule created. Click on create replication rule and let me know what's on this page. Once you're on this replication rule configuration, put a rule name. For example, just type in test replication rule. It is a simple name. Even if you put in your first name, it will accept it. Right. So there's no any rules applied to that. What should be the name of it? Put a name, enter a rule name. Let me know once you're done with this thing. Now the status is enabled. Now it will show you the source bucket details. So it says source bucket name. Right. This shows the source bucket name, which means that the application will start from source. Source region. Right. Now it says that you want to limit the scope of that application. For example, if I apply a filter like prefix like .jpg, so only the JPG images will be replicated. But in this case, we'll choose apply to all the objects. Right. So please go ahead and under the rule scope, make sure that you choose apply to all the objects in the bucket. Please go ahead and do that. Just type in done once you're done with this thing. So apply to all the objects in the bucket means that it doesn't matter what's the extension of the file. It's a PDF, it's a PNG, it's a JPG, whatever the extension of the file is, it doesn't matter. I want to apply this rule to all the objects of master bucket, whatever the format of the file is or the file extension is. It can be an Excel sheet, it can be a PDF, a document, a PPT, a PNG image, JPEG image. It doesn't matter. Now it will ask you to choose the destination bucket. Now it says that choose a bucket in this account. Is the bucket is in this account, or specify a bucket in another account. You could now, this is a not applicable to us, but just an FYI. You can initiate the application between two buckets in two separate accounts as well. In that case, I have to specify the 12-digit root account ID and the bucket name in that root account. But in our case, we'll choose a bucket in this account only. Once we choose this thing, choose a bucket in this account, it says that, all right, so then browse for that bucket name, which is your destination bucket, right? So I click on browse S3 and I look for the bucket name, which ends with DEST, this one, and click on choose path. So basically you have to browse for the destination bucket under the destination box. So what I'm saying is that this is my source bucket, this is my destination bucket in the same account, right? But they're deployed in different regions. What's next? Now, in order to initiate this communication, an IAM role is needed. You go to IAM role and choose create new role. Now this will automatically create a new role so that all the necessary permissions are enabled at the backend, so that the source bucket contents can be replicated to the destination bucket. So it will automatically create a new role for you at the backend. Please go ahead and do that. Go to IAM role and just by default it's selected choose from existing IAM roles. Under IAM role, choose create a new role. Now, if you choose create a new role, it will automatically create a new role for you so that the source bucket has all the permissions to replicate its content to the destination bucket. Because this source bucket is trying to access the destination bucket. It's a bucket to bucket communication. So I'm applying this role so that the source bucket gets enough permissions, or we give enough permissions for this communication to happen. What's next? You don't have to go for encryption as if now. Destination storage class. So I'm saying that now this destination bucket is my secondary backup. I want to bring down its price. By default, my source bucket will have the standards data stored in the standard format. I want for this destination, I want a cheaper version. So under destination storage class, choose change the storage class for the replicated objects and choose one zone IA. Okay, so I'm saying choose destination storage class, change the storage class for the replicated objects and choose it to one zone IA. Now one zone IA is a cheaper option. Now it says minimum duration storage 30 days. Of course, after 30 days, you start getting billed from one zone IA, and one zone IA puts the data in just one availability zone. That's okay. This is our secondary backup. This will bring down the cost of our storage. So under the destination storage class, I'm saying change the storage class for the replicated objects and choose one zone IA. One zone IA is applicable in these cases only. One zone IA means that your data is put in just one availability zone. If that availability zone goes down, your entire data is lost. But that's okay because we have duplicate bucket, source bucket, which already has that content. For duplicate backups, we choose one zone IA, which is quite cheap. Then what's next? You don't have to go for additional application options and click on save. Let me know what's wrong with this. Now, once you click on save, you get this option, replicate existing objects. Let me know once you get this prompt. Now it's asking you, do you want to replicate the existing objects or you want to start from now onwards, right? So you have to choose no, I don't want to replicate existing objects. So from now onwards, if I put any new object inside my source bucket, that will show up in the destination bucket. I don't want to replicate the previous objects because for the previous objects or the existing objects, it will run a batch operation job, which takes a lot of time. So you have to choose no, do not replicate existing objects. I click on submit. Now we're going to be testing it out. To test it, you click on your source bucket. okay, and try to upload something, any file from a computer, be it any file. It's a simple text file, a Word document, a PDF file, whatever. Just choose a small file. You go to a source bucket, click on upload, add file, choose any of the files on a computer. It doesn't matter. I choose a simple file, add the file, and click on upload. So go ahead and upload a simple file to a source bucket. Go ahead and do that. Just type it down once you're done. Go to your source bucket and try to upload any simple file. Go to the objects, try to upload any simple file. It can be an image on a computer, it can be a simple text file, right? So destination bucket ends with DEST. Source bucket ends with SOURCE. So these two buckets should be different. By mistake, you're choosing the source bucket as a destination bucket. Now, once you upload any data to the source bucket, go to your bucket list and click on your destination bucket. And you will see that within few seconds, the same file will show up. The same file will show up, but this time its storage class would be one zone IAM, right? This is the businesses use this strategy for disaster recovery and data migration as well. So that if you lose any one of these two buckets or its contents, you still have one bucket to retain the data from. After within few seconds, you just click on it. There's a refresh button, right? You can see there's a refresh button. Hit refresh few times, it will show up. If the file is a bit larger, it can take some time. But if you hit refresh few times, it will show up. This is what the replication stuff is. Simple, fine. You understood the process of cross-region application. Now this is unidirectional from source to destination. This is not bi-directional from destination to source. If you want to configure bi-directional, then you have to configure you have to enable the configuration, another configuration on the destination bucket, while choosing the source bucket as the target bucket, right? So you can also have bi-directional, but this is the unidirectional application from source to destination. Whatever you put in the source will show up in the destination. Okay, fine. Now what you can do is that you don't need this application anymore. This is optional. You can go to management and you go to your bucket, go to your source, go to the management, choose an application rule and click on delete. Now there's no cost for that, but if you want, you can delete an application rule. Okay, that's it. Now I've listed down the process. Now the buckets are free of cost, but if you wish to remove the bucket, I've jotted down the process to delete the bucket in the document itself. Step number 6. But if you don't delete it, there's no cost for you. No, it is, see, the application it's only applicable to the uploading process, not deletion process. You understand the point? One thing we need to understand, the replication is only applicable to uploading data, not deleting of the data, right? So if we delete the contents in the source bucket after certain days, by default, they will still show up in the destination bucket. That's what the purpose of the application is. If by mistake, if you remove some of the files in the source bucket by mistake, and those files are very important for you, you can still recover the same files from the destination bucket, right? That's what the purpose of the application is. So if you remove the, by mistake, if you remove, let's suppose 10 important files from the source bucket by mistake, then you can recover the same files from the destination bucket. So this application applies to the uploading process only.
Just a quick info, guys. Intellipaat offers an advanced certification in cloud computing and DevOps by IAM Web. Through this course, you can learn all the important concepts of cloud computing, DevOps, AWS, Azure, Linux, and Python. The course features live classes with IIT faculty and industry experts, campus immersion at iHub IIT Roorkee, and includes certifications from both iHub IIT Roorkee and Microsoft. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials in our Achievers channel, whose link is given in the description below. With 24/7 support, placement assistance, and EMI payment options, this course without a doubt can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of cloud computing.